check. 1, 2. Test 1, 2. Check 1, 2. Testing 1, 2, 3. Check 1, 2. Testing 1, 2, 3. Can you go up to the podium?
Check. 1, 2, 3. 1, 2. Test 2. Check. 1, 2. 1, 2, 3, 4, 5, 7, 8, 9, 10. Check. Check streaming 1. Streaming 1, 2, 3. Okay. 1, 2. Check. 1, 2. Test 1, 2. Check 1, 2. Test. 1, 2. Check 1, 2. Hold your mic, handheld. Check 1, 2. 1, 2. Test 1, 2. 1. Test 1, 2. 1, 2. Test. Check. 1, 2. Test. 1, 2. Test 1, 2. Hey, test 1, 2. Check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2. Check. Right. 2. Check. Test. 2. Check. 1, 2. Test 1, 3, 4, 5, 9, 10. 1. Check.
5. 5. 5. Good.
Hello?
Right. I know. Let's put it together. Come on, guys. I am so happy we get to start. Welcome, everybody. Welcome. We're going to do quick intros for the MCs because there are 2 tracks. My name is Alyssa Nykel. I'm a developer advocate at Progress, an Angular GGE, and a lover of all nerdy things. So come hang out with me. Come talk to me.
My name is Phil Fulcher. I'm a longtime beloved engineer at NX. Nobody's denying it, so we're good.
I love you.
Thank you.
Yes, you are. We love us. I'm Katarina. I'm product advocate and engineer at NX, and I really like cats. So if you have cat pictures, come show them to me.
Or five cats, yes. I'm a hero at Hero Devs. I've been there for a little over 4 years. I'm an Angular GDE, and my first Monorepo conference. See all these smiling faces this morning, and hello to everybody online as well. Welcome, welcome. Happy to have you all here. And
Katarina.
Yes, let me take my notes because I think my amount. I'm not saying this because it's. So maybe we can cue the slide for code of conduct. Thank you. So before we start, we have very important for everyone here to feel safe. For you volunteers, other and conduct. So the quick version is side. Your own, but at 8 p.m. where we have our okay, so there may be a scavenger hunt in the museum.
Museum at night. That's exciting. But 8 p.m.?
Yeah.
Katarina dresses nice, like wherever she. Have a raffle going on. If we could get the slide up with the QR code so we can see, that's. Which is ironic because one of our giveaways today is going to be Lego strategy. Line. Refresh your keyboard game. For
From
So much. This is really exciting. Victor, one monitor, so you're going to have to wing it. Do you want me to stand next to you with it on my phone? And you can. This is really exciting to see everyone here and everyone on the live stream. This is the third year we've done an in-person conference. We started in Arizona in 2022, my hometown. And then we started, last year we did NXConf in New York City, which was a lot of fun. And this year, we're in Mountain View, California at the Computer History Museum. And I think it's appropriate because this is a historical day for monorepos. Just about community. But monorepos and scaling organizations is a lot more than that. So we've got a lot of folks represented here from different projects that you see here, different projects and services to make monorepos work. And also, again, thanks to our sponsors to work with you folks and to support what we want to do, especially to NX. Thank you, NX. NX is my employer. I'll say a few things about NX because they're year over year roughly. We just hit 5 million weekly downloads. It's early on, so it's pretty cool to see this much usage. And by our estimation, more than 75% of the Fortune 100 is and trust it to help their organizations scale. 22 or really doing hours. I'm not going to read the whole number, which equates to 1,056 developer years, like full-time developer years, based on them working 2,000 hours a year roughly. And this doesn't even include our enterprise customers. So our self-hosted customers saving 125K average per month or per year, sorry, on hours that are being saved. And this optimizations we make with distribution and everything else we're doing with NX Cloud. So this is really exciting for us. This is where we spend a lot of time. It's in all the efficiencies we're achieving. I'm going to welcome my esteemed Victor Safkin to the stage.
I don't need this. This should work. All right. No, the reason why I need speaker. Right? So the first story, right? Every year, every team at NX gathers together to do sort of a retro on a macro level, right? We did it a year ago in Toronto, right? To discuss what are the biggest issues the NX project is facing, right? We talked for hours, and after hours, we kind of concluded that the biggest problem we have is that we had two styles of repos. We have package-based repos and have integrated repos, right? The distinction is so core to how NX works that when you create a new empty workspace, you see this question, right? What kind of repo would you like? You want a package-based one or the integrated one, right? The package-based one essentially is like sort of NPM workspace on steroids, right? You get caching, you get task orchestration, but what the tool does, essentially, it looks at your workspace, finds all NPM scripts, doesn't make any assumptions about those scripts, just wraps them, right? and kind of enables caching like around them, right? You, the developer, have to configure everything though, right? The tool does very little, and therefore appears simple, right? But because it does little, someone has to do the work, right? And that someone is the developer, right? As a result, you have often kind of semi-broken DX. It's so semi-broken, well, it's manual configuration. What manual configuration means is suboptimal configuration or broken configuration, right? Because humans are not very good at maintaining stuff, right? Generally speaking. And what you see often is that folks who use this style of repos on the main branch will just keep the cache, for example, because things are just like not reliable. They don't trust it, right? So they want to use it. Every tool in the monorepo space, in the JavaScript monorepo space, has this style of monorepos, right? If you look around, they all do this. We ourselves do this, right? About 40% of NX users use this style of monorepo because it's just, you know, just very, very easy to set up, right? The other style is unique to us. It's unique to NX, and like what we give you essentially is a lot more integrated repo, where we make sure that every tool works together nicely in a monorepo context, because the monorepo reality is different, so the tools you normally use may not work in a monorepo context. So we adjust all of this stuff. We configure everything for you. We figure out how things relate by analyzing your source code. We give you a much better DX. It's also significantly faster, easier to maintain. It's all great, except that it's like a particular style of a repo. It's not a bad style of a repo. It's just a particular style of a repo, which means that if you start, for example, from scratch, you could use this style. That's fine. But if you choose to move towards a monorepo, right, and you have a different style already, because you're unlikely to implement exactly what we did, right, then you have a problem. Like moving an existing repo into this reality is very hard, right, or not possible sometimes, right? Generally speaking, it's fine. Developer does less. The build tool does more. That's a good thing. But it's hard to migrate to, and that's kind of the biggest problem we had, right? So in this style of repo, what we did, we create a lot of project.json files that you set the tools you use, right, into executors. So as you can see, instead of invoking TSC directly, we have like a wrapper around TSC, an executor, right? And that wrapper does a couple of things, right? You know, that's the model, right? The wrapper makes sure that, you know, the things are wired up correctly, that TSC is able to be used in a monorepo context, the caching works, et cetera, et cetera. So it does a lot, but you don't use executors yourself, right, in your repo if you don't use an X. And therefore, moving to this is kind of challenging. It was kind of the main complaint we heard over the years. Not a complaint, actually legitimate feedback. Complaint is a very negative thing. It's legitimately difficult to move from an existing NPM workspaces repo to this, right? It can take many, many months. So we thought about it, and we looked at editors we use. This is Cursor, but basically VS Code in disguise, right? Which is very nice. But you can look at IntelliJ, it doesn't matter. It's all the same. All of those editors also try to give you a rich developer experience, right? By using plugins, sort of like an X does. But the plugins in these editors kind of work a little bit better, right? If you try to, for example, edit Rust code in VS Code or whatever, and you have no Rust plugin installed, it still works, right? You can still edit the source code. You can still run commands in the terminal. The bare minimum is always there. It always works, right? You can install the Rust plugin, right, for example, which will give you like syntax highlighting, completion, profile, and debugging or whatever, and it's extra. It's very easy to install. It's effortless to install, right? And it's very easy to set up. You may point to a binary, but that's about it. It kind of works. And most importantly, the Rust plugin won't obscure Rust, right? It's not like you install the Rust plugin, suddenly you cannot interact with any of your tooling. No. The tooling is still there. The plugin gives you extra in a very kind of nice way, sort of like a butler, or like my dream stuff. Someone who can walk around, it just like it makes your life easier without asking much, right? This is what we want to have, right? So we looked at this and we thought, why don't we redesign our plugins to be like editor plugins, which everyone loves, right? Instead of being more opinionated, kind of harder to use plugins that are very valuable but not as easy to use. And but that's what we did. That's a repo, an X repo with a TypeScript library created a year ago, right? Very simple. With a project.json, there are targets. That's what a lot of folks know about an X. That they see this, they recognize it, right? And that's the same type of repo, right? There is a small repo with a TypeScript library in it. In this case, there is one library, but it could be 1,000 libraries. It actually doesn't matter. The configuration will be the same, but created like today, or like with Crystal. So as you can see, in an X.json, we installed the TypeScript plugin, or configured the TypeScript plugin, which looks at every tsconfig file in your repo and defines appropriate targets for them, right? And then you can look at all the targets defined for this project in your package.json file. And you can see all of them are there. And you can look at project details view to kind of figure out what's going on. You can see our npm script is over here. And that's our build target. You can see the command invoked. You can see all the inputs that goes into hashing, the outputs, dependencies, it's all here, right? So to summarize, right? Essentially, we have one file at the root, an exe.json, that configures all the plugins for your repo. And there is nothing else in this repo that is annex specific, no matter how big the repo is, right? In this case, the repo is small. It could be 1,000 times bigger. You will still have a single file at the root that configures your plugin. In a way, what happens in VS Code or whatever is the same, right? You can install a plugin to VS Code, and you can open a small repo. It will work the same way. You can open a massive repo with, say, 1,000 TypeScript projects. Your VS Code support for TypeScript won't require you to configure more, right? It's not like VS Code is going to tell you, tell me about all the files that goes into every TS program. No, the VS Code looks at your TS config files and figures it out, right? So we are doing the same now. That's kind of the idea. Instead of asking the developer to tell us, we can be like VS Code or IntelliJ or whatever, right? And we can figure it out for you. That's kind of the idea. So by doing so, we make the adoption much easier, right? And we get, the speed that people want. We maintain the configuration for you, we figure out all the dependencies, configure caching, distribution, it all works. However, there is a second component that I mentioned executors used to do, which is adapting your tools, your TypeScripts, Playwright, and Webpacks, and whatnot, right, to the realities of a monorepo, right? Because some of those tools just won't work. They won't know how to load the code. The type checking won't work. You need to do something about it, right? And the executors they lay around your tools used to do this. That was executors and the targets together, right? That was their responsibility. Within, we also had this utils layer, right? We often provided some utilities for jest and stuff so that you can use within your jest configuration to do the wiring, but you had to do both layers, right? And it was very powerful because the wrapping anything, generally speaking, gives you the most flexibility, right? Because then you are in control of the lifecycle, right? So we decided to change it around and move those responsibilities from executors within the utils, which requires some creativity because it's obviously harder to do that, all right? Because you have less control, all right? We were able to do it for all the popular technologies we support, all right? We kind of expanded the scope of what utils are meant to do to be the place that adapts your tools to the monorepo reality, and that place doesn't care about performance or speed. The layer around, the Crystal plugins care about that, right? So we did that, and there are two advantages we got from this picture. This picture doesn't look, it looks simpler. There are fewer circles or whatever. But fundamentally, there are two big advantages. Advantage number one, which is before, because we had the wrapping, right, around your tool, it meant that if we invoke your tool via an X, for example, let's say we invoke an end-to-end test runner via an X and would load something in an executor to make sure things work or pass the right configuration, create a temporary TS config in a secret place you don't know about, things like that, right? It's cool, it works, right? But then if you have your editor support, all right, and you want to invoke the same test via your IntelliJ plugin or VS Code plugin, that plugin doesn't know about an X. It would invoke the tool directly, all right? So now you have a mismatch. Using the tool via an X is no longer the same as using the tool directly, right? Which breaks lots of experiences you have in your editor and stuff, right? That's not very nice, right? This removes it, right? The Crystal plugins are transparent, see-through. You use the tool directly. You can copy the command you saw and run it, by hand, right? Meaning that all the integrations you have in the editor can do the same. They'll always work. They cannot not work, right? Except that caching is not there, obviously, etc., right? But generally speaking, we remove the delta, right, from using the tools directly and going, via an X. The delta is no longer there, right? Very nice. Oh, the other advantage. That advantage is actually more important. That's what happens when I don't have speaker notes. And that's one advantage. Editors work. I love integrated experience in general. That's good. The other advantage is stronger, all right? And the utils section you see in the middle is just out of our goodwill, right? We want to make sure monorepos work for you, so we build those kind of set of utilities, little plugins for your tools so they can be wired up. We actually don't care. The rest of an X doesn't care if you use those. It doesn't, right? So if you can remove those, you just replace with your own. Maybe you figured out on your own how to wire up, all your bundlers and TypeScript compilations and whatnot, right? Fantastic. Good news, we don't care, right? I would argue we most likely did a better job than you did because we spent a lot of time looking at it, right? You probably, at a particular org, didn't spend as much time looking at it, right? So most likely your solution is not as optimal, but it doesn't matter. Like, we don't care. We absolutely don't care what you use, right? Because we are, from the outside, simply invoking TSC or Playwright with the right configuration to run inputs and outputs, right? Which means that we can now add the rich NX experience, not the basic one that everyone does, but the rich one to any repo, caveat, to many repos, right? To almost any repo, reasonably easy, like much easier than before. Let me show you. So that's an example of a repo that's not unaxified, it's Tailwind, right? I can run an X in it. To ask some questions, it will recognize that it uses ESLint and Next. That's the plugin to support. We can select both. We can say yes. It will install the right plugins. And that's about it. The plugins are initialized. The Next.json is created with those plugins being in there. And then you can see the targets are defined. It's all configured correctly. The caching is there. Like it recognized all things and made them work well with an X, right, in a rich way, not by just wrapping NPM scripts, right? And that's kind of the core value proposition is that because we don't care what the repo does with its next config, it doesn't have to use anything written by us. We are like that butler, or whatever, the valet, right, who is on the outside helping out, like Jeeves, right, so to speak, right, making your life better, right, in a very painless way. Okay? So Crystal solved two problems that we tried to solve, right? That there was a new way of writing plugins. Firstly, we simplified onboarding into this powerful setup. Before that, we worked with many large organizations that had existing monorepos, the project that could move into an X in a rich way, not the package-based way, could have taken many months, right? You would create a new workspace, you would slowly move things over, etc., right? It was taking a long time, right? Because it was a very opinionated setup. Now, as you saw with Tailwind, it just works, right? And we removed two flavors. Anytime you see two of something, be suspicious, right? It's like, this is no good. One is better than two, right? In this case, with one flavor, it's more general. You can pick and choose what you want to pluginize, etc. It's just a better way of doing stuff, right? So we wanted to solve these problems, and we kind of solved these problems. It's good, successful effort on the engineering team. However, sometimes you have things happen to you, that are positive. I know, right? Most of the time, there's some technical problems that comes up, and it ruins your day. But sometimes nice things happen to you, right? So I want to tell you about two nice things that happened, right? Because it was very kind of surprising to us that we got a lot of other wins for free, right? One of those wins is support for other stacks and languages, right? So if you see over here, that's a Java project, nothing NX about it. Isn't Gradle, right? It's small, but it could be 10 times bigger, 100 times bigger, it doesn't matter. The process is the same. I'm going to run an X init the same way. It's going to recognize there is a Gradle plugin. I'm going to say, yes, I like Gradle. And doop-a-doop, and here we go, all right? Again, it's going to create an X.json file at the root with a Gradle plugin is instantiated and configured. It's going to look at every Gradle file in your project, define projects based on those, right? And this one I need to refresh. This is I think it's a small bug we need to address, but whatever. So the projects are there, fantastic, right? And it was able to not just deduce the project, but also the targets. It defined all the targets that Gradle knows about, figured out what's cacheable, what's not, what inputs go into every target, etc. Right? It can do even more. It can split large Gradle test suite into smaller test suite, which I'm going to cover later. Right? The important part here, though, is that I ran one command, and in any project using Gradle, doesn't matter what it does, right? By placing one, it plays 3 files at the root because 2 of them are just executables. But one meaningful file at the root, it's able to configure Gradle support for any repo, no matter the size, right? That's a nice win. So we aimed at TypeScript because we love TypeScript. TypeScript's good, right? And we got Gradle kind of for free. It works, and we also use Gradle and Java inside at an X. It was a nice win for us. Support for Go, same with Go, and same situation, right? Support for .NET, we don't use .NET, right? But it's fine. If you use it, it's absolutely fine. There is nothing wrong with it, right? And I know some folks are trying to do the same with PHP because it's very easy now, right? It's very easy to add support for, very easy, as in it's much easier than before to add support for a new stack, right? Because the ask for the developer who is using that stack right now is much less. They don't need to worry about your stuff. They just need to change a few commands in the ACI, and that's it, right? So that's a win. For some reason, we didn't expect it. We should have expected this. It's just, I don't even understand how, I personally didn't expect it. It just shows that sometimes the obvious things that you see, you just, they're obvious in retrospect. But, when we started, we were like, oh, let's do Gradle. It's like, no, it happened a bit later. There is one extra win, a much better win, a very sweet win. But to talk about that win, I need to deviate and tell you about a different idea, okay? So like this is a track. It's going to be a lot of deviation. That's why speaker notes are important. It can be hard to track. Separate idea comes in, right? I love this idea, which is that changing the mental model sometimes can fix all your problems. It's like, Alan Kay said, a change of perspective is worth 80 IQ points. Same idea, which I really like it, right? Because we know calculus, we can solve many problems much smarter people in the past couldn't solve, right? Because we have the idea. Or like explore, exploit, the same kind of idea, right? Where sometimes you need to explore, and we as engineers really like to exploit, as in like do local maximums, right? We're not like, I think a lot of engineers like to just look at the problem very narrowly, right? Anyway, that's the idea. So about 2 years ago, what came into our view, we didn't come up with this problem. We just, lots of companies before already recognized it. We just focused on it, right? And the problem that we recognized is that the biggest source of complexity in CI, we thought, is that the build tool is scoped to a single machine, to a single CI agent. Now that's a big problem. So why is it a problem? It is a problem because if you want to scale your CI, you need to do kind of multi-VM, multi-machine orchestration. That's the only way to scale CI. Like you cannot just grow this box to bigger and bigger, right? At some point, you need to use multiple machines, many machines, dozens, hundreds, etc., depending on the case. Which means that the CI is responsible for this orchestration. And that's weird. That's a surprisingly bad design that we internalized and we don't reconsider it. Why that surprisingly bad design? Because CI knows nothing about what's going on. It treats everything that runs as a black box, just a set of recipes. Whereas the build tool knows everything about what's going on. It knows all the projects, how they relate, all the tasks, timings, what creates side effect, what doesn't, right? It knows all this information, right? But we don't use it, right? We don't use the build tool with all this mighty information to optimize your CI. We use the thing that knows nothing, right? And an example here is like an Einstein being advised by his dog on, on physics and stuff, right? It is backwards, right? We don't want to have that. In general, it's a good property where the component of your system that knows a lot, has the most knowledge, is the one you put the responsibilities in. Because presumably the knowledge is what gives that component leverage, right? The build tool has the knowledge, therefore the leverage. CI doesn't have the knowledge, right? So we look at this picture, and we decided to kind of flip it around, transpose it, or whatever. Put the CI inside the build tool conceptually. It's not really like that, but conceptually it's what happens, right? Now the build tool knows everything about the CI system, all the commands you run, all the targets, the whole context, right? And the build tool has this, a lot of VMs at its disposal to distribute compute across, right? The CI in this case doesn't worry about this. The CI just executes some basic, shell scripts, run some commands, etc., right? Those machines on the right, we call them agents, right? But that's kind of the idea. We changed the mental model. We went from the CI-powered mental model to this one, right? Before we see why it's important to discuss two types of being fast, right? So there's another diversion in the flow, right? There's one type of being fast, which is a kind of how fast is your car type of fast, which is like raw speed, right? And there is a second type of being fast, which is like how good is your navigation? Like, are you able to pick an optimal route, right, and going somewhere? Looks a lot like Greg, this guy who's navigating over there. Anyway, so, I think the build tools like NX are a lot more about navigation than raw speed, right? If you have an end-to-end that takes 2 minutes, because it's just how long it takes to click through the buttons in your application, right, via Playwright or whatever, it is going to take 2 minutes, no matter how you wrap it, right? You can wrap it with an X, you can wrap it with something else. It's going to be the same. So the raw speed is not really what an X, our tools like an X are all about, right? We're all about kind of navigation, optimizing your resource allocation, right? Moving stuff around, making sure that the same task doesn't run twice, or some things doesn't run twice, spreading the test around, deciding what to run and when, things like that. That's kind of the sweet spot, right, for tools like an X. But moving this navigation thing from the CI to the build tool means that we can now do kind of global optimization. Like we can navigate on a global scale. We look at the whole CI process, knowing all the history, rather than looking at every machine in isolation. So before, you can think of it sort of in a traditional CI case, the decision you can make navigation-wise is which lane to take on a road, right? Whereas if you go to this the build tools in charge model, the decision you're making is which roads to take, right? You can actually pick an entirely different route, right? So that's kind of the idea, okay? That lets you to take the same amount of compute you would normally run, right, in CI, and just rearrange it. That's actually surprisingly effective. to pack it more, right? To basically run the same amount of compute on fewer agents, minimizing idle time, making utilization significantly higher, right? By doing simple things like figuring out which tasks unblock other tasks, right? So there are no bottlenecks, right? Running slower things first, right? Etc. Or, that's what we do now, is taking and deciding just on the number of minutes you want your CI to run, right? Because the build tool has all the knowledge, it has all the context. You can just say, I would like my PR to run under 20 minutes, and the main, maybe you don't care as much, 25 minutes, right? And then it's the build tool's job, in this case, knowing all the context, to figure out how many VMs to allocate to execute your PR, such as this property holds, right? Things like that. One last bit, which is even more exciting, what the build tool can do, it can look at your tasks and figure out which tasks can be divided into a lot of smaller tasks, right? You know this anecdote about the professor who put some pinballs and gravel and sand in a cup, and if you know, blah, 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 right? The important bit is that if you have a lot of pinballs or whatever, you're going to have a lot of empty space in your glass, right? If you don't have enough sand, and that means idle time, bad utilization, right? You want as smaller units as possible to achieve this flat, beautiful utilization, right? That's what the build tool can do. So we're going to look at it, but first we need to go another diversion, right? We're going to have another side quest, right? And we're going to talk about things that are as important as being fast, which is reliability, right? When we talk to build tool folks, right, the build tool folks really like to talk about being fast. I don't know what it is. It's just people like super fast, right? The speed is so important. Whereas reliability is more important, I mean, just as important, but I would argue more important than the speed. And you can know it. So if I tell you that there is a 30-minute PR that's your CI time, and every third time it's a flake, you have to rerun it. Edit is done in 40 minutes, right? If you kind of, this is going to exclude all the time in between you need to wait or whatever, right? Now imagine a place with just a consistent 40-minute CI time that always works. Most people would pick the latter. Less stress, you're not like checking, is it flail? You just trust it, right? Peace of mind, right? Reliability, you don't want to be like this car, fast but kind of falling apart, right? Yeah, you want to be reliable. So what we realized right away is that if you distribute, that also means that you can run the same tasks on multiple agents. Because distribution and replayability demands no global side effects. No global side effects mean that you can run the same thing twice, 3 times, concurrently, serially, it doesn't matter, right? This means that if you have a flaky task, right, like let's say this attempt 1 was flaky, you know that it's flaky. Any tool can know it's flaky. Any tool like an X, because it can look at the computation hash, look at the outputs, see that the output changes with the same computation hash, flaky test, and just rerun it on a different agent, a clean environment, to make sure that nothing is left over that's affecting it, right? You can do it. Beautiful, right? We were very happy with it, very proud. However, what we quickly realized is that more things that are flaky are end-to-end tests. And most organizations keep the end-to-end test in massive test suites that take like 40 minutes to run, right? So if you detect that 40-minute test suite is flaky, well, it takes 40 minutes to rerun it, and that's no good, right? It's like, okay, cool in principle, in practice it doesn't work because it doubles your CI time, right? It didn't work well. And that's where the idea of crystal plugins we talked before kind of connected to this idea of this distribution and agents, right? And again, we looked at editors for inspiration. It's kind of weird that we kind of look at editors and just borrow ideas from it, you know? And if you look at editors and you run end-to-end test suites, or any tests in a folder, the editor, a reasonable editor with good plugins, will recognize all the specs within the test suite. And even if it runs all of them and can show you structured output for each test, right? You can run one of the tests. It basically has knowledge about what's inside your folder. It doesn't treat the whole folder as a unit, right? It inspects it and gives you kind of more affordances, right? So we thought we can do the same because Crystal plugins already look at your tools. They already kind of look at configuration and deduce stuff to configure cache and the rest, right? They might as well figure out what exactly are you trying to run and if those things you're trying to run are divisible, right? If it's one piece or many small pieces. The feature is called atomizer because we atomize the thing with like an array of power, right? And what it gives us is a beautiful property where instead of seeing this picture, which is very depressing, because if you have a 40-minute test suite with about like 41-minute end-to-end tests, something's bound to be flaky there, okay? Just all the time. The thing is not going to be passing, right, very consistently. However, if you atomize it into smaller units, well, most of them are probably pretty stable tasks. You have 1 or 2 that are flaky. Each of those is significantly smaller as a unit, so you can rerun it. And it becomes like a viable way of deflaking everything. Like you can fix flaky test categorically with this, right? Where there's just you will never have a flaky test anymore, because you can just choose the number of reruns and probabilistically reduce it to 0, right? So that's kind of my idea about you can have your cake and eat it too. There are no trade-offs. These are numbers we have based on the data we have. That if you move towards this mode of distribution and atomization, you get significantly faster CI. It varies from a project to project, but you get huge gains. But you also get a reduction in cost because you run less compute, right? So it's not like you have to pay more to get faster CI. You actually get both. It's cheaper and faster. Second, you don't have any trade-off between reliability and speed. It is faster, but it is, there is some trade-off if you kind of, but follow my, let's squint and pretend there is no trade-off, right? There is no trade-off between reliability and speed where it is faster, significantly faster, because you break those 40-minute test suites and you spread the load across the machines. But also, it's more reliable. You don't have flaky test, which is very important. But most importantly to me, there is no trade-off between this goodness that you get and complexity. Because complexity is always that comes as a kind of a requirement for solving hard problems. Because there is a hard problem. Well, we have a sophisticated. It's not called complex. It's called sophisticated solution, right? The sophisticated solution comes in, but it's very hard to maintain and requires big brains, right? And what we want to do is to make it super simple, and that's an example of how you would enable distribution, deflaking, or all of it, right? Come on. Boom, one line of code. OK, cool. If you want to do it more interestingly with different resource classes and task affinity, it's more than a line, but it's not much more than a line. It's still pretty short, OK? And that's a property that I strongly believe in now. This is my strong belief. Does your solution fit into a tweet? If it does not fit into a tweet, it's not a good solution. Tweets got longer, though, right? When it was 140, it's pretty rough. The solution space greatly expanded, right? By doubling the length of a tweet. But I think it's surprisingly true that if you have something that's complex enough where you cannot describe it in a tweet, roughly speaking in a tweet, it will cause confusion, right? And you can see it even in history. Like if a project that I just keep thinking about is my youth passion, Smalltalk, right? Smalltalk was designed for children, right? So children can learn programming, right? I think arguably misapplication of effort in there, but whatever, right? It was designed for children, and lots of big brains, smart engineers at big organizations build big systems with it. Because when you design something for children, even I can use it kind of stuff, right? Because if you design something for me to use, it doesn't work, right? So the ease of use or ease of adoption, like does it fit into a tweet, is a big deal. Yuri, who is somewhere in here, is going to show our next import today, which is a way of adding project to a workspace. Again, made tweetable, right? So you can fit into a tweet and you can expand your workspace. Our docs should be just a series of tweets. OK, now I want to tell you a little bit about 2025. That was a look at the past, right? The past year. A lot has been accomplished, but a lot of what we did was kind of foundational for what should come now, right? So a lot of really cool things is coming in 2025 because we have the building blocks, but the total Polish dev experience wasn't always there, right? Now we're trying to kind of bring it to a conclusion, right? So use AI to generate all of those. Looks pretty cool. See, I'm also cool. So the first one is our next core is migrated to Rust. Okay, so we have this benchmark. You can argue whether the benchmark is useful or not. That's not the point. The point is that so our next in here is 150 milliseconds to run. Like it basically measures the overhead, how long it takes to boot an X and to kind of check if anything needs to be restored from cache. That's it. All right, should be super fast. 150. It's pretty fast, but noticeable. I notice it, and it bothers me. It bothers me greatly. And we spend a lot of time trying to make this number smaller. All right? And I think at this point, with the current model, it's just very hard to make it small. If you have a slower machine, or if you have a bigger repo, the number is going to be bigger. Right? So it's just not fast enough. I want it to be 50 milliseconds. Right? Also, other tools are getting a bit faster. I want to just jump so far ahead. No one's even close. That's kind of my personal. But yeah, I want it to be super fast. So you run it and it just feels super snappy, always, right? There is not even a slightest delay, right? The only way to do it is to go full native for this core use case. Not full native in all of our X, just the core use case of running tasks, right? And there's nothing new about it. So if you look at your node modules right now, you will see there is a, this binary over there. We have moved most of performance critical parts of our X to Rust already, so it's underway. It's, we've worked on it for a long time. We're just bringing this to a logical conclusion, right? Where the core use case is purely native, right? Super fast. Everything else, like that runs in a daemon, generators, whatever doesn't affect this, the most important performance use case, can be done and should be done in JS. I think Rust for performance, JavaScript/TypeScript for extensibility is still the model I strongly believe in. Extending using JavaScript just very nice, very easy, everyone can do it. But the core experience has to be very fast, right? The second part that is landing 2025 is something that I was dreaming about for a long time, and it's going to land, which is, as you can see in CI, it's very easy to distribute. Just slap a flag, distribution happens. I want the same locally, right? So any local command you run, you can say, I want to distribute on these machines, and then I can keep doing what I'm doing, and then test just run. Partially for speed, but secondly, sometimes it's just very hard to make things work locally. So being able to just say, you know what, pretend it's CI, let it run while I'm doing my own stuff, is actually quite useful. The other part is different. It's exactly the exact reverse. And I'm excited about this even more. Like the first time I saw it working, I was I felt excited like a child. And partially because I was watching my daughter jumping on a trampoline at a birthday party, and I was thinking about no cloud, right? And I was like, no cloud has good points, right? Cloud is good, it's flexible, lets you scalable, but very expensive, right? It's very expensive. How can basically, it's too expensive. Like NNX helps with it being expensive. Affected commands, cache and distribution can cut your compute by like a factor of 3, but there is still a lot left, right? And we have these supercomputers, right, that we use, like the dev machine that are super mighty, that's idle all the time, right? They're not doing anything most of the time. You're on a Zoom, 70% of your CPU is not doing anything. It could be running CI, saving you some money, right? You can ask your boss for a bigger machine. You're going to save money, right? You get a bigger laptop. It's for a reason. You're going to help your CI, right? It's actually a surprisingly reasonable idea, right? So instead of running everything on cloud, how about we run most of things locally, right? We already have all the infrastructure. We can spawn containers and Docker that with a CI environment for the setup for any CI execution you have. It works. And it only works, by the way, with a model where the build tool is in charge. In a traditional model where CI is in charge, that doesn't work, right? With the build tool in charge, it works. Like I can close my laptop leader now. The task this machine would have been running, it won't complete. But it doesn't matter, right? Because in this model, the distinction between pets and cattle kind of stuff, right? These agents are reusable. We can throw them out, put another one. So the agent goes away, the task is gone. Some other agent is going to pick it up. Or if you don't have enough, a cloud agent is going to pick it up. It doesn't matter, right? So you can save a lot of compute this way. It's a beautiful thing. You can see it in this little demo. I see, cloud. Anyway, the demo is not very exciting. The point being is, it's a cool idea. And when I say a dev machine, I don't necessarily mean it has to be a dev machine. It could be an old computer you have. Plug it in, and start saving money, right? So we pay a lot for CI, surprisingly, right? And we don't even do anything there. It's crazy. Okay, another idea I'm running. That's why what happens. I think we're behind, but I have no speaker notes, so I blame someone. So, and the idea that I had, which is sometimes one can have a monorepo without having one, right? It's almost like something zen about it, right? And the reason why we came up with this idea that every time we talk to a VP, chief architect, CTO, they all say the same thing. We have a bazillion repos. They will never come to be together. What are our options, right? It's a common pain people have. They have 2,000 repos. You're talking about monorepo. That doesn't sound good, right? So what we thought is, can we give you some of the benefits of a monorepo? Not all the benefits, some of the benefits, right? Without having you to do anything, except paying us money for the license for the thing. But that's bracketing, right? But generally speaking, it's effort-free, right? So, and that's the idea. So we came up with the idea of polygraph, right? Where you have multiple workspaces, multiple graphs, right? And imagine we have a meta workspace, like a workspace where every repo you have is like a folder within it. And they can all connect to each other within that folder with edges, right? So we can figure out that a package published in one repo is consumed in another one. So repo 2, in this case, depends on repo 1 in a different way, through an intermediary, through some sort of registry. But the dependency is still there, all right? Of course, it generalizes. You can have many more of them, right? And by doing so, you can do some nice things. You cannot do everything monorepo gives you, obviously. Like there are no atomic commits or anything like that. But you can do some things. You can provide the real value, right? So we basically would create a composite graph. We can help you enforce best practices. We can help you do multi-repo refactoring. That's the biggest pain people have. They have like 100 repos. It's out of date. They're trying to make code changes go through those repos consistent like a big wave, right? And it takes many years. It's surprising, right, how long it takes, right? Promote cross-team collaboration, et cetera, right? And we focused right now, what we really want is like cross-team affected, where you run things and we just verify things across graph of repos. That is still in the future. So this is still in the works. But what is currently there is that we're able to run like conformance checks against your repos, define them for your polygraph, and define a release schedule for them, right? So you would have conformance checks. James is over there working super hard, day and night, on a lot of this stuff, right? And many other folks like Mark and Chow. And the idea is that we can do it, and we can roll out those best, so that's another thing, right? Roll out a lot of these cool things throughout your repo graph in a much more efficient way. Instead of spending like 6 months discussing it, you just go in there, it enforces your rules, shows you fixes, you run the fixes. Suddenly your graph of repos is being modernized. Modernize your enterprise. That was my slogan at some point, right? So we are going to modernize your enterprise, okay? So the last bit, the very last one, which is documentation didn't fit. Documentation, and that's embarrassing. So we use LM-powered doc assistant for a long time. You know, it works actually surprisingly well. We landed LM-powered error explainers, also work reasonably well because we have the context to give you a good explanation. But what LM's really good at is at taking declarative descriptions of what you want to do code-wise, with some examples, and applying them. And that's what I really want, right? Because in case of polygraph, you know, the conformance checks, when you do those refactorings against your thousands of repos, the core team who is going to do it is going to write thousands of checks a year, right? Because they're short-lived checks. You're not going to be spending, you know, months building AST transformations with semantic analysis. No, you don't have time. You have 2 hours to land this check. You have old API, you have new API. You want to move from old API to the new API, right? That's basically what you want to express as clear as you can. It doesn't even have to be totally correct, and it won't be. Based on my experiments, it won't be. But it has to be close enough to save enough dev time, right? Where instead of spending like 3 days doing it, maybe you spend a few hours, right? Kind of stuff, right? And that's what I had working already. It's actually quite usable. And it fit nicely into our next mode where we already have generators and migration with a virtual file system, and we can already kind of do code transformations at scale. Here we can just have different mechanism of going against the same virtual file system and do the same transformations at scale, right? It kind of works. It's actually pretty cool. And that's about everything I have. So this is Jean-Jacques Rousseau. Let them eat cake. Thank you so much. Okay, here you go.
Have some new information about tonight's party. Hot off the presses. You're now the press, Jeff. Apparently tonight during the party, we will also be showing Tron, the movie Tron. So if that interests you, be sure to check that out tonight.
Ooh. Where will the movie be shown? On a screen. Fair enough. Okay. Everyone will have their own screen? Okay. Okay.
Money was paid for it. Please, at least watch a little bit.
Yes.
Even if it's just the credits at the end, come watch a little bit of Tron. So just a reminder, we are track 1 in this room. Track 2 is across the hall. So if that's a talk you're interested in, Alex, turn around. Don't watch. If people are going, no offense to you. Okay, cool. But we have 2 tracks. So if you are interested in a talk in another room, we're going to do our best to keep the 2 schedules on sync so that the talks starting here and in the other room are going to start at the same time.
And in how much time will the talk start approximately? So that, because I see a lot of people leaving, don't all leave.
We've got about 10 minutes. I can't
10
stand in front of
minutes.
the screen because that shines in my eyes.
Yeah. Okay, so in about less than 10 minutes, I will say.
About 5 minutes or so.
In about 5 minutes, we're starting here and they're starting next room. So yeah, be sure to be in your seats.
And also just a heads up, with getting a little bit of a later start this morning, we're going to probably cut lunch a little bit short just to be able to get back on schedule for this afternoon.
Okay.
We'll give them a few minutes to settle down and what have you.
So approximately 1 more minute left. Oh. I didn't know. So almost 1 more minute left. So if you want to start taking your seats and wrapping up your conversations. Thank you, Jeff, for setting a good example. Thank you.
We'll just bring you up as Alex Eagle and. All right, if everybody wants to work their way back to their seats, if you
Yep.
want to stand, I mean, whatever. Again, code of conduct, do you.
But the conversations need to wrap up, sorry.
So again, can we get another warm welcome or set of hands for the keynote? God, words are hard this morning. I don't know.
I don't know.
You don't clap. But we are ready for our first talk today in track 1. So here to kick things off is
Alex Eagle. Alex is another Angular alumni, and he worked at Bazel, and he will give the rest of the introduction himself, as he told me. So give it for Alex Eagle.
Good choice. Love that song. I believe that is the music video for that song, too. They walk up and down stairs, backwards down the stairs. Very cute. Hello, everybody. It's fantastic to be here at the very first Monorepo World. I'm really excited. This is one of the preeminent build system conferences taking place this month here at the Computer History Museum. You can all come back next week for BazelCon. Before I get started, this is Python Monorepo with Bazel. Before I get started, let me just do a quick audience survey here. How many of you are primarily doing JavaScript in a JavaScript repo? Okay. 3/4 maybe. Okay. How many of you are doing some Python? Okay, and how many is in the same repo with the JavaScript? Okay. Like six people. Okay, interesting. Okay, cool. Let me switch over to the slides if I could. I am plugged into both, and my Ethernet cable is now taped, and so everything should go fine. Hopefully it's fine. So yes, my name is Alex. I've been working on Bazel for a long time. I worked at Google with our esteemed keynote presenters, Jeff and Victor, for a long time on the Angular team. Met my co-founder, Greg, working there. We rolled out Bazel to some set of the Angular community, and I know that was a little bit of a challenge, and so a lot of my talk today is to reintroduce you to Bazel if you've already heard of it or tried it. The perception about Bazel is that it's complicated, and I would like to show you that it is not as complicated as you think. You don't need a PhD in build systems in order to get started and use Bazel for your project. So what is Bazel? So this is the build system that Google developed internally. Jeff and Victor and I all used Bazel regularly as we were developing Angular, and so and I think NX borrowed a lot of ideas from Bazel as it was getting started. Still borrowing ideas from Bazel. Thank you, Jeff. Oh, stole. You're not going to give the ideas back, you're saying. You're not borrowing them. OK. Well, we'll take ideas back from you, so it'll be fair. There's a lot of reasons that Bazel is very popular today in Silicon Valley among a lot of the big tech companies, not only because they have ex-Googlers working there, but because it gives you a lot of fantastic properties about your repo. And I know that this is a long list of properties, so I've helpfully given you this acronym that you can remember, IPCR-CUI. So if you just keep that in the back of your mind, that will help you remember incremental, parallel, correct, cached, et cetera. The one I want to zoom in on today, and it's a little bit tying back to what Victor was saying in the keynote about reliability, is that you want your build to be fully reproducible. This is one of the main guarantees that you get from a build system like Bazel. It is very, if you can imagine there's a dial you can turn from 1 to 10, Bazel's really trying to turn that reproducibility dial to 11. So this is a property that you can get by a combination of two things. If there's, one of them is hermeticity, which is the idea that all of the inputs to the build are known and pinned ahead of time. Bazel fetches them for you. Today we're going to be talking about Python, and it fetches the Python interpreter for you. There's nothing about your system, no offense, but we don't trust what's on your computer. We don't want to use anything that's on there already. The second thing is determinism, and if you have determinism, that means if I run the same thing twice, I should get the same result with the same inputs, and so things like timestamps shouldn't show up. And if those two things are true, then I should be able to go back 3 months and take a release that we shipped and make a single cherry pick commit on top, build and push, and there's no behavior changes other than the thing that I cherry picked. I'm not going to get any surprises. Reproducibility is a pretty important guarantee. Okay, one of my favorite quotes, the difference between bravery and recklessness is whether the outcome is desirable. Why am I giving you this quote? Well, the rest of my talk today is an extended 20-minute live demo, and so it's either going to be brave or reckless, and we will see which it is. Okay? We're going to make a Python monorepo from scratch. I've got an empty terminal window. We're going to be in a temporary directory. There's nothing hidden up my sleeves. Also wearing short sleeves just to prove the point. And what we're going to build is a full-featured Bazel application that shows a bunch of properties. Right? We're going to use Aspect CLI, my company Aspect. We started like 4 years ago. We've been doing a lot of consulting around Bazel. We also have products and services built around Bazel. One of these products is this improved CLI. I'll talk a little bit about other products at the end, but of course, today's talk is mostly about Bazel and things you can do with it. So Aspect CLI is not required to do any of the things I'm going to show you today. You could do these things with vanilla Bazel, just not as nice. Okay, you can go see our docs about this, and you can also install it yourself on your laptop. Of course, I've already done that. I'm on a Mac here, and so I've done brew install, and we have Aspect CLI set up and ready to go. So the first thing we're going to do is switch over here to a terminal, and I'm going to go to a new temp directory. I'm going to see how well I can type in front of everyone here, and I'm going to run aspect init. So this is going to be a wizard to prompt us how to create a new project. I'm going to call this thing Monorepo World in honor of the conference that we are at here. So the next thing we see is it offers us a choice of a bunch of languages that we can code in our repo. And Python is only one of 6 here. One of the things about Bazel is that it works with almost every language and framework today. And Google uses it for every single language that they code in. They have started adding more ever since we forced them to add TypeScript way back when. For this talk, of course, we are going to pick only Python, but you're welcome to try running Aspect init and see how this works for other languages. Then it's going to ask us a few more questions. So do we want to set up code generation? Yes, we are going to show you how that works. Of course, we're going to want to scaffold out a new library because we're showing you a monorepo. This is going to use Copier, which is a tool from the Python ecosystem to do that. Do we want to set up formatting and linting? Yes, we're going to show you how those things work. We're going to use Rough, which is written in Rust, super fast tooling to do linting and formatting. Do we want to set up version stamping? Yes, I'm going to show you how that works. We are going to make a release. Protocol buffers, that's not today's talk. Let's step quietly out of that room. And then for OCI containers, yes, we're going to build a container so we can push to production. It's confirming my choices, and then it will run a post-scaffolding hook to clean stuff up. That's not really essential, and to save time, I'm going to tell it to skip that. Okay, so now we've scaffolded a new project in a directory called Monorepo World, and it gives us some instructions, including, very importantly, there's a README in that folder. We'll look at it just a little bit, but this is one of the most important things you need in a monorepo, especially if you're adopting tools that not everyone is familiar with, is to have a very easy README for everybody else on your team to be able to follow along. So you don't want them to be mad because you tried checking in some Bazel stuff, okay? So I'm going to use Visual Studio Code. Of course, you could use whatever editor you like. And let's open this in the editor and get started. Do I trust myself? I don't know. It depends how much sleep I've had. Okay. Hopefully this is big enough for those folks in the back. What we have here is a new repository. It's got a whole bunch of files. We don't really care what they are. We're not going to look through them. What we want to do is start writing some Python code. And so we're going to make a new folder called app. And of course, the convention in Python is to use lots of underscores. Dunder is the abbreviation for when you put two of them together. So dunder main.py is the convention for an application that should be runnable. Okay, so we're going to build a new application. Let's pretend for the sake of this talk that I don't know Python, which is basically true. And so we're going to go to this getting started page for Python requests. And it's got some code here that I'm just going to literally copy paste into the application. Okay, and now what I want to do is run this. And so how do I do that? Well, we want to run it with Bazel because, like I said, we want it to be reproducible. We want it to manage the interpreter for us. And so let's look at the README, because I told you that's where to look. Formatting, linting, installing dev tools, working with Python packages. Okay, so we've added a new import statement. We're going to run aspect configure to update build files. So what does that mean? So Bazel uses these files called build. A few other build systems use these as well, like Buck2 and Pants. And that's going to have all the instructions. We don't want developers to have to learn how to do any of that. That's a regression from their current behavior, and that's where PhD becomes involved. So we're just going to open the terminal here in VS Code and run aspect configure. And it's going to give us an error because requests is unknown, right? So I pasted some code from that web page, and requests is not in my project right now. That's easy to fix because we're going to use the standard pyproject.toml. For those of you coming from JavaScript, which was about 3/4 of you, you can think of this being like a package JSON file. We'll add requests here as a dependency. And now I'm going to run a pinning operation, repin. Okay, so what this is doing while it's running, is we're giving ourselves a reproducible set, not only of the Python interpreter, but all the dependencies of our project, including transitive dependencies, right? So we're producing a lock file. If we look in this requirements folder, we see there's a couple of other in files. So we need PyTest, for example. We're going to write tests in a few minutes. All of that comes together in this all.in file, which points to those. And then this is the thing that needs to be constraint solved. It uses a tool called pip compile from a project called UV, also written in Rust because we like things to be fast nowadays. And so its job is to create this file I'm showing right now, requirements.txt. This is, as you can see, certify, for example, comes in via request. This is a transitive, not a direct dependency. And we're getting the cryptographic hashes of that library because we want supply chain security. If somebody grabs a deploy token for that project and pushes some bad artifacts, we don't want to download those and use them in our project. Okay, there's a little bit of some Go code compiling here because, of course, Bazel is capable of compiling lots of languages at once. And one of the tools that's being used here is written in Go. Not important, it's all done now. And so this file has been updated, all of our dependencies are available. And so now if we look in the application that we started writing, we now have the build file written for us. There's nothing we need to do. It's got app_bin. And so we should now be able to do Bazel run app:/app_bin. And so it's going to print out the result that we got from that README, which was just go fetch some code from the internet. Okay, so there you go. Immediate gratification. We've got like a Bazel project up and running, and we've run our program without having to learn any Bazel stuff. So what are we going to do next? So the next thing is that the editor does not look quite the way we want. It's important that there not be any of these red or yellow squigglies. The editor is sad. This is a common misconception that in Bazel you can't make the editor work. The answer in Python is, of course, virtual environments. This is where you would normally start from if you were creating a new project on your machine so that the editor will look around in certain folders and know what to find. And to fix that in our case, let's look at what other stuff is in that package that got created for us. So if we query app:all, we see that there is something here that's a venv. That's a runnable target. If we run that, it will create a standard Python virtual environment for us. And the editor, of course, understands virtual environments, offers to select that for our workspace folder. So if I say yes, now the editor will go find that site packages folder that Python installs. And now request is no longer a squiggly, and all of our auto-completion and jump to definition works. Right, and if I hop in here, we can see I'm in this. It's under a package, it's a folder called site packages. The interpreter lives in there. It's like, this is how Python tooling is meant to work. And so the answer, of course, is that Bazel shouldn't be weird, and we shouldn't be teaching the editor any Bazel stuff. Instead, we should be teaching Bazel how to act like every other tool expects. Cool, so that's working. Now let's try watch mode. So JavaScript developers are used to having a great watch mode. Python developers don't always expect that. This is a separate tool, so I'll look in this tools folder briefly and show you. So there's a bunch of tools installed here. I'm not going to talk about any of these other than the fact that Bazel is managing these for us. So if I was to run this version of Docker Compose or this version of Terraform, it is exactly the version that the rest of the people on my project are using. There's nothing for me to do, and it will lazy fetch those on demand if I was to run one of them. For watch mode, iBazel is the tool we need. This is a little wrapper script that tells Bazel what to do. So I do /tools, iBazel, run, app_bin. Now we're running it in watch mode. And we go back to the application. Now we should have live editing. So I can say we got, OK, here's where I'm typing in front of everyone. Format, this thing. OK, and so we can see as the editor was saving in the background, the application is restarting, and we can see that the string got shows up here. OK, so watch mode is working. That's cool. Now let's install a first-party dependency. We want to be able to copy these and scaffold these out. I'm not going to create one of these from scratch, partly because of time, but also because it's really important to see how this copier thing works. Let's say that there's a new team within our company, and they're obsessed with cows. This is a cattle company. I didn't tell you. And so there's going to be something here to let the cow say what we just found from the internet. I'm just going to go shop around for a repo that provides what I want. In this case, I've created one on GitHub that's just a template for a Python library. Sorry, let me zoom in. So this is assuming that we've run aspect in it, so we just have these tools in this location. And so if I copy this, then it will stamp out a copy of this library in a place called mylib. And then we'll also run this bulldozer command, which is just a way to teach Bazel that that thing now exists. And then there's one more step on this README, which is to go to that all.in file I showed you earlier, because of course this app is going to need a dependency in order for cows to say things. It has its own pyproject.toml file, which has its own dependency, and our job in a monorepo is, of course, for dependencies to all be managed, but still to be constraint solved together so we know that they're compatible. So if I open tools.in, or sorry, if I open all.in and put -r ... requirements.txt, now I just need to do that repin operation again, and I will have that new library is now installed and all the dependencies are available in my project. Cool, so I could build it. Let's actually go over to our application and start using it. So instead of just printing, I'm going to, from my lib, import, and of course my editor is working, import say, and so if I say moo, and then let's run the application again. Now we have an error because there's no module named mylib. Well, the build file wasn't updated, right? It doesn't say that it has that dependency, but of course that's just a matter of telling it to update that by running configure. And now if I run the application, now there's a delightful cow who says what was gotten from the internet makes the application a lot more fun. Everybody likes this more. We've added value, is what I'm saying. We've added value to our enterprise by having a cow say this thing. OK, cool. So that's working. We have a third-party library. Let's see what we want to do next. Now we're going to add a test. So we're going to go into this new cow library. It didn't come with any tests. We're going to just use pytest, and it's going to work even outside of Bazel because our job is not to make everybody change their behavior. So to add a test, we're going to go to this mylib folder. We're going to make a new file. We're going to call it mootest.py, and in here we're going to from mylib import say, and then we're going to make a function called test mooing. And of course, to start with, when we're writing tests, we always want to see them fail before we see them pass. So I'm going to assert that say moo test is something wrong, like fail or whatever. OK, now we want to run this test. So of course, we need to update the build file again. Sorry, ran the wrong thing. And then if we look in the build file now, what we should see at the bottom is that we have a py_test. So this is how Bazel expresses test that it's going to run. It's going to manage the version of pytest and everything else that's going on here. So if we try testing this thing, we should see the right failure. Mylib : this. OK, and the failure we got was assert none equals fail. So that's what we expected to happen. Turns out this say function that I called does not actually return anything, and so I can make the test fail, or sorry, pass by correcting this code. Now, that's interesting, but not sufficient, right? What we really wanted to do was to show that Bazel's not making you break your workflow, and there's going to be developers in this project who don't want to switch to use Bazel, so that's fine. What they want to do, let's look again at the output of query in mylib all, and we'll see that there's a bunch of targets here now, including one that's a virtual end for the test. Right, so we're going to have for every executable thing, programs and tests, we want them to have their own virtual end because they have different sets of dependencies. We want to drop into that virtual environment and know that we're only seeing the dependencies for that thing. So we will run that. Now we get a virtual environment that's specific for the test. Editor offers to boot it up. I say yes. Now what's cool is if I leave this terminal and open a new one, the editor will even hop into that virtual environment in the editor in the context that my terminal is in, right? So I should be able to go to mylib and just do python-m pytest, and the test runs just fine here, OK? So we're not breaking anything. In fact, let's see if we can also debug this test, because debugging is another thing that commonly misconception is impossible to do with Bazel. So since we're in a virtual environment, what I should be able to do is open the testing tab, tell VS Code to configure tests. It wants to know which framework is used. It wants me to pick a folder. Now it will auto-discover those tests. And let's go back to, sorry, I didn't actually open this new file, say.py. So this is the library code we got. This is where the function is that we've been calling. So if we stick a breakpoint there, we tell it to debug all the tests in this file. Of course, we hit the breakpoint. You know, the debugger is working like we expect. There's our string test that we had passed in here. And if we tell the debugger to continue, then the test is working here too. So all of our normal developer workflows continue to work. OK, cool. Let's now step to how do we run tools. So if you've read, there's a lot of great books about how to do monorepos and how to do development in a large organization. And one of the things they say is that you should not force teams to use standard tools, right? But we just said, oh, well, like Bazel's going to manage your monorepo. Maybe NX manages your monorepo. You want teams to have the ability to pick and choose what tools that thing is going to run. And of course, it's not opinionated about which tools you use, right? It can run any tools. And in Bazel, there's a misconception that you have to write something called custom rules and get into Bazel's extension language in order to use any tools. That's false. Let me show you. So we're going to use Jinja 2, which is a templating engine that's pretty popular for Python projects. So that's just a couple of steps. The first one is, of course, we need to download the tool. So this is where we're going to go to this tools.in file, and we're just going to say, hey, I would like to be able to run Jinja2-CLI. That's the package that they ship. Then I'm going to leave this debug console and go back to a regular terminal. We can deactivate this virtual environment. We don't need it right now. And then we'll do tools repin one more time. This is now going to fetch the Jinja2 CLI and all of its dependencies. Now we just need to be able to run it, and instead of having to write any custom Bazel stuff, what we're going to do is go in this tools folder and find this build file. Sorry, that's not the right one. Tools/build. OK, so we see copier is already here. This is what I used earlier to stamp out that mylib. So we're just going to put one next to it. And this is a console script is what people in Python land call a package that ships binaries you can run. This is similar to the bin field in a package JSON file. So this is called Jinja2. And the package it comes from is Jinja2 _CLI. Now we should be able to run it. Tools, Jinja2. And what we see when we run it is, of course, it just prints its help, because we didn't give it the arguments it expects. That's actually kind of great, because the help that you get from the CLI is exactly what you need if you want to now use this tool as a build step inside of Bazel to transform some inputs into some outputs. So we'll go back to the build file for the library. There was a second function I did not say anything about, right, which is down here. We're going to do moo_stamped. It wants to read a header file. We need to fill that header file in, and so that's where the templating engine is going to be useful. The template for the header file looks like this. It says built at timestamp, so somebody's job is to fill in that timestamp. I'm a cow. I found this on the internet. We're really into cattle at this company. So we look up here in the build file, and there is a section called run_binary. So this is a little adapter to take anything that's buildable and say I want to use that to generate some, take these sources. So there's some data in a JSON format. There's that header as a template. And then I'm going to pass these arguments, right? And -- format here is the same as -- format down here. We're just filling in the CLI arguments for this tool. The tool here, like we said, is tools::Jinja2. So now we should be able to build this thing. So this is mylib : make header. OK, so interesting. I get an error. What's this error about? Visibility. So if you have a big monorepo, I'm sure you've encountered the problem that you have a spaghetti of dependencies where some application that's mission critical took a dependency on a library that nobody's maintaining, and oops, the library maintainers were not expecting to provide that kind of quality SLA for that application. So there's a visibility system to constrain this, and so there's an opt-in where this, I need some code to be visible to me. Fortunately, the Aspect CLI includes some plugins. One of them auto-repairs this kind of error, so if I say yes, it will fix it, and I can just try again. OK, so we've built our header file. We can take a look at what's in there. And it says unstamped. We'll see in a minute why that's important. We want determinism, right? I said we want things to be reproducible. We want to get cache hits. So if this was to change all the time and have a timestamp in it, that would be no good. That's why we've chosen in this build file to put the word unstamped here. OK, cool. So we've run a tool that we fetched from the internet. What do we want to do next? And we've done the code generation on it as a build step. So next we want to be able to depend on that code gen. So that's a simple matter of updating our app. And we're going to, so we see that there's this moo_stamped. So we're going to use that from the main once I find it. So instead of moo, we're going to do moo_stamped. That's going to use our header file. And now when we run the program, of course, the first thing we get is, oh, we forgot to update a build file. In this case, it says that we didn't declare this dependency. Now, in this case, the dependency is hard for this generator to see because it's not an import statement. And so we're going to declare it manually in this case. It still doesn't need a PhD because all I need here is header.txt to be a data dependency, which means it's a runtime dependency of this library. Gets propagated to any application that transitively depends on this library. And now our cow has this little header at the top, built it unstamped. I'm a cow, found this on the internet. Cool, so we've wired code generation into our application. Still nothing too difficult here. So, and we saw what happens with visibility. I have just a couple minutes left. I want to show you 3 more things. One of them is formatting. So formatting is kind of a solved problem. You know, everybody in JavaScript agrees you just run prettier, you don't think about it. We certainly don't want to spend time in code review discussing whether single quotes or double quotes are the right kind of quotes in this given situation. So if I go back to my main and let's say that I violate the style guide of my team and I put single quotes here, am I going to end up in an infinite code review cycle with somebody who disagrees? Well, of course, we've got a pre-commit set up in this repo, which says you can do aspect run this thing. I'm going to do a simple version of that, which is Bazel run format. Okay, let me make sure I still get that file up because it happens so fast. So if we watch what happens here to line 6, when I run the format, it's going to, first of all, expect to ask Git what files are meant to be part of the project. So if I do a git init, that will cause this to be found by Git. Now it's running formatters for every language. It so happens I only picked Python. If I had more languages here, it would format all of them. Formatted Starlark code too. That's the language Bazel uses for its extensions, including the build files. And now you can see all of our quotes got fixed. Okay, so formatting, solved problem, run it as a pre-commit hook, stop talking about it. And now linting, we're going to want to find problems in our code. And of course, linters are something we expect to be wired up with our build system. And for this, let's say I leave off one of these close quotes and I make an unused import of import OS. And now I want to lint this thing. So what am I going to do? I can do Bazel lint. Technically, Bazel itself doesn't have this command. It comes from the aspect CLI. I could run it either way, but I'll do aspect lint. And let's say app:all in this case. So I'm going to lint every Python, any library in any language beneath that folder. Let me make the terminal big. So here's what we see happened. There were a couple of problems found. The first is this formatting issue, right? So I can click right here to go to this line. The other one is that the unused import has an automated fix, right? So it's offering interactively to apply my automated fixes. I can say show diff to see what the fix is that it's about to do. It's going to delete my unused import. That sounds great. I'll say yes. And then I will also click on this line that it pointed to where it says, oh, of course, the line just moved by 1 because I removed an import. Fix this, and now, of course, the linting should pass and say everything is great. And if you take a look at the rest of the Aspect platform, we have nice ways of wiring linting into your code review, which I encourage you to check out. Finally, and I'm a tad over time, sorry, is we're going to build a container. And we're going to want to stamp that container so that if it starts crash looping in our Kubernetes setup, we can tell with our monitoring tool that it was this new version of the application that broke it. Okay, so this is much easier than you might think. In our main, I'm just going to put a hint here that says OCI:build. So I'm going to build an OCI image, and if I run aspect configure again, it will read this from the source file, and it will know what to do in the build file. This is not built into Aspect CLI. There's actually a little plugin that lives in this repo that told it to do that. Now I get something that's called py3_image, and now I can Bazel run app::image .load. I'm going to load this directly into my container daemon. I'm also going to add -- stamp because I want to fill in that unstamped variable. So when I run this, it's going to do some fetches because Bazel had been lazy and hadn't fetched these things before. It's building layers. It's putting the interpreter in a separate layer from the dependencies, in a separate layer from the application code, so that as I'm doing typical Docker development task, I have very small layer uploads. It says it loaded the image, and so I'm using Podman here. It so happens you could use Docker. I will do run app, and if the demo is successful, what we will see is built at timestamp, we are now running this application inside of a container. It's ready to ship to production. Our job is basically done. Okay, so that's the big applause line because the demo has succeeded. I think I was brave and not reckless. Don't worry, you can still clap at the end. Okay, thank you. So last thing I promised in the abstract, but we don't have time for, is to talk about CI. It so happens that Bazel and CI go together great because you can just tell your CI to Bazel test everything all the time. And Bazel's job, sort of like Victor talked about, let the tool do the work instead of the CI do the work. So you can use, you can just do that yourself. You can just do Bazel test ... in your Jenkins, whatever you're using. If you want to have that be super fast, you can take a look at Aspect's product. We have something we call Aspect Workflows, which gives you this really great performance benefits of Bazel that they advertise if you go look at the Bazel homepage. It also reduces compute costs quite a bit because we've done a lot of the effort to make it do the minimal amount of rework and rebuilds. And of course, it runs on cloud. It runs on your cloud and not our cloud, so we don't charge for usage. So that's all I have time for. Thank you very much for listening. Please come find me or my co-founder Greg around the conference. We would love to tell you more about why Bazel is less crazy than you thought. Thanks.
Thank you, Alex.
So before we go to our next speaker, I want to ask, but the next speaker can't start coming up and getting set up while I speak, maybe? Yes?
That works for me.
So speaking of Angular, which I know we're not speaking of Angular, but I need a way to to introduce what I want to say. Who here remembers or has used Angular Console? Okay, that's a few people. So I have some Angular Console was created by the Narwhal team in 2018. And January of 2019, I went to a conference. I met Jeff there. No, I had met Jeff 2 years ago, but I also met Jeff there again, and he had Angular Console stickers with him. So I took a bunch of them, and I have a bunch of Angular Console stickers. These are collected items. So you can find me during the break, and you can ask me for Angular Console tickets. I have them like this, but I also have a sealed mint package of stickers for if you're an extra collector, which probably you can sell on eBay. Speaking also of rare stickers, I also have just one Narwhal rainbow sticker. It's just this one. Okay.
It's gone.
Oops. Well, you deserve it, because I would say that whoever first shows me picture of their cats can get it, and Mike has already won. But Mike, if you want to give it up to someone else.
If anybody wants a picture of a cat, just come see me first for a small nominal fee. I'll be happy to share my phone with you. Quick reminder, we were asked by people at Narwhal, or excuse me, NX. Narwhal or NX? I always get confused.
NX.
NX, perfect. If you stop by their booth, they have the QR codes to scan to get in for the raffle to get one of the two potential Lego toys. What was it? It's
Yeah.
a tuxedo cat.
Tuxedo cat.
And a guitar, the Stratocaster.
And a guitar, yeah. When we were speaking about these gifts before the conference, like in internal meetings, I thought we were actually raffling an actual live tuxedo cat. No, it's not. It's just a Lego set.
Imagine your disappointment that it wasn't an actual cat.
Yeah.
All right, well, without any further ado, it's time for our next speaker. Unlike Katerina, I don't get the chance to introduce my coworkers often. So I get the privilege of being able to introduce one of my current coworkers at Hero Devs. So please give a warm welcome to my coworker, Josh Van Allen.
Hey, everyone. How's it going? How's Monorepo World? It's actually a little interesting to say current coworker because we live in this world of end-of-life technology and always messing with the end-of-life technology. We run into the situation quite often that we're seeing repositories held together by rubber bands and duct tape quite often. And I don't know if you can see that up there. Yeah, there's a little rubber band and duct tape. This stick represents repositories, and as you make changes inside of a repository, usually are being asked to task, or you're tasked to do changes inside of repositories held together by rubber band and duct tape. And you make a change, push it out to the pipeline, and then you wait and wait and wait until you realize that it's actually impacting a whole bunch of other projects that you didn't anticipate. But sit to yourself, think to yourself, why did that happen? It shouldn't have done that. It should have only changed the other repository or the other project inside the repository. Maybe there's a null or a reference that should be there. Mike, you want to help me out here? Let's do a little real-world code pair programming. And we're going to cut this rubber band.
Break something. I'm good at breaking
hopefully.
things.
So go ahead and cut that rubber band, and hopefully this stops and shows that this is now a separate project. There's no reference to the other project, but if I make that change, it's still happening.
I didn't break it.
It's working perfectly. Phenomenal. But now the question is, well, why did that happen? What's going on inside of your dependency graph? So we're seeing this happen quite often of we want to make changes inside of a repository, and the question usually goes from, I remove the code, I remove the snippet, thing still happens, And my decision from that point forward is to rewrite to a different testing library or to a different build test or build project or build library, really, in order to speed up my environment, my pipeline. But then I see Victor, of all people, post something like this on, sorry, switch over to the slides. Cool, there we go. Awesome. Sorry, guys. We see Victor post something like this of, we need to start thinking about not just speed in terms of build performance, but also be smart about it. And that's what this leads back to the question of, what's in your dependency graph? This is actually kind of an homage to my previous employer, Capital One, what's in your card, or what's in your wallet. So I want to first introduce myself. I'm Josh Van Allen, one of the software architects here at Hero Devs. Been a hobbyist magician for about 20 years. I'm the world's first NX expert. And there's QR codes if you want to get my socials. But really, I want to start off the question of, why does that matter? Why does that matter? Why does it all matter? Well, if you don't have a proper dependency graph, you're going to start invalidating cache that shouldn't have, or that should have been invalidated. Caching heavily depends on your dependency graph. If you're changing everything, or if the graph is saying you're changing everything, you're not caching anything. The other thing, too, is task distribution. If you're saying everything has changed, that means I have to reevaluate everything, increasing your AWS costs, supposedly. Apparently now that's going to change because of everything that's going on with Victor and X, being able to recalculate everything. But primarily, when you talk about task execution, you might be over-tasking your environment. And then finally, the worst thing that you could potentially do that's very, very disruptive, and the worst solution you could potentially think of to solve a pipeline situation potentially, is to switch your tooling. That is such an overbearing inside of your ecosystem. So let's first ask the question, what is a dependency graph? So the dependency graph is a directional graph representing the relation between entities. Fancy words just say, hey, this project depends on this project. And we've seen this before. A lot of people have seen this type of example, especially in the NX ecosystem. Client ETE depends on client, which depends on client feature main, so on and so forth, all the way down to components. Admin ETE depends on admin features, depends on component shared. But I'm sure you've seen this in other situations. Look at the angular change detection graph algorithm. Notice the similar directional graph that's associated to this. It's a dependency graph. Has anybody messed with net kernels before, or real-time network tracing? This all shows the relation between the internet all the way back into your services. By the way, net kernels, phenomenal technology, not an advocator, not sponsored, not a thing. But it's the technology around this is every step of this is cache. And the only way they can actually achieve this if they have a dependency graph defined. And this is done in real time. Take a look at it. There's a good conference talk about it. UML diagrams. Been around forever. Not a lot of people do it quite often anymore, but this is another representation between your base classes to your child classes. What about a non-technical solution or a non-technical representation? Org charts. Org charts is a dependency graph. CEOs depends on every organization. Dependency graphs are such a fundamental piece in society that we have solutions to solve them. Yet usually the solution that we use to solve them is to avoid the solution of fixing the dependency graph and switch tooling. So what I'm actually advocating is evaluate your dependency graph and only evaluate what's absolutely necessary. If that doesn't work, or if you're still running into a situation, then consider switching tooling. So the first step to figure out what's going on, check out the situation. Get it? Da-da. Okay, cool. It's take a look at what's going on inside of your repositories. Pull requests, there's two approaches. You can tackle it from the pull request, which I think is a reactive approach. So audit your pull requests to make sure that they actually are changing what's actually meaningful. If they're not, that's a good indicator that you might have this problem. Again, in order to identify that you have or in order to claim that you have a problem, you have to first find the problem. The next, or the other approach associated to this is, so I mentioned about pull requests. This is all analytical information to figure out if you have a problem. I want to talk about what's the difference between information and data. Data doesn't really mean anything in most cases. Data just says a thing, which have no context. Like if I step on a scale and my scale says 206, that means nothing to me. As soon as you add the unit of pounds or kilograms, then it becomes meaningful. That's the information I care about. Now, adding more context is associated to it, whether if I gained 5 pounds or lost 5 pounds, that's extremely important. So you want to build information and analytical, you want to use information as information instead of just as data. Who cares about data? We want information. The next thing, or the other approach to auditing your system is to be proactive. This means pulling down the code, doing a quick change, seeing what happens. If it's impacting other projects that shouldn't have been, then that's a problem. You should tackle that problem first before switching tools. And I don't know about you, but I'm definitely a visual learner. So I need to visualize the graph. At the beginning of this, there was a representation of the graph. I think that's a great criteria to make sure that you have the right tools available to you. So have a tool that can actually visualize your graph, and it can visualize the infected projects. So the next question is, I know I have this problem. How do I fix it? The first problem, or the first solution to the problem, might just be you have unnecessary references. I know NX looks at any form of references between files to find a project to then related to projects. Maybe it's a unused reference inside your code base that should have actually been removed, and that's an easy fix. Or even there might be a quick opportunity to refactor. If you were able to refactor it, life is good. Because the next couple of things might be a little bit harder. Or it may not make sense. The semi-quick fix is break it up to projects. If there's code changing quite often, but there's other parts that aren't changing quite often and they're the same project, maybe it's worthwhile to split apart. However, don't just do it to achieve some type of benchmark. Do it logically. If there's an appropriate domain, go ahead and do that. But don't just do it for willy-nilly, do it intentionally. Really, all this talk is intention. Make sure that you're doing it intentionally. The not so quick is to consider another grouping approach. I've seen repositories in my times at Here It Is that has been built around types. I have seen projects built around frameworks. But I want to consider if there's other approaches to grouping your code instead of what you're currently doing. One approach probably would be domain-driven design and building around domains that has appropriate boundaries for any other code. Give it a shot. It's not an easy fix, but it might be able to bring that down. So you identify a problem, you fix the problem. The question now is, how do you maintain this? And the last step to fixing the problem, I suggested to maybe consider domain-driven design. Because one of the aspects of a domain-driven design is to do defining boundaries. Boundaries are great in relationships. not just for code, but for personal reasons as well. But it really works well in code. There's a lot of tools out there that helps you define boundaries. ESLint, NX provides that type of ability. I'm not sure if Gradle in the Java ecosystem have it. If there isn't, we should probably open an issue and make that available. So defining boundaries helps you limit the scope around your projects. Hopefully you don't have to run into that situation again that you have to fix this problem. The other approach, or another approach to handle this, is to do automated code modifications. Automated code modifications allows you to standardize how code should change. If people are willy-nilly going into the code base without the mindset or the intent, there might be lingering references that should have been removed. Starting off with automated code modifications and making sure that your projects are defined up front in a standard format, one, actually allows you to refactor your entire code base into a different fashion if you need to, but also guarantees that they're probably not going to be missing appropriate tags or boundaries. So, to wrap up, if you didn't listen to this, I'm calling you out. The first thing about all of this, what is dependency graph? Dependency graph has been around forever. It's been part of our society since the dawn of people. Why does it matter? It's going to impact your delivery time and your developer feedback. It slows down development and delivery. What you should be doing is audit the situation, fix the problem, and then maintain it. You know, a couple years ago, John Oliver made a joke about my city, Pittsburgh, about we have a bridge underneath another bridge to maintain the infrastructure. I think it's pretty great. But it kind of showcases that we as a populace kind of suck at maintaining, and I'm here advocating for more and more time around maintenance. If all else fails associated to this, or you don't actually have this problem, then it's okay to actually evaluate to switch from just to VTest or ESBuild to roll down or some other type of approach. Because at the end of all this, the hope is when you make a change and camera, sorry to make this another switch. I'm gonna wait. Cool. Hopefully, by the end of all of this and you reevaluate your situation, when you pull on this string, nothing has changed. Thank you very much.
Thank you, Josh. I have something for you, by the way. I stole your scissors. So we have a running joke in our family. We end up with our own little sayings around the house, and it's relevant to Josh's talk. But like in our bathroom, we couldn't come up with the linen closet as the name of that. So forever and throughout the rest of our family, it will forever be known as a bathroom pantry. But I bring that up to bring up the other one, is that if something's being done willy-nilly, as Josh referenced a few times, and it's a little bit more formal than that, it could be William-nillium. So feel free to use that one as well.
I have to say I didn't fully get the joke because I'm not a native speaker. Sorry.
I'm sorry. I'll fill you in. It'll be cool.
Thank you.
So we're going to take a little bit of a break. So again, thank you to our first two speakers and our keynote. And then we'll be resuming. We're going to start back up in a half hour at 11:35. So go take a break, stretch your legs. So it's track rooms if you want.
And while you're at the break, don't forget to go enter our survey to enter the raffle for the cat and the guitar. The fake cat.
The fake cat, yes. Thank you.
Hello? Okay, it's working now.
See, you test with your voice. I'm here tapping on the microphone. Everybody have a good break? Feeling relaxed? Excellent. Get some coffee, some drinks, some refreshments.
Did you eat your fruit and your nuts?
Yes.
I did also.
Feeling good. Feeling good. Ready to get things rolling yet again. You got anything?
No, go ahead.
Okay. We're just going to right to it and get rolling with talks again. So we're going to welcome to the stage Ankit Jain, who is the CEO and founder of Aviator. So put it together for Ankit.
Testing? Can people hear me? Cool. All right. Today we will be talking about scaling ownership to improve developer experience. So before we get started, the main thing I would want everyone to get out of this conversation is not even a solution, but like really understanding why ownership is even a problem. And obviously everyone will have different ways of thinking about it, and I would want to kind of like present many different ideas that we've had discussed with different people, and we'll see kind of like how this resonates with everyone. So let's get started a little bit. Let's see if this guy works. Okay. One more time. Okay, I'm going to just use the keyboard here. So a little bit my background. I'm a software engineer, previously used to work at Google, and have worked at a bunch of startups. Founder and CEO of a company called Aviator, like the sunglasses. We are building a Google-level engineering productivity seat. So what does that really mean? So we're essentially trying to bring some of the best practices that I've observed myself at Google, bring that to the rest of the engineering in the world. And so ownership. So why is ownership even important? Like, why should we think about it? And this is probably one of the most important things we should really get out of this session. Ownership represents the responsibility of an asset. When we think about development, right, any kind of code that you're writing, that requires ownership. Operations like DevOps, that requires ownership of services. You're thinking about strategy, you're thinking about compliance, you're thinking about resourcing. In summary, what we're looking at is accountability. So essentially, when things go wrong, who do I call? And this is one thing where ownership becomes important. And especially, we are in Monorepo World, so as your code bases grow, as your teams grow, this is where ownership is very critical for teams to understand, and that's what we will try to dive into. So let's kind of like think a little bit about when we think about ownership, what do people mostly think about? The most obvious idea that comes in mind is code owners. So code owners, I'm guessing many of you are familiar with, it kind of like looks like this. Especially if you have a monorepo, it probably looks like 200, 300 lines of similar structure. And you have like different organizations, different teams. How do you kind of like really make sense of it? But before we go into it, one thing I would like to emphasize is ownership is not the same thing as code reviewership. What you looked at in code owners is only a small fractional part of it. When we think about ownership, let's look into where else these things exist today. So we have service catalogs. I don't know how many folks are familiar with here. There's a concept of IDPs, internal developer portals. Backstage is one of the open source one, which many teams adopt. And this is also one place where we try to define ownership. But it doesn't just end there. We have Git history, right? All your Git history, everyone who's doing the commits also represents like who's owning what pieces of code. We have GitHub teams. Again, you're defining ownership here, like which teams define who owns what pieces of code. And we have ownership in a lot of different places, right? We have this ownership information, teams information in Gusto, in your HR tools. You have it in your alerting systems when you define like, okay, this is the PagerDuty escalation policy that I own. There is like, a Sentry or Bugsnag or error tracking systems where you own this. You have like Okta where you're again defining who owns what pieces of systems. So all I'm trying to explain here is ownership isn't really just tied to code owners. We're looking at ownership from the perspective of every piece, every asset that the developer has to interact with. on a day-to-day basis. And why is it so hard to scale this ownership in large organizations? One of the key challenges is organizations are living, breathing things, right? People change. New people are introduced. You have organic growth. You go from like a 40% company to a 200% company, right? You shift priorities. There are reorgs that happens. People change within the organizations, different teams. And there is a very high probability of people moving within the teams rather than people leaving the company. People move, ownership becomes much more complicated. So how do we solve this? Before we even solve this, we really have to understand technology doesn't always mirror the org chart. This is how your teams might look like, but that's how your services and systems may look like. They're not really directly tied to one-to-one. So how do we think about really understanding these things? One way to think about it is instead of thinking of individuals, everything should be tied to teams. So essentially, you go from one person owning a service to actually teams owning the service. So you define teams and capture their hierarchy. Because we have the org chart, it makes it easier for you to understand who owns what pieces of code, but also how does this bubble up at different hierarchy levels. And then you define the roles and responsibilities. So once you know how do you represent the teams logically, you can define these responsibilities. And at the last step is when you define the assets. And these assets are now tied to the teams and not to individuals. So what is a software asset? Now, if we go broadly, a software asset is any digital entity that should have an owner. So let's take some examples. All of these things are potentially assets. All of these things are something that developers touch. All of these things are something that should have an owner. So one way to really build a more generic purpose layer to understand assets is you build asset providers. So asset provider could be a team who's managing your database. An asset provider could be a team who's managing your GitHub instance. An asset provider could be your PagerDuty or your on-call system. And then you can group them together. Now you have a different level. Okay, we have a product team which owns now multiple different web applications, and those web applications have a front end and a back end. So you can define that groups and hierarchy and define those relationships. And that would make your asset representation easier for you to manage. And you can define now ownership at different levels. So taking a few original sources, you can now define a single source of truth for ownership. So think about taking your Git history, and in this case, Git history could be your code owners file, and you take your employee data, which is coming from your HR system. Now, the reason we take employee data is because this is the one source of information which is always going to be true. You're not going to have employee data of people who have already left the organization, or you're not going to have employee data of people who don't work at the organization. So taking those things, we define something what we call a team identity. And instead of it being a passive information source, you can inject that information now into all the different systems that require ownership. So instead of having to define these ownerships now in your escalation policies, in your code owners, in your infrastructure, in your service catalogs, you can have a single entity and send all of this information across all different assets, across all the different things that developers touch. Now, why would we want to do that? One way to think about it is, you're taking this information. Now, it's not just an independent team that you have randomly defined. There is a relationship of parent-child. So essentially, if you think about, there is first-level managers, and it rolls up into different organizations. So each team has a parent-child relationship. And why is that hierarchy important? It's important because when you make this representation of ownership, which teams own which pieces of systems. Let's say a reorg happens, a team moves, people move, and the team doesn't exist anymore. You can automatically build a system which actually passes on the responsibility to the parent team. And the advantage here is now your assets are never orphaned. Now you always know who to call when an incident happens. Eventually, sure, that parent team may be a director or a VP level who may have to reassign it to another team. But you always have somebody who takes care of your asset. There's always somebody who's going to take care of who should we call? Who's responsible for taking these steps? So let's look at a little bit of examples of like, what does it mean by managing assets within the team identity? So this team identity now is where you can populate your code owners. So essentially, instead of having a static code owners, now having a single source of truth, now this pipeline pushes any changes in your organization structure directly into your code owners. So if you have a monorepo with 200 lines of code owners file, you don't need to manually manage it. You don't have these zombie teams. You don't have these zombie individuals who own different codes path. And then once they leave the organization, you don't have understanding of who owns what. Likewise, now in test health, you know by different code bases, different code paths, who are the ones who are kind of like managing the test. So especially in a large monorepo, when there's like different test filling at different paths, you can automatically, looking at the stack trace, identify this is the team who is responsible for these tests and kind of automatically assign tickets to them. So you can tie this to Jira, you can tie this to your ticket management system, and fetch all of the test health information from your different systems. Likewise in release management, if you have a lot of different releases going from your monorepos, you can now break it down because you have tied now code paths and assets to these different teams, and you can split them by different services and deploy them independently. I already described a little bit on the bug, on the testing, but this also works in monitoring systems. So kind of like looking at your Sentry data or your error tracking systems, you can automatically track who owns these services and how do we assign these issues to those teams. And likewise, now you can measure, understand productivity. You can measure these DORA metrics, lead time for changes, change failure rates. If you're deploying these services independently, you can track how your delivery performance is in each team and be able to even understand like, oh, our iOS team and Android teams have differences in how they're deploying, and can we kind of like find where the inefficiencies are and be able to automatically track all of this information without having to manually keep on tracking ownership. And this is just tracking the surface, right? You can start trying to identify ownership drifts. So suddenly, even if the teams exist, maybe they stopped writing code to this. Maybe there are other teams who started contributing to these pieces of code. Can we automatically introduce them into this code base? Can we automatically add them as owners? Can we track technical debt at different levels? Now you can track it, like if you're defining these hierarchies, you can track it like a product level. You can track it a particular platform level. You can track it particular feature level. What is the tech debt? How do we identify this? How do we improve on it? How do we define goals for these organizations? You can track code review bottlenecks, like where or how are we performing as a team in terms of code review health? Should we have different teams own these different responsibility of how quickly do we respond back to reviews? What is like overall the quality of bugs, quality of code that's written in different pieces of your code of your team? And you can do that now based on the team level information and be able to collectively, as teams, grow and improve. And that's overall around scaling developer experience. I would love to, again, if you take one thing back from this session, it should be that understanding ownership at an organization level is important, and being able to track different assets is very complicated. And again, it makes, especially as your organization grows, it's living, breathing. You're going to have drifts. You're going to have people leave. You're going to have teams move across different teams. Having a central place of identifying these ownership makes a huge difference in how your teams operate, how your teams really understand inefficiencies within your developer experience, and make it easier for developers to really understand like who owns what pieces of systems, and make it easy for you to go and track them. A quick note on Aviator itself. We as a company started 3 years ago. We help improve engineering productivity at all different stages. There are 4 core products outside of Teams. So Teams, again, what I described here, the product doesn't exist today. This is something that we are working on, but would happy to chat with anyone who's interested in learning more. These are some of the products that we already have that we build and scale with our different organizations. StackPure is a product that helps, it's an open source CLI that you can use to break down your changes into smaller changes, makes it easier for people to review, improves your code review response times because smaller changes have been statistically proven to be faster and easier to review. We have a system called Attention Set, which is inspired again from Google's Gerrit. This is a system that helps you track the changes which require your attention. For instance, as a reviewer, when I respond back to a code change, the attention is passed back to the owner, the author, and when author is creating making changes in their PR and sending back the review back to the reviewer, the attention is passed back to the reviewer. There's also a Chrome extension that helps it easy to track this attention, especially in large repositories and different multiple repositories. You can actually track all of these things together. You might have heard the talk from the other side as well on merge queues. So we do have like a merge queue that works with NX systems. So especially if you have large monorepos, it creates a distributed queue based on your NX graph. And based on your dependencies, you can distribute the queues. And last but not the least, our product release management, which makes it easy for teams to manage releases, makes it easier for each individual developer to track what changes are going out. This is again tied to the dependency graph as well as teams. So if you have a monorepo and you do multiple releases, it identifies what changes are getting targeted and impacted based on the things that you're releasing, and makes it easier for developers to manage releases, cherry picks, rollbacks, all of those things together. So that's it. Thank you so much for listening. If you have any questions, you can always email me, and check it out, aviator.co/identity. Again, teams and ownership is a place we are actively exploring and learning more. We also run a community, we call it dx.community. It's like NX, but with D. dx.community, which is a place where we learn and talk about many different developer experience topics. Come meet us there. We do virtual sessions as well as in person, working with many different organizations to learn about a developer experience. With that, thank you very much. I don't know whether they're taking questions here, or I'm happy to chat on the side with everyone. Are we taking questions here, or should we just move on the side?
We do have a little bit of time. If somebody has questions, we can do that.
Let me take, yes. I can take the...
Was there any question? Yeah, there was. Okay.
You mentioned investing in tools to detect drifts between kind of ownership and Git commit history as being a good path. Do you have any open source tools that already exist that you would recommend for starting down that path?
That's a good question. So we do not know directly of tools that do that, but the algorithm itself is pretty straightforward. Like you essentially look at the last X number of commits, and generally we look at like last 100 commits and identify who are making those commits and seeing whether they're part of the same teams. The reason you want to do commits versus time is because different parts of code base move at different speed. So you don't want all of them to be, if a library only gets modified twice a year because you have to just do upgrades twice a year, you don't want that be assigned to other people. And also the other part is many organizations have these libraries and frameworks where they will do horizontal changes, where there's like a platform team who's actually making changes across all different libraries, and they don't necessarily own those libraries as well. Cool. All right. I'm also available on the side, so if you have any questions, happy to chat on the side as well. Good? All right. Thank you so much.
That was awesome. I appreciate you being willing to take questions. That's a brave thing to do up on stage.
Thank you. I'll go down.
Yeah, they'll have the mic over there for you. So we're going to give everybody, again, a chance to switch rooms if you want. And I keep on staying in the middle and get blinded. That's OK. That's a me problem. But if you want to switch tracks or what have you, you'll have a few minutes to do that now. And then we'll get on to our next speaker here in a few minutes.
But just a few minutes, don't go far. Okay, so we're almost ready to start. Just a quick reminder before we start that be sure to, again, check out the code of conduct and make sure you abide by it. And just keep this in mind. And also, if you notice any violations, just come up to us and let us know. Yeah.
Safe space for you and everyone around you.
Yes.
Also, just a reminder, lunch, it will be here, the same place breakfast was. If you weren't early enough to make breakfast this morning, it's kind of in the area between the two track rooms.
Yes, that's correct. And should we invite to the stage
Yeah,
John?
absolutely. I
Go-
got a French lesson beforehand. All right, computer's awake, and I think we're ready to roll. Okay, so please, everybody, put your hands together. Warm welcome for Jonathan Gillin. I'll take it.
Hey, hello everyone. First of all, I'm really excited to be here at that first Monorepo World conference. And today I want to put on the table difficult debate. Should we use the poly repository architecture or the monorepo architecture? Yeah, we are on the monorepo conference, but yeah, it's still a debate, right? So, and there is, another one. Should we merge all of the repositories into one? It's something we do like to do these days, right? But before we talk about that, let's first have a look of the benefits we will have for each architecture. So for the poly repository, mainly, I will not enter in each details, but if you have too much interaction between the teams, if you need an isolation between your products, that will be a good architecture. And it's also, without having to add extra tools, you will have, a better isolation. On the other hand, the monorepo architecture, so we all know the benefits. You will have, a better way to share your code and to unify your way of working. And it's also interesting for team collaboration, right? People will have to work together, so it's interesting for that. So why do we have to choose one or the other? Maybe we can choose both, right? We can have the list of benefits for this both architecture. And this is what I will present today. It's the distributed architecture. It's when you have multiple monorepos. So you will have one monorepo for your organization with all of your applications and your tools, and you will try to support multiple monorepo with that central monorepo. So I am Jonathan Gelin, and I am freelance software engineer, and I'm just supporting companies in improving their software development cycle, and I'm using Enix to do that mainly. Today I'm working for Caseware, and this is where we are putting in place that type of architecture. So I like to name it the polymonorepo architecture, the best of the two worlds. So in which use case we can have that? For example, if you have franchised monorepo, so you are selling a brand, so you are providing everything other companies, all of the tools you will need to to support different monorepo like hosting frameworks. That can be a good use case. Or maybe you are working at Enix, and that's a perfect example of supporting many monorepos, right? They are providing many different features, and they have to be sure the upgrade will be smooth. So to be able to achieve that architecture, you will need to follow 4 phases. First, we will focus on the central monorepo, so your organization monorepo, and because you will need to prepare it to be sure you can support the others. And one aspect of that you need to focus on is the conventions. It's maybe we have different names, but it's a way to unify your way of working. So, for example, a workspace layout. It's a convention, right? It's a simple one, but by default you will have that mindset of I want to structure my code and my files in a unified way. I will not allow to have 10 different ways of structuring your applications, for example. Another conventions that you will have in your monorepo could be the naming convention, right? We also have that habit of naming our project in a way that you recognize directly what that project will do. So by role, for example. So any unification you will put in your monorepo can be conventions, like you will configure your projects. I put also the design system here because maybe it's not directly linked to your monorepo, but it's also a way, this idea of trying to unify the way your users will work, right? It's also kind of a convention, right? You try to align the way your application would look like. Same for the linting rules, right? The linting rules, you will try to ensure that the way you will code in your monorepo will look the same. So you are creating linting rules. So any alignments in general. So you have a big ball of conventions, and it's everything you want to have in your monorepo. And by doing that, you will start to discover that you have different type of projects, that you will have maybe different libraries that would look the same. So it's interesting because you will be able to identify your projects and classify them by type. And yeah, you can have multiple dimensions, but usually at the end, I see that the project types will be defined by a stack, right? The technologies you are using, and the role it will serve, right? If it's a feature, if it's data access project, and also the scope, right? Sometimes, depending of the team or of the product, you will have different type of project, different configurations. So that's the way I would define a project type in general. Okay, so we saw that we need conventions, that it's important. It's even a core concept of the monorepo in general. So it's more a mindset. But now let's see what we can put in place in our monorepo to facilitate the adoption of these conventions. So I generally have two poles for that in that strategy. So we will have the NX plugin architecture, and we'll have the housekeeper. So the NX plugin architecture, it's not that new, but it's an NX plugin is just a specific type of library in your monorepo. It's a way to maybe support your monorepo in an easy way. So it will provide multiple features. Each plugin can be part of one of the dimensions of your project type. So you can have a plugin, for example, for your stack, for example, for React, or you can have a plugin for that will be used for a specific technology and a specific scope. So, for example, maybe you have specific configuration for React for that product, for example. So you will have really a set of plugins that will match these different dimensions. Okay, so what type of feature do we have? It's quite known already, but let's see how we can use these features to apply our conventions. So first of all, we have the code generation. So the other name is generators. So what is a generator? A generator is a way to generate your code in the same way. So it's a way to apply your convention, right? Because whatever you will generate, an application, a library, a component, or anything you want, you will generate it in the same way. So you will already unify the way you will generate your code. So it's a good way, for applying conventions for your monorepo. And when you will create your generators, you will also organize them in your plugin, right? So like I said, you will have different plugins, maybe for your technologies, maybe for your team, for your product, and you will, organize your generators in each of these plugins. So like I said, generators, it's a good way of applying your convention. So we will put that in our plugin. Then we'll have the task abstraction. The tiny name is more the executors. It's also a good way for applying conventions because you will specify that what if you want to build any type of project, you will use always the same task name. You will not care about the technologies you have behind. You will implement an executor for that. So it can be a Java or a React project. You will use the same keyword for that. So it's kind of a convention, right? We create an abstract layer for your task, and we decided that you will always use that name for your way of working in your monorepo. So that's also a good way for adopting the conventions. And we will, again, organize these executors in each plugin. So we will also have that feature in our NX plugin. So again, we have a good set for applying our convention. The third one, it's my favorite one, is the infrared configurations. It's a way to remove duplication, because when we say conventions and when we talk about generators or executors, we try to remove duplications. We try to avoid that we have different type of configurations. So the infrared configurations, it's a feature from NX that will scan your repo, recognize some patterns, and based on those patterns, will inject configuration automatically. So for example, if you have a Jest configuration in your project, you know that you will probably have to run tests, right? So you can inject that test configuration. Same for OpenAPI. For example, here we decided that we have an OpenAPI YAML file, so you know that maybe you want to generate data transfer objects, right? So it's also a way to inject configuration automatically. And you can do that for an entire product, right? Maybe you have plugins for a list of products, and you can decide to inject the configurations for that. So it's also a good way to centralize, to be sure you will not duplicate these configurations. So you can implement your conventions there. And you will also organize that in each plugin, of course. So another feature that we can put in our plugin, right? The last one is not directly related to the NX plugin, but it's just a common sense of using sharing libraries, is when you want to share some code. So we talk about the infrared configuration to centralize the NX project configurations, but you can do that for any type of tools that you have in your monorepo. For example, here I have many libraries that are using Jest. The Jest configuration is all the time the same. So instead of having to maintain each time these configurations, you can centralize that configuration and put that in your plugin too, right? And you can do that for any type of configuration. So you can do that for Jest, for TypeScript, for your ESLint rules, or even for Webpack configuration. So it's also a good way, it's good to focus on project configurations, but also for the other tools, right? Not just NX. So we can also put that in our NX plugin. Something also interesting to look at, it's the way you will organize your plugins. So I like to see 3 different types of layers. You can have more than that. But the first one is the community NX plugins. I really like first to fit to the standards and not have to maintain that code. So it's really important to try to reuse what another repository is doing. So it can be, NX is already providing a lot of different plugins, but you have other plugins like NXWorks for Java could be also useful. And then you have a second layer where you will just add your specificities for your monorepo. So you also have a list of plugins per technologies that will mainly just extend the standard one, right? And you will just add configurations, so that's interesting for your monorepo. And then the extra layer is more, when it's more business related, is where you have something really specific because of that specific context or that specific app or for that team. When you have multiple teams, maybe they want to work in different way. So you provide, this type of plugins that will just combine maybe other plugins. And by using that plugin for product A, maybe you can generate a full stack, for example. So it's, also an interesting view of, organizing your plugins. Okay, so we have now all of our plugins implemented. We organize everything. We have all of the features. And there is something really important too is, to be sure people will use these plugins. And this is where, here I name it Housekeeper, but it's important to have a tool to ensure that people will use these plugins. So you cannot ensure that people will use your generators. You cannot ensure that they will, use executors, and they will also maybe match your infrared configuration patterns. So it could be interesting to have a tool that will check the state of your entire monorepo, and that will ensure that it matches what you implemented in your NX plugin architecture. So for us, we just implemented a simple test runner. We just implemented a list of tests by using the Node.js test runner. It's a simple library, and we just scan the entire monorepo, and we validate that it's match what we implemented in our plugins. So then we can really ensure that each time we made a modification in our plugin, it will be reflected in the entire monorepo. How we do that? Mainly we just execute that in our CI, and then we have the result, and we have different level of criticality. And if we are not matching, for example, a blocker criticality, then the build fail. We also have a UI that will, for example, organize these rules per team, and then each team knows if they are matching your set of conventions. So even incrementally, they can do that later on, for example. And yeah, I had to add that slide because it's something new, but NX provide that kind of tools today too. So it's the conformance. It's a good way for also validating that your monorepo is matching your conventions. And if you want more detail about this type of tool, I encourage you to attend to that talk from Nicolas Bossa. He will only focus on this type of tool. Okay, so we kind of, have a good central monorepo now. We have all of the tools we need. We have all conventions, so it's working well for our central monorepo. Good, but how can we now, share that with our distributed monorepo? So first of all, we will need to expose that. We will need to be sure it will be accessible for our distributed monorepo. And here I will explain 3 other features that can be useful. The first one is the NX presets. If we are using NX, you probably use that already. Is that will allow you to generate a new monorepo, right? If you want to have a distributed monorepo, you first have to generate it. So that's the first step of creating a distributed monorepo. And NX by default is providing a list of presets. So it will create an empty workspace first, and then it will add configurations related to your stack that you want to use. But if you want to have specific customizations, then you can have your presets for that. If you want to have a preset in your current monorepo, you can use that generator, right? And what that generator will do, it will generate an empty workspace, and then you will have other way to add extra organization configurations. So that's the first step for being able to have distributed monorepo, is to generate it. The second one is to maintain it on long term, right? Each time you are making modifications in your central monorepo, you want to be sure it will be applied on the distributed monorepo. So that's called the NX migrations. And if you are, again, using NX, you know that command to upgrade your monorepo to the latest version. It's just a way to apply the migrations to your monorepo. And again, you can run migrations on your specific library. So it's something that is open. You can reuse the same command. So if you want to generate migrations in your monorepo, you can, again, use a generator. What that command will do, it will generate migrations.json that will contain all of your migrations. And then it will initialize already a migration generator, because a migration is just a generator, finally, that is executed. In NX migration, we have 2 aspects. One, which is a list of generators. So you will be able, in that migrations.json, to specify a list of generators. And each time, it will be related to a specific version of your library. And on the other side, you will also have a way to upgrade automatically the packages on the distributed monorepo. You are maintaining your monorepo, so you want to be sure it will be compatible with your NX plugin architecture, for example. And something interesting too is that it's something you will be able to add to your NX plugin. It's also a feature of the NX plugin. So, it's again interesting to have that set of NX plugin in your central monorepo. Okay, so we have the preset to generate our NX monorepo, distributed monorepo. We have the list of migrations. Okay, it's good, but we need now to expose all of that. And yeah, this is where I like to create the concept of the dev kit, right? So we will put in that dev kit everything we need, that we want to expose to the distributed monorepo. So here we'll have our NX plugins, our presets, and also the housekeeper. And what you can use to expose that, you can use the NX release. I will not go too deep in the details for that way of working, but NX release is really useful because it knows really well your monorepo, and it will really facilitate the publication of that dev kit. Okay, so now we publish everything. Everything is available, but how can we use that, right? We don't know how to use it. And that's quite simple. We have just to know 3 commands, and maybe even less, because the first one will be the command to generate that distributed monorepo. So you just use your presets. The second command will be the migrate, the way to apply, to execute your migration. So each time you want to maintain the distributed monorepo, you can use that command, and it will apply all migrations, but it will also upgrade your plugins, so you will be able to access to all of the new generators, executors, infrared configuration by default. You don't have to do anything else. And the last one is, to be sure that you are in line, you are aligned with with the central monorepo. So you will also execute the housekeeper CLI. And usually we just put that on the CI configuration, so you know directly if something is wrong. All right, so it's not a question about should we use poly repositories or monorepo. Depending on the context, yeah, you will maybe choose one or the other. In that context, we need both, right? So we will have a set of monorepos in that distributed architecture. And how can we achieve that? Yeah, you can follow 4 phases. The first one is the mindset. You need to be sure that you have the mindset of trying to unify your monorepo to follow conventions. The second one is providing tools, providing utilities to be sure to facilitate the adoptions of these conventions. And it's also useful to have a tool to be sure you are using them, because otherwise you can sometimes be not in sync with these configurations. And the third one is how you can expose that. So you have extra features in NX that will allow you to maintain this distributed monorepo. And finally, easy peasy, you just have to apply these different configurations on your distributed monorepo. If you want, all of details related to that presentation is in the article on my blog, so you can have a look. It's already published probably. And yeah, thank you all.
Loving all this content today. This is great.
Yeah, that's true.
Yeah. Got a quick question. We're going to wait a few minutes to start the next talk because we want to try and keep the 2 rooms on the same schedule. So we're going to follow what's currently posted for that. So we have, my watch isn't turning on. There we go. About 10 minutes before we're going to start the next talk. But so if you want to go grab a drink or what have you, switch rooms, give you some time to do that. But I'm just curious, what's everybody excited about for tonight's party? Karaoke. I knew karaoke was coming out about. Do you want to give any secrets away of what you're singing? Anybody else? What are you excited for? Tron? The Tron credits, yes.
Okay.
Exactly. You have to at least make it for that. Shout them out if you have anything.
Open bar.
Open bar. I don't. You're the one that would know. No? Okay. You said yes? Okay. You got the rubber stamp going for that. Perfect. All right. So we're going to be back here in now about like 8 or 9 minutes. So feel free, like I said, stretch your legs, grab a drink, write some code, whatever you're doing.
Okay, so now the 10 minutes buffer break is over, and we're ready to start with our next session.
Absolutely.
Yes, and
Yeah.
okay. After James finishes, there will be lunch. We are going to go into more details after James finishes. Right?
Yep. We'll come up. We'll give you a little bit more details about what's
Yes.
going to go on with lunch, a few reminders about the rest of the day, and then we'll dismiss you to lunch. That sounded like school a lot. And then class, we will dismiss you, and you can go get some food in the cafeteria. No, we'll give you a few more details and then a little bit more information then. But before that, don't let your stomachs grumble too loudly. We're going to welcome to the stage James Nislau.
Nimlas.
Hello, I am James Nimlas, and this is my presentation, how Webflow scales its monorepo to bring superpowers for everyone to build for the web. I am a staff software engineer at Webflow, working on developer productivity. All right. So if you didn't know, Webflow is a platform for building and managing websites at all levels of complexity. It is a web experience platform. The majority of Webflow application is housed in a single monorepo. It's got almost 4 million lines of TypeScript and JavaScript. That's not the node modules. That's everything except node modules. And this is in about 25,000 files. And we have 704 NX projects, and last week we merged 319 pull requests by 109 different people. A brief history. In 2012, Vlad made the first commit to this repository, and it is the same repository we use today. There are still lines that you can get blame Vlad on. Now, over time, they modernized. It was jQuery, monolith, Node.js server. Then they added Webpack, Babel, et cetera. In 2016, they added Cypress to enable writing end-to-end tests. Webflow was bootstrapped, meaning it was fully self-funded until 2019 when it first raised capital. When you're scrappy like that, things like build system usually go by the wayside. It's volunteer hours effectively. And so by 2021, people were really gung-ho about writing those end-to-end tests, and they wrote 2,500. And deploys could be up to 2 hours, which is absolutely atrocious. Like, it was just uncomfortable, right? These tests were slow, they were flaky. Developers stopped trusting them. They were just hitting retry over and over until it would get it working. However, we made a concerted effort to make this better, and we got deploys down to 15 minutes by 2023, 2 years later. And that was while multiplying our Cypress tests to 6,000. Wow, James, how did you get your builds to 15 minutes from you? Thank you. Well, we spent a bunch of money. Okay, it's not entirely accurate. Obviously, we didn't just spend a bunch of money, and it took us 2 years. We parallelized all the things, which if you've done this at your own homegrown situation, especially without a tool like NX, you're getting just an incredible number of simultaneously running jobs. And if you'll notice, I've highlighted that this build passed in over 21 minutes, which is more than 15, which I just said we got to, right? Well, this was the same year that we got to 15 minutes, and developers are still writing code. Like, won't they just stop already? So, yeah, it was an unwinnable battle, right? We were just continually fighting, trying to add more agents to take on more shards and to try to keep the build down to 15 minutes, but it wasn't scaling. And so really, we hit a wall, right? We were just constantly battling. We couldn't get it lower than 15 minutes. So we needed new technology. We needed something to help us manage this. So we did our research. Now, this is very specific comparison to our needs. I would not take this as some sort of general tools, right? Overall, we analyzed 13 different tools. About half of them were unmaintained, and so they seemed like easy rejections. In regards to this, I would definitely look at the framework across the top that we use. We looked at how these different tools might impact developer iteration. Very bad. Double arrow negative, right? But then, you know, NX, Turborepo, Bazel, RushStack, these were all going to improve how fast developers could iterate. Some a little bit more than others, potentially. Then we looked at developer disruption. Obviously, if we just left everything the same, developers wouldn't need to go through a migration phase. However, we would never improve. And so there's obviously some developer disruption with migrating, but it's acceptable compared to what benefits we're getting, right? There's cost, the total cost to migrate. This is both any actual costs you end up spending towards a company, consultancy, and, you know, effort that your developers put in to get it to this point. Then there's the ongoing cost of maintenance, how much time you have to put into maintaining the tools that you build for it. And then finally, of course, there's the overall ending system complexity. Is the system better? Is it less complex? Is it easier to navigate for your average developer, right? For us, the differentiating feature was the built-in workspace analysis. We could turn on NX, and then we could immediately start filtering out these irrelevant tests that we were running in 300 jest shards, right? Here was our overall migration timeline. So I spent about a month planning and doing all this analysis and research, and then we needed to normalize our code base. We ended up, you know, plugging in NX and refactoring a little bit, and then we really started diving in and more completely integrating with NX. So when we got started, we really needed to normalize our code base, right? Specifically our custom system. We had our own custom Monorepo library management system, and it allowed for projects to be nested within each other. That was an explicit original requirement. However, that wasn't really compatible with how NX worked, and so we needed to normalize them and flatten them. Then, of course, we moved on to using NX affected with our existing system. So we haven't migrated from BuildKite. We still have our own custom pipeline generator, et cetera, but we use NX in front of it. We wrap it in NX, wrap the pipeline generation so that we can start seeing what types of results we can get, and we can start making progress on this sort of unwinnable effort. Even though it is less effective than if we had a fully integrated, fully implemented NX plugins, et cetera, it was still worth it to sort of get something going, see something happen. So then we're going to more full integration, right? This is when we're removing our bespoke build system, our scripts, and we're using the NX CLI, and we're starting to define these same scripts that we had sort of ad hoc throughout our code base in you know, shell scripts, and we started putting them as NX targets and making some consistency. Then we started actually migrating to NX plugins that are available for install. And then, of course, there's the complete migration. It's replacing all of the strange bespoke things that we have with NX executors and plugins. To be honest, we're not done with that, and we might never be. We definitely still have a grunt task that runs in our CI. Oops. That was an extra slide. So lastly, as part of this complete integration, we added remote caching. So we replaced our custom caching system with a custom task runner and caching in S3. And that was, bit by bit, we're sort of getting into the NX world and following these conventions and being able to take advantage of all of the sort of consistency in this realm that NX has created. And then we slowly started enabling build and test caching. So because we had this custom system, we didn't have these inputs, these correctly defined inputs and outputs. In fact, we still have a public folder at the root of our monorepo, and that's where some of our front-end applications live. They aren't actually still served as a list of JavaScript files put directly into the HTML. They're bundled, et cetera, but because of inertia, we just haven't gotten to a place where we can move them. But NX is okay with that. It sort of let us define these weird things and keep going. So specific challenges, it's me. So really it was our own legacy code for the most part that was holding us back. That's what takes the most time when sort of getting it together and merging with NX. And so my recommendations would be migrate sooner than later if this is something you're looking into. And secondly, any consistent system is better than no system, right? So Jonathan was saying in the previous presentation, getting conventions and conformance and defining that and making sure that your projects are following these conventions is very important. Also, how to have this smooth migration. So the worst case is that you have a new build system and you're hyping it up, and then you forget a implicit dependency or a target input, and suddenly everything breaks, it's in dev, all the developers are complaining that their local won't start, et cetera, right? So what we had implemented is both we used a merge queue, and we used affected to skip steps, to skip tests on the PR builds. However, we still ran everything when it was in the queue. And this enabled us to have this extra fail-safe. Even though it was going to cost a little bit extra, that added safety was really worth it. And secondly, we just disabled caching to start. We just didn't even turn it on until we were really feeling very comfortable with how we define these things. And then again, we enabled it methodically and purposefully. We only turned it on in PR builds, and we have not yet enabled it in the merge queue or deploy or production deploys. So what was our return on investment, right? How can you, I really want to, as part of this talk, hopefully you can use this to bring back to your own organization if you're having trouble evangelizing and prioritizing some sort of a migration to a tool. We saw a 48% decrease in AWS CI costs. And we saw some builds that would take only 7 minutes. And then our median build time got to 20 minutes. And you're probably saying, wait, weren't you just already at 20 minutes? Well, it was 21.5 or something, it's a 6% decrease. It's okay, it's not super great. But I want to bring you back to our migration timeline. Those results actually came from here. And actually, we're over here now, right? And so where are we now? We're actually at 12.8-minute median builds, having continued our integration with NX as we continuously deliver results and able to show sort of what we're getting at. On top of that, we've seen an amazing increase in developer productivity using sort of this, using NX. And again, I'm not purposefully just evangelizing NX, that's the tool we chose. But we saw a 68% increase in mean deploys per week over the last 6 months. We've seen a 22% decrease in change lead time. This is the time between the first commit on a PR to when it's actually deployed into production. And then very significantly, we saw a 31% decrease in change failure rates over those 6 months. Right? We're talking actually, in this case, we're talking about a 3% to 2% change failure rate, which is still very great, right? And this is very important for us because we are definitely still in the phase transitioning from a startup to an enterprise. And we really need to show to those large customers that we care about how consistent and stable our product is. What about improvement? Specifically, we've seen an amazing impact on how fast we can scaffold new apps. Remember how I talked about this was originally a monolithic Node.js server back in 2012? Well, it is still very much a monolithic Node.js server, just within a monorepo, okay? However, teams are now recognizing that they really want to break away from this monolithic server. They want to start having more agency when they're creating applications, when they're starting new features. And we've seen, before it was cumbersome. People had to walk through this and figure it out on their own, right? Now with NX, we've got documentation. I mean, we don't know. We just, ultimately, as long as the feature requirements are satisfied, that is the end goal, right? So we should get there first, and then we can do these extra optimizations. We can look further into what these choices are. What were our overall lessons learned? So, of course, one, migrating is absolutely worth it. If you are existing in a monorepo that doesn't have one of these amazing tools that's out there, you should really start looking into them and trying to see what it might take to get it implemented. Obviously, our results substantiated our effort, but it wasn't known beforehand. We had some really good guesses, potentially, but we were sort of hoping. And hopefully you could also use our results to say, look, this is one example, and they were a legacy code base, and they implemented one of these great tools, and they saved substantial amounts of money. Second is that actually the NX project graph is not all-knowing. So this is something that I didn't realize before, but the project graph doesn't include target inputs, and my preference, looking at it from a fully free customer, because we are not paying NX yet, is that a combined project target graph would cut some of the waste for us, because we're still spinning up some of these agents to run these tasks that then find that that it's okay to use the cache, and they just run that. Now, I do have to say also that using NX Cloud and using DTE completely alleviates this issue, because it's reusing agents, et cetera, which is a much more efficient way of running the system. So, quick questions. Yes, you over there. It's correct. Webflow is hiring. If you are interested in applying, we are fully remote. We are hiring for DevOps, site reliability, front end, back end, all levels from early career to staff. And if you see a job that you're interested in, we recommend that you apply even if you don't meet 100% of the qualifications. The URL is webflow.com/careers. And that is it. Thank you very much. So if you have any questions or would like to talk further about this, feel free to email me at james.nimlos@webflow.com. You can talk about the presentation, or if you're interested in Webflow or you're just interested in career progression or whatever, feel free to reach out. Thanks.
Thank you very much, James.
No, I'm not presenting to share, and it was a lot easier on my brain to bring up the laptop versus trying to remember things.
Yes.
Got anything you want to go?
No, go ahead.
Okay. So that concludes all of our talks for this morning. And we're going to break for lunch. We're going to reconvene at 2:45 local time. So that's Pacific time for those of you online. Other information, I had other stuff. Reminder about tonight's party. On the list for tonight's party, it is 8 to 12 tonight, and that is here at the museum. On the docket for tonight, we have karaoke, the scavenger hunt, Tron, the whole movie, not just the credits. And we also are going to have some board games and open bar. So it makes things a little bit more fun.
Do we want to say anything about the lunch? No, right?
Anybody want to know the lunch menu?
There's options for everyone.
There's an extensive lunch menu.
Yes, there is an extensive lunch menu. Did you want to go through it, or?
I can give you the high level. I'm not going to give you all the ingredients.
Yep.
There's a grilled chicken wrap, roast beef sandwich, Tuscan tuna wrap, an Asian-inspired vegetarian banh mi sandwich, grilled chicken sandwich that's gluten-free, a vegetarian sandwich, also gluten-free, a harvest side salad, also another harvest side salad without feta. Don't get offended.
Yes, I wanted to say, at least there is one that has feta. Thank you very much. I don't know if Jeff looked into it, that there is something Greek for me. So, yep, thank you.
And there's some assorted dessert bars, as well as it's listed as chef's selection, which mentions vegan, gluten-free desserts.
So for those watching online, sorry.
But again, 2:45, so what is that? That is an hour and 50 minutes from now. We will reconvene in both tracks at that time.
Have fun.
Thank you for this morning.
Hello, everyone. Can we cue the picture of my cats, please? Okay. So, as a proud parent of cats, I like to force pictures of my cats to people. Pictures of pets or kids. But since I have you here and you cannot go anywhere, you are forced to look at my cats. So these are my two babies, the tuxedo one and the orange one, and I'm very, very proud of them. They love each other very, very much. And aren't they the cutest? Look at these cute faces. Look at them.
The owner of the second cutest set of cats at the conference.
Okay, so
I have 5. I win just from quantity.
You win just from quantity. So if
I got a woo. Nice.
we can remove the cats and enter the slides and the queue for Scott Arbite.
Yeah, everybody give it up for Scott Arbite as we kick off our afternoon. Testing audio. There we go. Hey, everybody. Hi, I'm Scott. I should have loaded pictures of my 2 cats because they're the best. So I work for GitHub. I have this title, Technical Architect, which we kind of made up because basically I have gray hair and they just throw me at hard stuff and I kind of figure it out. This year I've spent a whole bunch of time talking to some of our largest monorepo customers, in fact, some of the customers that have struggles keeping their repos healthy on GitHub. Out of 420 million repos that we have, there are fewer than 100 that I'll say kind of give us indigestion sometimes, where we have to work a little more closely with the customer to keep things healthy, and I've been able to work with some of them. When I saw Monorepo World's call for speakers, I thought, well, I've been having this conversation all year, so I can kind of show up and quickly share. I'm going to rip through this stuff. I'm going to do a quick 2-3 minutes on Git systems at GitHub. Not everyone is on GitHub, and if you're not, what the hell? Come on. But just to talk about GitHub's architecture a little bit, and so you have some context for why sometimes it cause problems. We're going to talk about what large means. I do just want to say, like, if you have a monorepo, it doesn't mean it's a large monorepo. You could have a small or medium-sized monorepo, and if you do, party on. You don't even need to be here. Like, it'll just work. And then we'll actually get to the recommendations, which I know is why you're here. So super, super silly high level on Git systems. Git systems is I've been a programmer since I was 11 years old. That's 43 years ago. They're absolutely amazing. So here's the silliest high level thing. Imagine you're the Git client, you're typing a Git command, it goes over the cloud, it gets into our network. We have a really nice front end network layer. It gets to a system called Babel. Babel is the thing that actually speaks Git protocol. When you type a Git command with GitHub, you're actually talking, understands what you want to do, it'll do authorization. It might convert the command to a slightly on Git systems know all the arcane bits of Git and what to convert things to. And then it gets sent to a system called Spokes. Spokes has 2 jobs. Spokes handles all the storage. So GitHub Enterprise Cloud runs in 3 data centers. By default, we keep 5 replicas of all of your repos. We can adjust that number if we need to. It's rare. So Spokes knows that there are 5 replicas. If we lose a file server or if we lose a data center, which we do test, Spokes knows how to make up for it and to get you back to 5. The other thing Spokes does is it's our 3-phase commit system. So it's the thing that makes sure that when you do a write, there's a quorum of replicas that return back and say, yes, got it, before we let you know.
spokes real quick. Imagine you send a git fetch command. I'm obviously skipping over all the part about Babel. I'm just going to spokes. And at this point, Spoke sees it and goes, what kind of command is it? Is it a read or a write? Okay, cool, it's a read. I can pick one of the replicas at random. It'll pick whichever one. And at this point, Spokes is speaking Git. I mean, this is actually Git all the way through. GitHub is Git all the way down. So Spokes is going to fork Git. It's going to actually send a Git command to the correct file server in whichever data center it chose. And that one is running a Git daemon, and it's going to respond back with whatever the results are for the fetch. And without too much other ceremony, it's going to stream right back to you. So that's part of it. On the other hand, if it's a write command, let's say you're doing a push, Spokes is going to receive that. The first thing it's going to do is lock the repo for writes. So obviously you can imagine in a three-phase commit system with locks, that's going to limit how fast we can go. In general, you never notice it. For the crazy, crazy busy repos that I've been speaking, the customers I've been speaking to, lock the repo, we have to now send 5 pushes because there's 5 replicas. As soon as at least 3 of them come back, we can release the lock, let you know that it was successful. binaries are there in the releases section. As long as you have a full clone of your repo local, you can just run it locally and get really good heuristics. I'm going to run through a few examples of git size or output, just so you could, when you run it against yours, the first time you see it. So I know this text is small. I'm going to zoom in on it. And I of uncompressed blobs, no big deal. Like, that's fine. And if you just that like, oh, I can't do it here. But you can see that like the right-hand column, there's not a lot going on there. So like that's healthy. This is a lovely, healthy repo that GitHub and GitLab and Atlassian and whoever your friendly Git hosting provider is, like they're not going to have any problem running this repo. Here's another one. Again, I'll zoom in, and I was just trying to pick interesting ones. Here's React. I thought that one would be cool, and I was expecting it to be, I don't know what I was expecting it to be not good somehow, I don't know. But look at it. Whoever runs the React repo, it's absolutely. One line here, you'll see that like these things look really good. The rest of this repo. For the read side, we do have a caching system that helps us. So even this is fine. I'm going to very quickly move on to a couple of actual large crazy repos that we deal with. Repository XXXXX, and you'll start to see that the right-hand column starts to get a little busier. So for this one, for instance, we've got 50, almost 60 gig just of tree objects in this one. This repo's been around for a while. And that's a lot of blob data, right? That's pretty big. Now, with git sizer, when you run out of asterisk, it just does exclamation points. So like, this is like, ah. So this repo for a long time actually caused us problems. It was sketchy. It was kind of hit and miss, and we worked for a long time to get it to work. Thanks to some of the engineering changes we made really like 2-3 years ago, this repo's been great. Like we actually handle this repo now really, really well. I don't know the last time there was really an issue with it. But I just want to sort of go to the bottom here really quick and show you some of this stuff. Now these are less about the day-to-day and more about what's the biggest object? If you picked a particular SHA and said, I want to check out this version of the repo or this branch, like what's the biggest thing you could get? Well, 2.65 million directories in one checkout. Now that smells to me like, I don't know, but that smells to me like somebody did a really bad check-in and we never cleaned up the history. Like the history was never cleaned up. So like, ugh. And like, again, the biggest checkout, 200 gig. That's not good. So like, if you have something like that at the bottom of your Git sizer, like, see if you can maintain your repo, see if you can clean up history, see if you can do something better. Last example I'm going to show. Okay, look, watch the right-hand column. Oh, actually, I want to say one more thing about this one. There's another repo we have with very similar numbers of that sort of 57 gig here and like roughly the same size here. But that one has trouble. Like that one is more on the edge of what we struggle to support, and we work closely with that customer. And the difference is that this first repo has a lot of devs. I'm being very vague with the numbers, I understand, but let's just say it's got like 1,500 or so devs. And the other repo's got multiple times that. So it's just busier, it's more repos doing more users doing more updates, plus more CI/CD. So even though the sizes of these repos, if I showed you the Git sizer for the other one, they're almost identical, but one we don't have a problem. The other one we have, like we have to be a little more careful with. So size is a thing. And then one more. Now, again, like if you knew nothing about anything programming-wise, but you walked up to a dashboard that just looked like that, in any world, in any field, you would just be like, I don't know what's going on, but that's not good, right? So this repo, we have internal chat ops where we can pull up things like what are the busiest repos over the last X hours or X days according to disk, read or write or CPU or whatever. This repo is in the top 25 pretty much every day. It works, like it gets the job done with like 3.77 terabytes of uncompressed blobs with crazy numbers of tree entries, right? Why does it work? Again, like a lot of users, but not crazy number of users. So we can kind of handle the traffic. So all these things, back to that sort of spider graph idea of like think holistically about the size of your repo and how busy it is. Okay, a few more recommendations. First one, next one, Git Scaler. I'm going to ask one question. Who knows what Git Scaler is? All right, we have a few hands. This is super, super important. I would argue that if you're watching this video, if you're here at Monorepo World, that means that you think you have a monorepo or you think you might be heading in that direction. You are the target audience for Git Scaler. You should be running Git Scaler now. You should move your dev teams to be running Git Scaler. So what is Git Scaler? It's a mode. Think of Git Scaler as like a collection of settings that Git will set on your clients that will make you go faster. And what it sets by default it sets you in partial clone mode. Partial clones in Git mean that you get all the trees locally, you get all the refs locally, but you don't get all the blobs. So your clone and your fetches are much smaller. You only get, it creates a virtual file system, and it gets you only the blobs you need as you need them. So as you do checkouts of different branches, it'll see if you have those files, it'll only get those, and really keep your local copy pretty small. That's good because it's less read traffic for GitHub, for your friendly Git hosting provider to provide. It's less disk space for you. It's just easier to deal with. Second thing, it lets you do sparse checkouts. Sparse checkouts are a thing where you can say, I actually only need this part of the tree. I don't need the whole tree. So like in the Windows example where some of Git Scaler came from, when Windows moved from Source Depot to Git, some of this was like the genesis of what became all of this built into Git now. So if I work on audio drivers in Windows, I don't need the code for solitaire. Like I can focus. So you can do that. Background maintenance. It'll do Git Scaler will create a file system watcher. So it watches your working directory, and that way it knows everything you're doing. It can keep some internal data structures up to date, so that when you run commands like git status, you can very quickly get the information that you need without it having to crawl your entire tree before it can give you answers. So you can run Git Scaler, by the way, on any size Git repo, even the smallest ones. It works fine. But if if you're within the sound of my voice because you're interested in monorepos, push to move your dev teams to using Git Scaler. It will absolutely help us, and it will help you. CI/CD. Last couple things. it still counts as traffic if it's CI/CD. Just because you're not typing git fetch, it doesn't mean it doesn't count. And I know it's silly for me to say that, but I have to say it sometimes. It still totally counts. If you're doing builds, make sure you're doing shallow clones. So shallow clone as opposed to partial clone. Shallow clone doesn't leave your repo in a state where you can actually do pushes and pulls. It's not a dev mode. It is a take the checkout I want, get the thin first layer of the files I need, and that's what I'm building. So by default, for instance, if you use GitHub Actions, the GitHub Actions checkout action does shallow clone by default. And if you're not doing that, please make sure you're adjusting your CI/CD processes to do shallow clones. In case you're doing any write operations during CI/CD, in other words, you run a build and then you do something where you update a file and you do a commit to your repo. It doesn't happen all the time, but there are places I've seen who do this. Please don't. Like, that's the wrong way to capture whatever metadata you're looking to do. Like, put it literally anywhere else. Put it in SQLite, like text it to your phone, I don't care. Just like don't do another commit as part of your CI/CD. You're just adding write traffic on top of write traffic. And if you're running your own infrastructure, in other words, you have your own VMs in a public cloud, or maybe you have it on premises, or you're using agents like we saw in the keynote this morning to like use local dev resources that are sitting idle and we can do builds on them, whatever. But if you're doing a lot of builds, which means you're doing a lot of git clone, which means you're doing a lot of read, think about standing up your own Git proxy. Like we have some of our largest Git customers who run their own Git proxy server right next to wherever their build servers are. And they'll do it, like one I can think of does a fetch every 3 minutes. And if something new shows up, then it kicks off their CI/CD stuff. But like that, first of all, takes a lot of pressure off of us. Again, enabling your friendly Git hosting provider to serve more write traffic for you. And also puts that Git code a millisecond away from all your build servers instead of having to go all the way to Virginia and get them. So last thing, just don't do stupid stuff. Like please, no large binary files, like get rid of them. Like do the work. Like if you're like hearing a monorepo talk, we're all adults here. This is the big time. Like you're using Git for real and you have to treat it with respect. And Git does not do binary files well. It never has. That's not what it was designed for. If you have large binary files in your repo, please do the work to get rid of them. Once you're clean, this is something that really one of our absolutely largest repos does. They did the work to clean up their repo, and they set a 5 meg file limit on their repo so that they never have to go down that road again. By default, GitHub has 100. I don't know what the other hosting providers are. By default, we have a 100 meg limit. Set it to 5. Like seriously, you do not, if it's bigger than 5 meg, it should be in object storage. Rant over. No using Git as a file system. We see this sometimes. Again, this is back to that storing log files or XML or JSON files or large binaries. For file distribution, people want to treat Git as a file distribution mechanism. Android, excuse me, sorry. Don't do that, and please use object storage and CDN. So, there was one other slide that I got rid of, sorry. Work with us. Like if you run git size or if you think you have a monorepo that might be an issue, file a support ticket with your Git hosting provider. To have a conversation, ask us, hey, could you check this out for us? How do you feel about it? Does this look good? Is there anything we can do? We'll work with you, we'll help. Like we want to help you. We want to give you the best experience of Git. We want to give you the best experience of your monorepo. But like don't create the giant monorepo on your desk and then just start magically pushing it and hoping it works. Because GitHub, like every company we work with, GitHub is a bunch of code running on a bunch of servers. We have so many devs. We have backlogs like all of you. We do as much as we possibly can. Help us help you. And I have like 2 minutes. If there's any questions I can hit.
As I'm walking over there, I'm actually going to ask a question. You mentioned not using Git for distributing large files.
Yes.
What about for the packages? Is that considered separate from Git because Git offers Git packages for distributing packages?
Yes, that's different. Totally. Okay. That's like more GitHub than Git, kind of. Yeah.
Fair. Okay.
Yeah.
Hey, so we have a moderately large Git repo. One of the things we've struggled with long-term in terms of maintenance is BFG repo cleaner kind of sucks to run.
Okay.
Git filter, way too slow. What tools do you recommend to transition towards Git repo health while also kind of keeping things online and not screwing up everyone's local forks and like that world?
Yeah, here's the part where I'm just going to back off and go, it depends. It's work. Like the thing you're talking about is not something that I could say, download this and it works. This is like, it starts to almost get to be like, hey, would you like to do a 1-week professional services engagement and we'll come in and help you? It's just, I know it's work. Like I know that once you're in a bad state, it's work to get your Git repo good, but it's work we have to do. Like again, if we're going to be adults about this, it's work we have to do. So sorry it's a lame answer, but thank you. One more and then I'll get out of here.
So you said you always use shallow clone. That doesn't work so well when you're doing affected because you need the commit to compare against. How do you do that with NX affected?
If you have all I can say is if you have a circumstance where the shallow clone doesn't work for you, I understand. Like, do what you got to do. If there's maybe there's other ways, I'd have to sort of sit with you and think about it and see if there's a Git command we could craft that would get you as little as possible, but everything you need. Like, because you can go shallow clone of depth 1, 2, 3, so it might be in that realm. But again, like just please don't do full clones to do a build is really the lesson there. Thank you so much. Really appreciate it. I'm the only Scott Arbite in the world if you ever want to ping me. And here's my side project that I have to mention. I'm writing a side project, a version control system, because I think we might be on the verge of needing one for monorepos. Thank you very much. Appreciate it.
Thank you, Scott. I like thinking about these ideas that we've been talking about all day from a different perspective. So not only how do you manage all of the different dependencies within a monorepo, but how do you manage all the files that you have associated with it? So I
appreciate it.
Different spin on the entire problem.
And thanks to the organizers. This has been a great conference so far. Thank you so much.
Excellent. What you got?
I think we're good. So I'm very, very excited for the next talk. It's going to be the talk for NX. And I think
Anybody here heard of NX?
Yay!
Okay. One or two? Okay.
And yep, I want everyone to be excited for this talk. So everyone, please clap once. Okay, so you do pay attention. That's good.
Of course, I should have done this with the other hand. If I had half a brain.
Your mic's on back there.
Okay.
I think we're all set.
Okay, the stage is yours, Yuri. Take it away.
All right. Are we ready with the slides? Awesome. Perfect. Yeah, I want to talk a bit today about the whole spectrum from consolidating, enhancing, and scaling a monorepo. And we're obviously going to talk a bit about NX. So monorepos are great, right? I mean, we're at a monorepo conference. I think I can say that without any issues. Like, there's a lot of different benefits that people talk to us about. Like, it's reducing communication overhead, ideally, within our team. It's kind of helping us facilitate collaboration and code sharing. Like, ultimately, it should help us ship faster and hopefully with higher quality. That's kind of the goal. But you can already hear the tone of my voice. Like, there's a but, right? There's trade-offs, like with every technology or tooling you're adopting. And so they do come with free, and I often call this the pain points you don't see yet, right? Because you might be in a polyrepo setup. You kind of start feeling a bit of the pain of like keep sharing code, keep deploying it, keep like managing different versions. And so then there's this shiny toy, the monorepos, with all these benefits, so let's just jump on it, right? But it comes with some pain points. And well, let's maybe not call it pain points, let's call it challenges. And so I want to talk a bit about these three big blocks, right? So you want to migrate from a potential polyrepo setup to multiple single repos into a monorepo. Then you want to enhance it, right? You want to make sure you actually leverage the benefits of a monorepo, because otherwise it doesn't really make a lot of sense. And then finally, you need to address also the scaling aspect, right? And so with NX, we want to try to kind of cover and give you something and support you along the whole spectrum of this, right? So from the actual first migration consolidation phase to enhancing to scaling. So my name is Joris Strumpfloner. I'm currently senior expert, and I also do some video courses. And so let's jump right in with the first one, which is consolidating. And there's one thing that is almost like a must, right? It's incremental. It needs to be incremental. Like, no one can actually say, well, let's stop for like 4 or 5 months. Let's just migrate everything over, and that will be ready, super productive, and go ship. Like, that just doesn't work in reality. So you have this setup, which this can be like multi-repo setup, and there are still some dependencies among those, right? They might be more looser in the sense of like there might be some runtime API connection between these projects. There might be some internal NPM publishing. Maybe you have within your organization a local registry where you publish stuff and then reuse in our repos. So there's some connections in there. And ideally, in an incremental phase, you want to take this and move it over to that single repo, right? Either one by one, or move it over, but leave it almost untouched. I'm saying almost because, like, obviously you can benefit already from some direct connections, like for NPM. Like, you don't have to publish anymore, right? Just depends on the latest version. But that's kind of it. So that's kind of like the first step I wanted to look a bit into. So let's have a look what that means for a single project, just to break it down, start simple, right? So roughly, I think by now, like 1.5 years ago, we introduced a command that's called nxinit. So rather than creating a new monorepo from scratch, so Greenfield project, you just apply this command on any type of repo. It can be a single project, can be a monorepo. And what NX is going to do is it figures out the setup and then installs itself into the monorepo and configures itself. And this is a very minimalistic setup in the sense that what you get is an NX package, single NPM package, and then you get the metadata file, which is like NX.json. So this gives just NX some information about what it should do. You don't have to have it, but it doesn't make sense really without it. Because here's what you define, for instance, what operations are cacheable. You can define some task pipeline dependencies, etc. And what do you get? Well, you can now run it through the NX pipeline. You can run multiple commands at once in parallel, optimized. You get some caching out of it. So if operations have run already before, it just like doesn't run them anymore. But the important part is this uses just existing scripts that you have. Like in this case, it's like a JavaScript repo. So it just uses your package JSON scripts, and it doesn't really touch anything else. And this is a big advantage because like the chances that things are breaking is actually pretty low. So you get some benefits, but like you minimize the actual breaking parts potentially in your setup. Now you might be wondering, like, for a single repo, is it really worth it? Like, why would I do it? And it's kind of a legit point, right? Like, you don't really get a huge gain in, let's say, you have a single remix repo, remix project, and just add an X to it. But for an existing monorepo, it actually makes sense. Let's say you have your PNPM workspace with a bunch of different projects. It works for you, but at some point you feel the scale of it. Like you run into some issues in terms of speed. At that point, NX can kind of bring in like the fact that you can just take the existing scripts, keep going with those, but you get the task pipelines, and you also get caching, locally and remote, potentially, right? The point here is you manage this, right? You still take your existing repo, and you manage these setups, make sure they're in sync, you upgrade them over time as you keep adjusting your monorepo, and that's fine, right? That's perfectly legit. But when we think about these use cases, usually the thought is always like, can we do better? Like, you get the setup that you already have, but can we kind of help you without being too invasive? And so very often what we bring up and like keep pushing forward is NX plugins. And these are NPM packages that you can add on top of your setup. And the main goal there is that NX plugins take care of the tooling. So they take the tooling that you might be using already, but they make sure it works well in a monorepo setup, which might need some fine-tuning, right? And so the plugins handle that for you. They configure caching for you, and the goal is you just focus on shipping, right? You don't really worry about the rest of it. And they have been, I have here historically, because you can still use this setup, but historically, they have been more kind of opinionated and more restrictive in a sense, because if you just build, like there's some options you provide to such a plugin, how it should build, then you give the type of the build system. In this case, it's like a Vite build, could be a Webpack, rollup, etc. And the plugin then knows how things work. And this is opinionated, clearly, right? So we know where files should be, how it should be configured. And for Greenfield projects, this is amazing, because you don't have to know a lot about the underlying tooling. You just get going, right? So you create a new workspace, the plugins will configure the tooling for you. You just keep focusing on developing actually the product and shipping features. And what we noticed, though, is like for migrating existing projects, mapping step in between, where you maybe port your existing setup, your existing build scripts, like your Vite, WebEx setup, etc., over to the more NX-specific plugin setup. And as you can see here on this side, this is very high-level, non-technical illustration of how a plugin looks like historically seen. It's like it takes these options, it feeds them into the plugin kind of knows what it needs to do with it, and the plugin itself wraps some of the technology underneath. So it actually might access lower-level programmatic APIs of the tooling and then produce the artifacts kind of at the end of the cycle, right? And so it's more of like a black box. So what we actually would want, though, is the use case which we had initially was like the NX init, right? Super lightweight, super minimalistic, but enhanced with some of the stuff that the plugins do, because they're actually pretty powerful. It might just be harder to migrate to them initially. And so our thought keeps coming up, and this is something also that Victor mentioned in the keynote. At some point we were like, what if like plugins are more like the VS Code extensions? So if you think about that, like I often make the Playwright example, like you can use VS Code and run Playwright tests without any issues, right? Works. But if you add the Playwright plugin, it's actually pretty neat, because you get like these in the gutter, these icons where you can run tests directly. You get a test explorer, it kind of filters out some of the stuff. So it's enhancing your experience when working with Playwright tests in VS Code. And that's kind of the idea that we would want to have. Like you get a setup, everything works, but we want to enhance it with some more stuff to take away from you. So it's kind of the whole thought about like we want to enhance, but don't really interfere with whatever you're doing right now. And so what we try to do is like move from this perspective to something like this. Again, high level, non-technical, right? So it's very, like, we move the build tooling outside, we just invoke directly the underlying CLI, but we still do some of the fine-tuning that you might want to do. And there's a crystal here, because we named this project Crystal, and that's when you hear like NX Crystal plugins. Those are the type of plugins that try to interfere less with what you do, and are usually much, much easier to adopt in an existing reality. And so what we do here is, instead of like providing a whole set of options, which you can still provide, but you don't have to, we actually rely much more on the underlying tooling config. So for Vite, it's the Vite configs, WebEx config, etc., depending on what tool you're using. And we read information out of that, and we already make sure things are keeping in sync. So that means also we know what targets you usually run when you have like a Vite setup. For instance, there's for sure dev, build, and preview target you can invoke. So we automatically infer and generate that as well. So you don't have to specify it anymore if you don't want to override it for some reason. And so that has the big advantage that the cache output directory will always be in sync, because we just read it out of the Vite config. You for some reason change the output directory, tooling will automatically pick it up, in this case, the NX plugin. And so this is what it looks like in such a crystal setup. So you can see here on the one side, the project JSON file, which is the configuration file for like an NX workspace, an NX project, is empty, right? So if you don't have any custom target set up, it's empty. You actually don't even necessarily have to have it. And on the view, this comes from our NX console extension, which is for VS Code and WebStorm, but you can also just run it in a local browser environment. This shows you the different targets that got inferred from the tooling setup. So we know, since it's a Vite setup, there will be build steps, dev steps, etc. And if we open up one of those, you can see there is like a cacheable marker. So we know this should be cacheable. As a command, it just runs Vite build, right? So it just refers to the local actual CLI of Vite. And if we scroll further down, we also see there's some inputs and outputs configured. So it also pre-configures the caching for you. So again, it takes away some of that burden from you. You don't have to think about it anymore, basically. But you still don't have to change a whole lot of different things on your existing setup. And as you can probably anticipate, it turns out this works really, really well for importing. So meaning importing existing projects into a monorepo. And so that's why we started creating an import command, NX import, which does exactly that. And so here is a setup for a Java project. This is a Spring Boot application that uses Gradle underneath. And we're just going to import it into an existing workspace. So you can see here, it's like just normal setup. Like there's a product controller. It has a Gradle plugin configuration, a Gradle config file. And so clearly you can run all the different Gradle commands, right? Like Gradle build, Gradle test. And if I move over now to my existing monorepo, I can just run an import in here. So this is a monorepo with a bunch of Next and React apps and Angular apps in here, some libraries. And so if I import now my Gradle setup, my Gradle-based project, it asks a couple of questions: which branch you want to import it, where you want to place it in the existing monorepo, and then it detects the plugins. So it found the NX Gradle setup because there's a Gradle config file and suggested to install that. So now the project is in. It actually ports over the existing Git history, so you don't lose that from the original project. And so now you can basically run a command to show whether it got recognized. So you see the API project, which is our Gradle project, got pulled in. And if you open the build file and you have NX console installed, you actually get that icon that now shows you all the inferred targets, as we have seen before. So you see there's still the boot run, there's the test command, there's the build command. You see it's cacheable, that got detected automatically. Just use the underlying Gradle build command. And it also has the input and outputs configured, right? So caching is set up. And that basically means we can now run commands as before, but we use NX for it. So we run NX build, we run NX test, and we can also chain it with others, right? So we run many, build test, and we'll just run it regardless whether it's a Gradle file, a JavaScript project, React project, etc. And obviously gets cached. And finally, it shows up also in the project graph. So it's literally as all the other projects in the repo. And this is what the plugin allows us to do, right? So this is what the plugin did. We didn't do any sort of configuration on top of it. Just pull it in, plug in the tag to the Gradle file, pre-configured it. So that's kind of the power that I was kind of hinting towards. Okay, so now this is kind of the consolidation phase. And you can also import multiple projects, right? So I just took one example of putting in one project into an existing repo. Let's move over to the enhancing phase. When I say enhancing, I mean we have this setup now in our repo, but it's not really leveraging a whole lot of the monorepo setup. You just pulled in the existing projects. What you start doing usually is you split them up, right? You create smaller projects that are more usable, we can basically better allocate teams to these projects. You start kind of splitting that up and kind of leveraging the monorepo tooling better if you have smaller pieces. And so it quickly starts kind of becoming more of these projects, and it can even turn into something like this, right? We have just a ton of different projects in the monorepo because it's easy to create new ones, and people just start kind of cross-referencing all of these. And so that's when you start to have to do some sort of like control mechanism on top, right? You need to start thinking about how do we control this type of structure such that it is still maintainable as we keep going on. So how do we do that? Well, first of all, we need to kind of standardize some of the things. So where are projects being placed inside my monorepo? How are they being set up, right? We want to have some sort of like organizational standards that we want to impose. And the best way to do that is usually to automate. All right, so I'm not going too deep into that, but one of the ways to automate that in an NX repo is to use generators, right? So the plugins that I mentioned before provide some of these, so they have it built in. But many companies just create their own, because it's pretty easy, right? We have like an actual dev kit, which allows you to create your own generators where you can reuse existing ones, but kind of really tailor them to your needs inside the company. So maybe some of the questions you don't even ask. Like if someone says, I'm creating a new product for my orders domain area or whatever, or you are in the team of the orders managing projects, it will know in which subfolder of the monorepo the project should go. So you can actually really fine-tune this sort of process. All right, so once you have something like that set up, like this, it's very easy and straightforward to create new projects. There's the next thing that you need to think about, like kind of like hinting to a talk that we had just a couple talks before, which is the whole ownership part. Who reviews the code, right? You want to make sure, especially if the monorepo gets bigger, that the right people are reviewing the right parts. And this goes back to the structure that I mentioned before. As you keep creating such a structure, you kind of start to identifying different areas. Usually they reflect domain areas that you have within the team, within the type of company you are. It can be department-wise organized. So that really depends on like how the setup looks like. But the fact is that you start building such areas where you can clean it and assign owners, right? So everyone knows the team members of that team, so they should probably review their code. Now, most of the time, it will be that team contributing to that part of the repo. But in a monorepo, it shouldn't always be the case, right? If there is some connecting parts and I change an API, which I break some code over there, but I don't already know how to fix it, I can totally submit a PR for that as well. But it should be some of them to review that actually, because there might be some side effects I have not thought about. So that's kind of like the idea behind the whole ownership part. And code owners is one way to actually do that, right? Like you specify for each kind of folder structure that you have, who should it review when a PR is being opened. Now, code owners are file-based. So meaning you need to define the different, either at the glob pattern level, or you need to define all the folders and assign teams or groups or people names who should review these different parts of the code. And one downside of that is you need to keep it aligned with the project structure of the monorepo. So as you keep moving projects around, you need to make sure to keep that in sync. And so again, like we thought, like, can we do better? Like, can we kind of enhance that experience a little more? And this is when we started introducing what we call NX Power Pack, and code owners is one part of that. And so by installing a package, we basically introduce a different way of defining code owners, which is closer to how you usually manage your setup. And so with that, you basically have such a configuration in your NX.json, which allows you to first still at a global glob pattern level. For some reasons, that might make sense. But it also allows you to define it on a tag basis. Now let's have a look like what that actually means. You define these. You can run a command called nxsync, and that would then produce the actual output. So here's a small demo of how that looks like. So you can install that package using the nxadd command. nxadd just does more, right? It installs and then runs some initialization script. And then you can define such a code owner's configuration, right? You define the pattern for GitHub, GitLab, or whatever you're using. And then you define these different projects. And you can also use a tag to identify the project. A tag means in your project.json or package.json, NX allows you to define such a string base that you attach to the project, which is useful for more things, actually. And then once these projects have a tag and specified in the code owners file, you run nxsync, and it will then generate the file patterns, the glob patterns that it needs to properly assign the owners. So here you see the one that we had initially for DevOps part, but then for all the others, I didn't have to specify exactly where that project is located in my monorepo. Clearly, NX figured that out based on these tag patterns that we allowed to have. And this allows you to kind of reduce a bit of the maintenance burden on these code owners files, right? Because you just move projects around, and they will still keep in sync based on this tagging mechanism. Next thing is scaling, right? So we looked into some of the enhancing parts, and there's more, right? So I touched just on some of the aspects there. The next part is scaling, because clearly at some point, your monorepo keeps growing, so you need to look into more of these areas, and which is not just the code ownership, which is kind of a bit blurry because like it goes a bit also into scaling. You kind of need it at a certain scale only. But the next thing is like verifying boundaries, right? So we establish these boundaries, but at the same time, we want to make sure things stay within the boundaries, and you can control what can depend on what other projects within your monorepo. And again, automation is kind of the key there. And this is what we call conformance. And again, we pack this into one of these Power Pack plugins, which you can install into your setup. In this case, it's NX Power Pack Conformance. And what it allows you to do is to define rules, right? And one of these rules is an owner rule. So in this case, you can see I configure here the Power Pack Conformance ensure owners. And then in this case, I just exclude the end-to-end tests. But what it allows me to do now, this is a baked-in rule, is to make sure that every project has an owner actually assigned, because this is something I would want to do, right? If I instantiate a new owner, a new project, I want to make sure this is also covered by someone that reviews it. Now, ideally, again, kind of hinting back to the generation phase, you might pre-generate that as well as your part of your custom generator. And so when you run this and one of the projects doesn't have an owner, you would get such a notification, and you would run this on your PR, on your CI, and so immediately your PR will be blocked. You look into it. Oh, well, I forgot to define the owner for this new project. You go fix it, etc. Another one is the project boundaries enforcement that I just mentioned before. Full configuration right now, where you can see different options, also in terms of like circular dependencies configuration, etc. But the main part here that I want to highlight is the middle one, which is the dependency constraints between projects. So you can say something like, here, my source tag backend, which is like our API, our Gradle API that we imported, cannot depend on those that have been declared of type frontend, right? Because we don't want to have that direct dependency. We might have some shared parts in between, but we don't want to have direct dependencies. And so this is the type of thing that you can check with these conformance rules. And so another part is you can also customize them, because we have some baked in, but you can also create your local conformance rules. It's a matter of creating a TypeScript file and then basically configuring the rule, something like this. This is just obviously like a sample that I pasted in here. But you can then configure the behavior of this rule inside here. You don't have to pre-compile it. It will automatically be loaded in by the conformance plugin and ran on your code base. Then you run this on your CI, and it would automatically run the checks, and you can see all of these different parts in here. Like here, for instance, like there's a project type frontend that depended on a backend, so it would emphasize that and block your PR from being merged. Now, this is an early version of it that we just launched a week ago, 1.5 weeks ago. The main power of this one, because this is pretty similar to also like an ESLint-based rule that we already have, the main power of this one is this goes across the tech stack. So while ESLint is mostly JavaScript focused, this works across, as we have seen, also Java projects and other types of projects. And in addition, if we pair this up then with NX Cloud, you could even run these rules on all of the projects that are connected with your organization. So you can even go across monorepo boundaries in the future. And then finally, scaling CI, right? So that's always a part that at some point kicks in, because as you keep adding new projects, your CI will go up. That's for sure. If you don't do any sort of optimization, that's going to happen, which then again kind of almost neglects the benefits of having a monorepo in the end. And so we want to keep that as low as possible. And our main answer for that is NX Cloud. So NX Cloud, where we want to make sure that CI is actually optimized and kept as low as possible. And there are different aspects to that. Right? The remote caching part is almost the basis that you need, but you really benefit from the other features like the NX agent-based distribution, which means you automatically distribute work on multiple machines. We've seen some of that earlier this morning. Also things like automated task splitting. You have that huge Playwright or Cypress task, and you would automatically split that up into finer grained pieces to be able to cache them more efficiently, but also run them across multiple agents more efficiently. As well as like flaky task detections, and also like recently we added some AI-based to have, so cost optimization and speed optimization, where you can kind of choose how much do I want to pay versus how much benefit do I want to get out of it. And this one is actually one of the main benefits there, which is like the whole version from I need to code my distribution on CI compared to NX Cloud figures it out on its own, right? So I don't have to code it and maintain it as my monorepo structure changes, but NX Cloud uses kind of like a pull-based system where it just pulls in work as it needs to kind of get tasks done. Now, I on purpose didn't go into the details of this one because there's a talk right after this one on track 2, where some of my teammates are actually going deeper into all the different things that you can do with NX Cloud and how you can benefit from it on CI. So NX Cloud has remote caching built in, as mentioned just a couple minutes ago. But if for some reason you cannot use NX Cloud or you don't want to use it right now, you have already AWS, for instance, set up, we recently also added a Power Pack that allows you to self-host some of the cache. Where we have it for AWS, S3, we have network-based caching, and soon also Google Cloud and Azure that are coming, where you can alternatively host if you just need the remote caching piece. So for AWS as an example, what that means is you just pull in the plugin, you install that into your workspace, and then you get a bucket configuration. Ideally, don't use Jason's one. This is just like an example. You configure your bucket, and then you set it up on CI, and it would then allow you to actually have remote caching on your CI run. Right? And that's kind of it. If you need more stuff like agents, etc., you would then move to the next step to upgrade potentially to NX Cloud. All right. So if we look back at the whole spectrum that I just mentioned initially, these are kind of the features that we kind of touched a little bit. So for the consolidation part, the migration phase, we have NX import and NX init, depending on which situation you're in. And we have the enhancing phase where we have NX release, for instance, which we didn't even touch today. We have the NX generate commands, so we have the NX migrate and code owners. And for the scaling, it's NX Cloud and S3 caching, which is more for the actual speed type of scaling, versus conformance, which helps you kind of scale at the team level, where you make sure that the thing remains maintainable in the long run. All right. So thanks for your attention, and definitely get in touch. This is our community. There's links to Discord, our YouTube channel, where you can reach out, ask more questions, and interact with us. So hopefully see some of you around there. Thanks.
Thank you, Yuri.
Rolling right along through the afternoon.
Okay.
You got something?
No.
No. Just a reminder, everybody, I need to move out of the light so I can see. Right?
Yep.
How many people are planning on coming to the party tonight? Show of hands.
I don't see all the hands up.
Right?
What's going on? Don't you like having fun?
Has anybody here actually been through the museum before? Anyone else? See one set of hand? I'll throw my hand in the air. I was able to tour years ago. Yeah. A lot of very interesting stuff throughout the museum. I highly. And I heard rumor of potential prizes for that as well. So
Oh, yeah.
I have no idea what they are. So
I don't either.
I mean, we may be talking like Matchbox car, or we may be talking about a brand new TV. I have no idea. Asterisk, those are not actual prizes. Because I don't know.
I don't know either.
I'm definitely looking forward to it. Stumbling through it after hitting the open bar. Getting set up, and just a heads up, we're going to be taking a break after our next speaker.
Yes, that's true. A small break.
And they seem to have snacks during breaks too.
Yes, there will be snacks during the break.
There's good fruit this morning, some nuts and dried fruit at the earlier break. So
Healthy California snacks.
yes, very much so. I agree.
The best kind of snacks.
The healthy, fresh produce.
So what was the favorite thing you saw in the museum?
In which one?
Here, in this museum, you said you did a run through and...
Yeah, I will admit that it was probably about 6-7 years ago.
Oh, okay.
When I was here
Fair
last, so
enough.
it's been quite a while.
Do they have like old computers, like a Commodore?
Yeah, old computers, and even predating things like that, old computational different machines. as
Okay.
well. That is not exactly that, but we're all good.
I think we're good.
I remember last name. We're good there. All right, so you're all set? Okay. So, everybody needs to practice their clapping again for Ryan Beardahl. Kyle, what did I say?
I said Ryan.
Ryan, Kyle.
So I'm here to talk to you about something that just came up in Yuri's talk, which is that if you start from a monorepo, it's great. It's all awesome. Maybe not entirely. So in this particular case, the company I work for is called Renew Home. And if you haven't heard of us, that's probably to be expected because we have been in business for 189 days. So on April 1st, we formed this company. And as a pretty common case in the world of anything involving software, we're the product of two other entities getting put together. So we come from a background of a product and a program offering that was embedded inside of Google. It's called Nest Renew. It's a product that involved their Nest thermostat and energy optimizations there. And then the company that I worked at, which is called OhmConnect. OhmConnect was a direct consumer energy product. Basically, we got people to reduce their energy usage at important times for the grid and then shared that like earnings back with those individuals. But it presented to groups of people as well as two ways of working. And as is commonly the case, you got to fit those two together when you come into a new into a new company. But in our particular case, we had kind of a unique problem, which is that we came in with a very clear product mandate. This was not a, fit their software into your software sort of thing. Instead, we had a blank slate. And we had a goal that we had to build a clone of this Nest Renew product that was currently running at Google and embedded inside of the Google Home app. We had to make it work without the Google magic. Completely did not get any code to start with. And we had to do this clone build in 91 days. Because it had to get put into a beta test version of the Google Home app in order to time up with a release of a new piece of hardware that had been being planned and worked on since before Renew Home was even an idea in anybody's head. So that deadline was not going to move, and we had 91 days. I, at this point, was surrounded by people on my team who were all really worried about this deadline and thinking, oh no, how are we possibly going to achieve this goal? And to be honest, Renew Home merger, my daughter was born. And so I was on paternity leave. I left for a couple months, didn't think about this. But through many long nights of being awake all night and getting no sleep, there's this little thing stuck in the back of my head, and I couldn't let go this idea of a Greenfield. So I'm sitting there one night, in the middle of the night, feeding the baby, and I think to myself, this is an opportunity. This is something that not a lot of people get. to start from scratch and get to make some foundational decisions about how we're going to work, how we're going to build something. And I get stuck on this idea of the Greenfield, so much so that I kind of orchestrate my return from parental leave so that I could show up to the meeting where they were like, hey, who's going to deal with what as we get ready to like start this new company, because we can't actually write any code, but we can be ready to write code. And so I said, hey, I'll deal with the repo. I'll deal with this. And some background, I used to have my own company, and we used NX there all the way back to 2018. I've used NX in a couple of different companies since, and I really like it. And we had been trying really hard to do this at OhmConnect, and we had a monorepo that was in a subfolder of the main repo, which is a pattern you should not try and replicate. Suffice to say, I was really excited about this opportunity. And so I had to convince some people. Obviously, we had a bunch of people coming from a Google background, and so convincing them that we didn't have a team to manage Blaze was just like not a feasible option for us. So eventually, we did it. We, it worked. We actually implemented NX. We had a team of roughly 35 engineers on day one of the company, and we jumped right into an integrated monorepo approach, which I guess is not really the term anymore now that we have Project Crystal and everything is all just nice. But the idea being that these aren't individual packages. They're all deeply integrated. But the twist here is that as of Friday, when I checked, we have 155 projects in this monorepo, 6 months in, and most of them are written in Python. This is not a story that most people hear when you're talking about NX. There is some TypeScript in there. We have a remix front end, but most of this is in Python. So we did a lot of our own plugin development. We did a lot of things to stitch it together. And I know what you're thinking about at this point. You're sitting here in the audience, you're watching online, you're thinking, wow, what a concise talk. Like, this is great. I'm glad to hear it worked. Awesome. I've got a few questions, but like, thanks for giving us so much extra time back in our break. Sadly, this is not going to be the case. So one of the problems with the Greenfield is that it's an illusion. It's this idea, it's a philosophical concept, but in reality, this is not a picturesque carpet of green that is just rolling across an uneven surface. This is nature. And when you get closer to nature, you start noticing that it is not the thing you see from a distance, despite this really looking like the Windows XP desktop background. It's not. Which, by the way, that's also a real place, too, I found out. So as you get closer, you discover that you're not the only person in the Greenfield, that there's wildlife. You might run into this guy, a mole. It's really cute and also kind of terrifying. But they dig holes. There's other creatures out there, rabbits digging holes. You can go down those rabbit holes if you want to. But the point is that you can't just frolic, carry anything you want. You are probably going to step in a couple of holes. And especially if you're sprinting really fast, those holes can become a problem. So what are a couple of those that we ran into? First one is names. Now, maybe this is incredibly obvious to some people, and I just hadn't come to this realization until very recently. Names are the only fundamental resource in a monorepo that you have to share with everybody. You can have so many teams working in a monorepo together, and they can all have their own little wedge, and their projects interact with each other, but they're isolated parts of the graph. But fundamentally, the names you assign to those projects are shared across everyone who works in it. So you should really take a little bit of extra time to name things, because this is all complicated by the fact that naming things well is not a trivial task. We all have experience with this. This is why it's nice to be able to move a project in the monorepo. But getting that name set correctly the first time is not easy. But on the other hand, getting consensus around what you call a thing is crucial, because that's how you work with other people. Someone has to look at the thing and at least have some semblance of an idea of what it is. Otherwise, they're going to spend a lot of time figuring out where things are. So for our team, we found that this was so crucial that we set up a process. And I know like 10% of you just cringed inwardly thinking, oh no, another committee. Somebody is going to have to arbitrate all of the names, and we're going to have to go to a meeting to get a name approval. And that was really a big fear for us. So much so that we decided to implement a completely different process, and we have kind of leaned into this to the point where it's actually really, really efficient now. So the first thing that we set as a value for this process is it has to be low friction. You have to be able to be a self-serve, and it has to be very self-explanatory. So in our case, we picked a Slack workflow, which if you've never used those, it's kind of a cool feature they have. But you can click a button in Slack, and it pops up a form, and it has 3 fields. You got to give us the project name, the path where you're going to store the thing, and then you got to tell us, is it an app, is it a library, or a plugin? And with that, it makes a Slack post in a standardized format, and we have a conversation in the thread. Anybody who wants to have any opinion about what we call a project in our repo, or naming in general, our channel is called Engineering Naming, literally. You join that channel, and then it posts at here for every one of those messages. So you go in, if you happen to be around, you don't like a name that somebody has just proposed, you put something else in the thread. And the key there is you have to contribute something productive, right? You can't just be no, it can be no and, or no however. So No matter what, though, we have some amount of conversation, and what you're looking for at the end is consensus from ideally 2 sources. At least one person who is in the context of what you're doing, somebody who's on your team, who knows what the thing is and agrees, like, yeah, this is a good thing to name it. And someone who is as far as you could possibly imagine from your context as well. So find someone from the data analytics team that is not working in anywhere in the product space, and they should be able to look at this and say, like, yeah, that also makes sense. I wouldn't be confused by that name. Now, sometimes it's hard to find those people if it's off hours or something like that. So we don't always meet that goal, but that's the ideal. And the last thing is that we isolate project generation. This is one of the only places where we routinely use code gen inside of our repo right now. And the biggest problem we've had is that if you generate a new NX project, you end up with a bunch of boilerplate files that probably don't have a lot of meaning to a code reviewer. If you've run the generator should have done its job of making the code reliably. And so what we try and do is we sandbox that run of a single NX command into a PR. We link the NX naming thread so that you can say, like, this is what we agreed on the name to be. We put a copy of the NXG command in there so you can see this is the command I ran. I intended it with the right name in there. And then a code reviewer simply spot checks a couple places to make sure that things ended up in the right folder and that it's got the right name. And that's a pretty easy PR to review, as opposed to if I had generated a project and then wrote 4 or 5 files of logic inside of there. Now somebody really feels the need to review every file in that PR, which might be 10, 12, 16 files, depending on what your code generation looks like. So we're trying to isolate the things that are automatic so that review goes really, really quickly. The benefit of that is you get names into the repo as quickly as possible. You don't want a PR where you agree on the name to then take a week and a half to show up in everybody else's environment, because that increases the likelihood for naming conflicts, especially when you're working as fast as we were. Early on, we were getting 2, 3, 4, 5 new projects in the repo every day in order to get as fast as we were going. All of this is in service of avoiding moving projects. And now we just heard from Yuri, who's talking about sometimes you have to move things and it should be really fast. But ultimately, we've decided it's actually a bigger problem to move projects than it is to take the time to name them well up front. Because not only are some languages difficult to move, remember we're writing a lot of this in Python, and our Python plugin does not implement move at the Python level. I can move the NX project containing Python, and I can fix a few things about that, but I can't rewrite the Python code currently because we haven't invested the time to do AST parsing and completely refactor Python code. But it also increases the likelihood for Git conflicts. If you're moving big chunks of your repo around, you're probably going to create a merge conflict with somebody else, and resolving that just is more overhead for developers. And at the end of the day, developer confusion slows you down, right? The more you confuse the people working on the code base, the less you're actually getting work done. Second thing is NX boilerplate and copy pasta. So I mentioned we had a number of engineers that came from the Google background. They really wanted Blaze because they were really comfortable with it, and we had to kind of work through what some of the differences were. But one of the main pieces of feedback that we heard over and over again is that when I make a new NX project, I end up with a lot of boilerplate. It feels like there's a lot of files going on in here as opposed to having one build file that sort of centralizes all of that. Now the number of files ended up not really being the problem. We kind of narrowed it down to kind of a specific result of having duplication, and that was, give you an example. So say I start a new app, I make a little Python server, and I've set it up, but our code generation is just I have a Python project. So it sets up a Python project for me, and meanwhile I go write some code and have a server that I can spin up, and I make my own serve target at that point, because we don't have a generator that's specifically about a fast API server. So I make my own serve target, and it works great for my purposes. And then a few weeks later, another team's like, hey, we're building a Python server. Kyle has a serve target over there. We're just going to go steal his serve target, and we're going to put it in ours. So they've now copy-pasted that thing across. Keep in mind, this is also true if I had a generator that did this in both places. Because while they're working on their thing that I don't know that they copied, I go in and add a debug target to my serve target. Now I can debug my running server. This is super convenient. It's a really great convenience thing that I've built, and I want to use this everywhere. So then I end up helping them with something on their project. I see their serve target, I try and run it with debug, and it doesn't work. So now I have to go copy-paste that thing over. Even if I had a generator making that target, improvements to the generator, I would have to also go make a migration to migrate everybody's targets. That's just problematic. You end up getting these pieces of the repo that are kind of out of the way. You don't necessarily see them, and you don't have a really good way to keep them up to date. And once you go from a few targets to, you get 10 targets in every project, and you've got 150 projects, you have a lot of pieces to go maintain. So what we end up solving that with is plugins. Now, there's some extra stuff that NX has just released that also negates the need for a little bit of what we've built ourselves. But at the end of the day, we found that the stuff that was developed for Project Crystal of task inference is incredibly valuable. We've leaned into a system where we infer the types of projects. So for example, all of our Python projects have the same test target. We enforce how we do code coverage. We enforce how we do debugging so that nobody has to go and figure out how to do that. an addition on top of that would be like if we had NX conformance, we could then go ensure that everybody is using that inferred test target and they're not overwriting it locally. But that is incredibly valuable from a place of centralizing that logic, right? You don't have this chance of somebody taking a target, borrowing it, and putting it in another project, and not realizing that they've missed capturing half of their test files because they configured the target slightly wrong. The other side of that is if you're going to lean into plugins, you have to make it easy for people to add to those plugins. It can be kind of confusing if you're not used to working in NX. Well, I've got this thing that I want to do sort of across all the projects in my repo. Where do I put it, right? It's the same problem that you have of naming a thing, but it's more like, hey, I need to write a new generator. Should I also write a new plugin to store that generator inside of? And you're trying to keep things from scattering out to the wind. So we ended up developing kind of a 2-layer strata that fits in with one of the earlier presentations of sort of the 3 domains in which you can store things. And for us, it was really about language implementation. So like specifically, are you working in Python, or specifically, are you working in TypeScript? Or on top of that, like kind of the next layer of abstraction is there a framework associated with it? So we have a Python plugin, but we also have a CDK Python plugin that deals with things that are specific to CDK, but Python plugin may provide some utilities that are imported up into the framework layer so that we're kind of sharing all of that logic around. The third thing is dependency structuring. This is a topic that necessitates its entire own presentation, so I'm not going to go into it super deep, but there was a couple of kind of dangerous patterns that we discovered, and a couple of ways that we found to kind of avoid them. So the really important educational component is knowing where and when to cut things apart. How do you do surgery on a project that you built really, really quickly? For example, we end up writing things where we'll make an app, and we're going to just spin it up as quickly as possible. We end up writing a lot of business logic inside of there, and then eventually we come back to it and say, like, this app has gotten a little too big, or hey, we want to share this thing between 2 apps, or an app and a library, and so that necessitates going in and cutting that piece out, lifting it out into a library. And that's sort of the textbook case for having a dependency tree, right? I want to depend on this thing in 2 places. There's a couple of other reasons you might want to cut things apart. You might want to isolate low change code or slow testing code. That might be a reason, you might do that just for optimizing CI, but you might also do that for making dependencies simpler. You might want to actually move some of this off into a corner so it's clear that this chunk of logic actually really only has one dependency, and that should be the only reason it changes. If you end up with business logic libraries where you're collecting a lot of things together, you have a tendency to build kind of a dangerous pattern here, and that's what we call the hourglass dependency pattern, where like that thing that's in the middle could be, it could be a business logic library, it might be your database access library, but it's a thing where ultimately everybody ends up depending on it, and so therefore everybody depends on all of its dependencies. And you don't so much have a graph as just like a bunch of lines that all cut through the same point. And so that in itself creates a problem for dead code elimination when you're in a language like Python that can't actually tree shake. So we had this with our Python libraries where we actually had a dependency on a single database access library. And it had a pattern, it had all the patterns for accessing all of our tables in Postgres. And we ended up having to slice the thing apart vertically because ultimately, if you needed anything in the database, you were pulling in all of the database patterns and you were pulling in all of the dependencies of that library, even if you really only needed a tiny sliver of it. So figuring out places to cut vertically was an improvement for us when we didn't have dead code elimination. Now, all of this sort of loops back around to the idea of the Greenfield, which is that we've now figured out where some of these little trip hazards are. We know, because we've sprinted through this field, that these are things we have to watch out for. But this is only valuable if you're the person who's run across that field. You have to make sure that you have some artifact, something that tells people who come after you, hey, don't go that way, go this way, right? And so what we've realized is there's a few fundamentals that make that knowledge part of not just your team's culture, but also build it into the code base itself and the way developers use the repo. First of all is that you have to make things convenient. You have to make things low friction, self-serve, and on demand, right? You can't have a committee that meets once a week to approve names because you're going to slow down the rate at which you can add things to your repo. You should document things. We should all document everything, right, if we had the time. But more importantly is with conventions, document why they exist, not just that they exist. Once your team has discovered, like, hey, we're doing this thing, we're naming things, and we use these suffixes on our project names to indicate end-to-end, and these are APIs or whatever, give some reason as to why you ended up there so that someone who's completely new and doesn't have all that context comes in and learns the reasoning that got you to that answer so that when there's something that doesn't quite fit in there, they can make a decision that puts them in the realm of possible rightness, and they're not just guessing like, oh, we have these 3 things, I'll just make a 4th one, and I don't see any reason why we couldn't have a 4th. And ultimately, that's all in service of solving problems before they come up, right? You want people to make the right decision so that you're avoiding scattering to the wind there. This leads into documentation maintenance, right? You have to invest time and energy into documentation, but written documentation is fine. Code as documentation is better. And we talk about that. People say, like, code is documentation. Like, this is true. You should go read the code. But what I'm talking about here is code that runs inside your repo. Automating things in your repo as a way to document how to do them is a better long-term solution than expecting people to find a README or something in a wiki that explains, oh, well, when you're making a new project, you should do this. Because the likelihood that somebody who onboards a year from now finds that and reads it before they do the thing is pretty low. But if you've got a tool that does the thing and you can intervene at that moment and prevent them from doing the wrong thing in the first place, you improve the likelihood that your repo doesn't end up in a bad state. The last piece of this is that everyone has their own day one. So we had the opportunity of having a monorepo on day one with a bunch of engineers and showing up in a completely new company. But since then, we've hired more engineers. We're growing. We're trying to make a bigger team. You have to remember that everybody is going to have a day one with this thing. And so it will be their first day with it, and they are not going to have any idea what they're going through. So in our case, when I was setting up the repo on day like -10 sort of to the company and I was getting things ready, I also built the presentation for our onboarding class to get people into that. And that one presentation is a living document. So once somebody goes through that class, we encourage them to then go and comment in the Google Doc or in the Google Slides or go and actually just edit it, add a new slide, add some new content for something that didn't make sense to them. Because if you're the person who's joining the company, the one superpower you have is the thing that nobody else can recreate inside the company, and that is fresh eyes. You have the context of never having seen any of this before and being able to point out, like, this doesn't make any sense. I have no idea what you're talking about here. And so encouraging everybody as they walk in the door to make their first contributions be a thing that makes it easier for the person that comes after them, they're the only person that can effectively do that. And encouraging that culture of building a process and refining it from day one leads to improving things like your naming process, right? You don't want these things to become crusty and immovable. You want them to be mobile and they move with your team as you develop new processes, right? You want these things to evolve along with you. Otherwise, you're just going to leave them in the dust. They're going to become useless, and people are going to ignore them. Ultimately, all this boils down to making the right decision the easy decision. For any developer, whether they're the most seasoned, distinguished engineer or the juniorest person who just joined the team, you want them to have the agency to make decisions and work on the products because that's why you've hired them. You don't want to be sitting over their shoulder the entire time. But you want to make sure that they're not making the wrong decision, right? You don't have to course correct them every 5 minutes. Now, maybe with junior engineers, you're doing more education, but the idea is that the tooling that you put inside your repo that developers have to touch every day should encourage the right decision with the least amount of friction for them. And that's all I've got. And so I did hopefully make good on my promise that we'd have a little extra time to go out on a break. So came in a little under time. I'm glad to talk about any of these topics. In particular, if you are using Python in an NX monorepo, I would love to talk to you because I have not found anybody else who is doing it the way we are. And suffice to say, we did consider Bazel. We've had some conversations about that. So would love to hear more. If you're working in any of these spaces or anything that sort of overlaps with it, love to hear your experience as well. Thanks, everybody.
Thank you very much, Ryan Kyle. Don't ever let me live that down, by the way. I love the idea of adding tooling to support your decisions. And the main point that you made, I'm trying to remember exactly how you stated it, that documentation in code is better over documenting in some wiki somewhere. Nobody finds that. It's documentation for the sake of documentation that provides little practicality. So I love that, adding tooling, generators, plugins, and everything else.
Thanks.
Thanks for enforcing that. Sorry, I'm good. Good news. It's break time. Everybody give it up again for the extra time during break. So we are going to reconvene in 21 minutes, according to my watch, which makes that 31.
31 minutes.
31 minutes. Sorry, took away 10 minutes. You can boo me if you want. I understand. No, stop. 4:35 local time to reconvene back in here. And remember, after talks, we are going to have a panel that is also going to be in here. Enjoy your break.
See you in 30 minutes.
Like, yeah, it's good. And when I move my head, all good.
Test? Okay. Can we cue the cat pictures, please, until the room is filled with attendees? I'm not asking you. I'm asking the people if they can show the cat pictures, please, until the time is right for Nicholas to start speaking. The cat pictures for a little bit, please. Please? No? Okay, I guess we'll have to see Nicholas and not see the cats. Thank you, yes. So, as I said previously, these are my cats. Please take a picture while you can, because in 20 seconds, this slide is going to disappear to show Nicholas again. Okay, let's go back to Nicholas. Thank you very much for showing my cats. It's 30. No, you don't have to. I mean, it's 35 past. Should we give people a couple more minutes? Okay, should we call them? Oh, okay. I agree, they're adults. They're responsible adults. Yeah, yeah. Okay, I think we can start. What do you think? Yep, let's start. Okay, let's give 1 more minute. Yeah. No, not 5. 5 is too much. We have to stick to schedule. Okay, now that Michael is here, we can start. Okay, without further ado, let's welcome on stage Nicolas Bossard. Did I say it correctly?
Nearly.
Almost, yeah. I took French in high school. So let's clap and take it away.
Hello. The real name is Nicolas Bossard if you want to have fun and try to learn French. But Nicolas is also right. Okay. So, picture this, right? You worked on a large monorepo with a lot of teams. Some packages have code owners, but like some don't. Like you don't know like who owns them and what is it there. The config you generated has drifted a lot since you ran your generators, and now like everything is not up to date anymore. And then the teams come to complain about a bug in their code, only for you to realize that they don't use the recommended TS config anymore, and that's why it's just like broke. And it's hard to get a grip of the raw state of the monorepo. At Perfect, it was the same. And we wanted a tool to that to maintain health over the state of our monorepo. So first, who am I? I'm Nicolas Bossard. I'm a staff engineer at Payfetch, a fintech in Europe. I'm an NX certified expert and champion. You can find my social there. But yeah, so we had a requirement list of what we wanted out of the tool. First of all, we wanted to have a central configuration, right? We wanted to have a central, unique place where we can configure what we wanted to rule and on what project. We also wanted to have justification and approval from the platform team to opt out of something, right? We don't want to have teams who say like, yeah, I don't care about your rule, it's just like bothering me, I'm just gonna disable it. If we need an opt-out, it would need to have to be justified, like, I'm not using the same tooling as you to build, so I need something special. We wanted to have incremental adoption, like enforce and evaluate, right? We wanted something that can be like in the trial mode, and then at one point just like, okay, now like it's like blocking if you are not like applied to the rule. We wanted to have a large support of like file types and syntaxes. So like we wanted to link like TypeScript, JavaScript, JSON, YAML, but like also Terraform files, right? We wanted to be able to run per project, but also have some state that is like global to the overall monorepo. And lastly, we wanted to have rules that for some can be simple to implement and for some can be a bit harder. So maybe we could use ESLint. Who already wrote like ESLint tools in the room? Okay, so quite a lot. Who likes to write ESLint tools in the room? So yeah, well, yes, there is only like 5 hands now. So ESLint have a central configuration, so that's like pretty good. It has incremental adoption. We can have like warning and error, so that's pretty good. But then like ESLint disable, and that's it. And even if you like block ESLint disable, I'm just gonna go through my ESLint config and just like ignore the file, and that's it. So this wasn't working out for us. There is no like Terraform parser for ESLint, and building one was just like crazy because there is no AST for your Terraform in JavaScript. So that was another thing that we had to build, and yeah, ESLint wasn't working for that. Running them per project was pretty good, but then having them also global, turns out we have like to have different like double kind of like system of rules. It was a pain, and you have to know like how to write ESLint rule, which is like most of us in the room knows about that, but like not every one of us. So we realized that we needed something custom out of it, and we created a bunch of rule for that. But then, a couple of weeks ago, like NX conformance came out. And turns out it was doing the same thing that we did, but just like made by NX. So it's basically a way to like run like conformance, like basically rules on your monorepo. And I want to give a special shout out to Austin and James that worked the hell out of it to basically have the same feature set as we have, but just so that everybody can like have the same system as we did. So can we get like a round of applause for them, please? Thank you, folks. How you can get it? If you are an NX Enterprise client, it's included. If you're open source, it's free. Otherwise, it's like a paid for system. But now, that means that everyone can run the rules that we created. And let's see how you can create your own rules, right? So the first one would be like a simple one. Every single project in your monorepo should have lint. If we had to create this rule, it's because it wasn't the case. Like, it was in a really bad state. So rules look like this. It's TypeScript code. You basically like import something from NX conformance. You then define the name. So like every project should have lint, a category, and then you say like it's a reporter on a project, and then you implement. So you get like the project graph. You get your rule options. You then create like an array of violation. You loop over the project. If they don't have a lint target, I'm going to add a violation to my array with like the project name and the message. And then I'm going to return this as a high severity, like it's critical, like we need ESLint, like for like compliance and security and whatnot. And then it works. It now runs properly on every single project, so that's good. And if we like remove like the inference plugin, it successfully failed. So now that's like pretty good. We can validate that every project has lint. So now if you look at the autonomy of a rule, like what is a rule? A rule has some metadata, a name and a description. The name is just useful to have like inline in the code, but description is also like a why you need that, like explaining of like why this will exist. We found out that this was critical to make the enforcement easier to understand. It wasn't just like we know better than you. It's like we need the lint rule for the compliance of ISO, whatever, and then et cetera, right? Then you have a category, which can be like what kind of rule it is, like is it a maintainability, reliability, security, consistency, and whatnot. You can have like 3 reporters, so you can report on a project that this project is bad, or this project has an issue. You can report on non-project files, so like the ESLint config at the root is wrong, or the nx.json has an issue. Or you can report issue on the project files, right? Like the vite config of this project has an issue. And then the implementation have mostly the same skeleton. You have your project graph, you loop over them, and then you return something, right? To then enable a rule, you go to nx.json, you add some conformance object with rules, and the path to your local rule, and your options, and then you can run them. One thing that you can do is you can also filter them out. Like I can say, I don't want this project to run on this rule on the conformance custom rule project. And I can have an explanation, or you can not have an explanation, depending on what you want. And then when you run it, it just filters them out, so that's good. Another thing that is important is we can, by default, enforce a rule, meaning that if it fails, it will like fail the CI and fail the check, so that's like very hard blocking. You can also evaluate. So evaluate means that if it fails softly. So you will still have like a big block that like, hey, this is wrong, but I'm okay for now about that. And then you have disable, which is like just don't run it for now. Like maybe there is an issue, maybe like we are still working on this rule, so don't run it. Okay, so now that's good. Let's try to do something a bit more complex, right? Every TS config should extend the root one. If you worked in an NX monorepo, you know how critical this is, right? Especially like in integrated mode. So the rule is a bit more complex, but if it boils down to let's read the project tsconfig file, let's calculate the path that we expect. So we use like offset from root, which allows us to get .. until the root of the workspace. And then we check. If the path is different, throw a violation. And it works properly. Like here, you know, like it's wrong.json. It should be like tsconfig base.json. But then that should be easy to fix, right? Like, we know what the expected value should be. Like, this is something that we know the result. Luckily, there is an API for that. If you work with the NX generator, you will be at home. You'll get a tree, which is like a virtual file system in your rule. So this adds, you get your tree and a list of violation. Then you loop over the violation to like get the project. So you read the project. Then you calculate like before the path of your TF config. You update the JSON. And then you can even format with Predator. And now when you run NX conformance, it will auto-fix. So like this, automatically fix one file in the project. Now, NX conformance has two commands. NX conformance will run the checks and fix, while NX conformance checks will only check. This is just for example, for CI, when you don't want to like modify files in CI. So that's cool and all, but here's an example of like one of the first rules we wrote at Payfetch. In vidconfig, you have like a cache here, and it should be unique across the whole monorepo per project. Otherwise, like it causes some like weird issue. So this is the first rule that we built with the custom engine in the past. So to do that, we have a couple of options, right? We could look at the string, like maybe like do a string search, but then like if it's a comment and it will still detect as valid, so that's not good. Given Vite as an API, we could resolve the config, but then if you have like 100, 200 Vite config to resolve, that can be a lot of Vite context creation, and that can be super slow. Otherwise, we can maybe look at the EST. But who in the room knows EST? Yeah, who likes to use EST? Yeah, more than ESLint, that's funny. So EST is not an arc-only structural tangle, even though like it's sometimes feel like it when you try to debug it. It's not like accessory scrambled thoughts, even though like when you try to understand it, it feels like it. It's not an abstract syntax tornado, even though like when you try to read the code through EST, it's that hard. But it's an abstract syntax tree. This whole idea is that you have something that transforms a code into something that a machine can understand. EST is used everywhere, from everything that needs formatting to like understand like code basically. So like prettier, like biome, like everything use EST. But like how can I use it, right? Like do I need to have a PhD to like get like this string value from Vite? Introducing this tool. This tool allows you to like identify what is EST in like a simpler manner. Everything will be linked in this slide in the end, don't worry. So with this, I can say like, oh yeah, I have my 2 plus 4.10. I can see that I have like binary expression that also have a parenthesis expression with like my 4.10. But that looks oddly similar to something that we use on a daily basis. That looks like HTML, right? It's just not div and span, it's just like numeric literal and other stuff like that. Maybe we can use something like we do with HTML, but like for EST. Maybe we can do something like CSS, right? Like CSS can do selectors. Maybe selectors can be applied to EST. Turns out, yes. You can use ESQuery from the ES tool folks, like literally the xmascript.org provide that. And you can use TSQuery. That is the equivalent, but for TypeScript. Now, with this, you can do literally nearly everything in CSS. You can select elements, you can select children, you can even do like has this thing into this thing. And with that, you can do some pretty advanced stuff. So if we go back to our example before, here I'm looking for like all the numeric literal. And there I'm finding like the 2 and the 4 and the 10 directly. Okay, so that's pretty easy. But now if we go to the more advanced stuff, I want to find this non-module string, like cache-dir string. So first of all, I can say I want to look for a call expression that has the identifier defined config. This way, I already have the object that contains this, the function call. Within that, I want to find something that has a property assignment that has the name cache-dir. And then I want to have the string. And this way, with this, I can select in the Vite config directly the value I want. But I can go even further. I want to select the value that I'm expecting. So this way, I'm like selecting, like I would do in CSS, a pretty like defined node to say, I want to make sure that this is there. And what is interesting is that here is like a function, like define config, but what if it's just a call? Or what if it just wraps with another function? Or if it's like a return statement, it will still find it. that's the beauty of using EST to like do string and like to find stuff in like code. So now that we have the rule, like the selector, like let's use it and let's like build something. TS query provides two utilities that we use. We use EST, so that will convert code into EST, and then includes, which allows us to do like a selector and returns true or not if it's present in the code. So to do that, first of all, we extract our selector, we put it in the code. We then look at every single other project. We look at if there is a vidconfig. If so, if there is not, we just like loop over and we don't care. Otherwise, we read the vidconfig. Same as before, we infer the value of the thing that we want to calculate, the proper cache dir. And then, like we did in the live editor, we just do like an includes. And if it doesn't include, we report a violation. And now, the violation is properly reported. And next step is to write a fix so that we can automatically fix the value. Luckily, there is also an API called replace, where we can just pass a selector and just say, like, I want to use this value instead. So same here. I have my fix generator. I loop over my project. If there is no vidconfig, I ignore. And then I replace the value of the selector with the expected value. And then I write and I format so that it's like properly formatted. And now, everything is automatically fixed. And with that, I won't ever have an issue with cache dir config in Vite ever again in the whole monorepo. So what about a requirement, right? What we wanted out of the tool. We wanted central configuration. That's good, that's it. That's nx.json, that's perfect. We wanted to have justification. So pretty good, we can justify that a rule is ignored for a specific reason. And by the way, this is like the first conformity rule we wrote to like validate that every conformity will have an justification for exclusion. We wanted to have incremental adoption, so that's good. That's like enforce and evaluate. We can support a bunch of files if needed. We can run per project or globally, so that's good. And rules are easy to write because we could use YAML or JSON directly. We don't have to like write an AST for JSON or like an AST for like YAML, which could just like look at the value. So now, what about tracking over time, right? You have like a couple of options. You can use code pushup, which is open source. But also, if you already use NX Enterprise, it's included. You can also like automatically enforce rules at a time. So you can say like, you have 3 months to enforce this rule for every single monorepo, and that's it. You can also distribute rules from the cloud. So you can say like, I'm going to upload my rule to NX Cloud, and then just say like, apply this everywhere. You also have like a nice dashboard, so you can see like what rules are enabled and the status of them. You can also say, I want to see the health of this particular monorepo. So that's really helpful. Okay, but so now, how does it work in the field, right? How do we use on a daily basis a tool like this, right? So let's say we found an issue in our config. Something broke, right? Like we realized that we need to have an option for like the vtest fork options. First of all, we identify a rule to make sure like we identify like where it works, where it breaks. Then can we auto-fix? I mean, if so, we create a fix, we apply the fix, and then we enforce. Job done, right? Every new PR will be blocked, and they can just NX conformance, and then everything will be fixed. If not, we enable the rules as evaluate. We then incrementally migrate and fix the projects. And finally, we enforce. And once we are there, the issue is gone. Because this is like only one-way flow, we will not allow for a regression in the whole process, meaning that in the end, we move in a forward-only manner in the whole health of the monorepo. So what example of rule we created, right? We created a rule to ensure that you use NX Crystal properly, or that you have the right like caching input for NX, or that you have properly cache setup for like your pre-build for like code gen and stuff, or that like vtest is properly configured, that like the forks option is properly set up because otherwise it's like out of memory in CI, or that the vidconfig cache dir is good, or that the rollup option output interrupt is correctly set. Like I don't know how much of you like know about this, but like if you're in the legacy code base, you need to know what this properly is, and no one else knows in your team. So that's why like conformance rules is useful, because like the justification explain why we need that. Like, it's not magic, it's just like, here is why, and if we don't have that, this is what breaks. We also validated test config, and yeah. So today, we run about 466 rules per project on every single one of the projects in the monorepo, all under like about 4 seconds. And while that is cool, right? Like, yeah, we wrote a lot of rules, right? What about impact, right? Like, what about the actual like result of that? So we have minus 95% request support for things about like related to build issues or like tooling issues or misconfiguration. So we basically have now like once request every month, say like, hey, I have a bug on this, then conformity rule, and then no more issue. We don't have incident related to build tool anymore, which is amazing. And the only one that happened was again because we added another conformity rule to ensure that it's not breaking anymore, which is amazing. And this is a fun one. So the monorepo was in a so bad state that people moved out of the monorepo and were preferred to have like a very slow deploy time by using npm as a proxy so that they could like have a better stage. But now people want to move back because like this is way better. Now it's like faster and I can work. I want to merge back into the main monorepo. So we have like 240% increase in terms of like contributor amount. And while that seems like a lot of effort over time, it only took a year. And that was not the main focus of the team. It was just like, we found some weird issue. We incrementally upgrade the system step by step, meaning that at every step of the way, we only move forward and we make sure that everything was like done automatically. Because in the end, right, thanks to this, you put your half of your monorepo in autopilot. Like, you know how things are supposed to be configured, running, and then you're done. Thanks a lot for your attention. You can find the code, the slide, everything on the link. Thanks.
Thank you, Nicolas Bozard.
Perfect.
I love tooling. So I love to see excellent different uses and use cases for tooling.
So I think what we're doing now is waiting for the people from track 2 to come to track 1, and we are all going to gather here.
Yes. So the bad news is that was our last talk of the day. There is more stuff. We're not all done with the day. Jeff is going to be coming back up on stage for a panel. But don't wait, he's asking questions. We don't have to listen to his answers and his thoughts. You're welcome. I got you. So we're saving people from you. That's what we do. However, the two other MCs will also be back in here momentarily whenever they wrap up over there. Jeff, how many chairs do we need? One more? Oh, did you add some? Oh, I like that. No, we leave that one separated. We can leave one separate. Do you want separated, like almost on the side, or are you standing? Okay. Semi-circle? Like an arc? Okay. Yep.
Okay.
Here, we want to center it, though, right?
Is this okay, Jeff? Good.
Bring one down. You said one more?
So, how have you liked it so far? Good, good, good.
Jeff, are you ready to reveal any of the songs you may be singing this evening? You're not ready? Okay, that's fine. Do you want to pick any songs for Mike?
No.
Okay. On that low note. Also, we've been talking about the Raffle giveaway. I can't announce it until other people get here, but I do have the winners. Huh? Somebody named Jeff? No. Oh, wait. Nope. Sorry, that was a different list. It wasn't.
No, wait. I think Jeff won all the gifts, all the raffles. It was totally random, completely random, but all the gifts go back to Jeff, I think.
Oh, well, that's good, because the online gifts, for those of you watching online, will be, I think you're going to be emailed directly. So, huh? Oh, you're going to email it? Okay. Yeah, we're going to take that out of Jeff's hands. and and we'll contact you about the, I believe they're Keychron $100 gift cards.
Funnel, no.
Can I stand and hover over you? Maybe like rub your shoulders or something? No, thing is no. Okay. Have I been disinvited to the party yet? Yet? Yeah, but every time I said something mean and nasty to you, you gave me nodding approval. My kids hated.
So it seems like the track 2 concluded the talks as well, since I see people coming.
I see people. Yes, but I won't know for sure until we see the MCs come in.
That's true, that's true.
That's going to be my sign, and then we can ask them, hey, has everybody made it yet? Do you need enough handhelds? What was that? Are you?
we're slowly all gathering here, right?
Dom. Mic 5 seems to be off.
I don't know if they see me. It sounds pretty hot. Hello, everyone. Welcome to the finale of day one, Monorepo World. We've got, I don't know if you've heard it all, but we have some prizes. Did you all
What?
know? Have you all heard? Yeah. I mean, I probably drove it into the ground in my room. I apologize. I was just really selling the QR code a lot. Were you? Did you?
No, we were selling the party. Open bar?
Yep.
Can I get like open bar? A round of applause for open bar.
Hey! Oh, we
That
definitely.
sounds like there's short lines for me.
We have some prize winners, but you do have to be present to win for the in-person ones. Are we announcing online winners, Mike?
We are not.
Okay.
I did say that we will get in touch, or they will be gotten in touch with for the winners of the
Correct.
$100.
They will receive an email.
Okay, so if you're online, you'll receive an email if you're one of the winners. But if you are in person, please make a whoop, a holler, come up to the stage and make some sort of noise so that you can come and get your prize.
I'm still a little confused.
Why?
Can you explain or demonstrate a holler?
Woo!
That's different
Okay.
from a woo?
Maybe holler is woo. I don't know. If somebody in the audience knows, they could
Just
tell us.
looking for clarification.
Also, you hear the music? This is, Philip promised me he would show you all his line dancing while we call names.
Okay, I'm going
I didn't.
to.
My microphone, I can't engage. My microphone isn't working. But also, hey guys, do we have the prizes somewhere? Where are they?
I don't know if we have the prize. Or you're
on,
going to
Ian.
fetch? Okay.
Ow! He actually can do this. I cannot. I'm making it. Oh, yeah. See?
Okay.
All right. Who is our first? What's the first prize we're giving
Well,
away?
are we going to wait for the prizes to get back? Is my mic on? Can you guys hear me? Thank you. It's highlighted. Do we want to wait till the prizes get in here? Like, do you want to be handed a physical prize, or do you just want to go, thanks? Is the photographer in here? Does he want pictures of prizes?
That's a really good question. These are all really good questions.
I'm good with the questions. We're struggling with the answers.
Here's what I think we should do. I think we should start calling names. And I'm just going to have you stand up here, and we're going to pretend you're part of the panel that's about to happen.
But I do want to be fair, though. Again, you have to be present to win.
Yep.
Well, good, we have prizes coming in. But what I will do is I will give everybody a second chance. So we'll go through the names once. If we have people that don't respond, then we'll go ahead and start at the top of the list again with a second run through. If you're
That's a lot of chances. I'm not
Right?
feeling
I'm
that
trying to be
favorable,
fair.
but all right, let's go.
But if they're not there, then we're moving to the secondaries.
Let's start it. All right.
For the JM Bricklayer Vintage Set, hold it up. Thank you. From NativeScript, the winner, and I'm sorry about names if I mispronounce, Alex Lenner.
Oh, I heard it.
You got a woo.
I got a woo. Come on up, man. Oh, to the very middle of the stage.
No, you come up. No.
Oh, I'm so sorry. I'm making you do so much cardio in this moment. Apologies. That's actually really cool. Ow! All right, what's your name?
Alex Leonard.
And how long have you been developing?
12 years.
Welcome, welcome. Congratulations on the, what is it again? Oh, I'm so jealous. All right, thanks, man.
I will say that the next prize is the autumn candle basket, but
Autumnal.
It does not say autumnal. It's just autumn candle basket.
Did you?
It says autumn there. Earlier sources said autumnal. I wasn't just looking for an opportunity to say autumnal.
I'm pretty sure it's just an autumnal basket.
This is also
And I think these are handmade from someone's partner. I think from here.
Oh, that's so cool.
Yeah, it's very cute and they're very beautiful. So, give us a name.
The winner is Heidi Grutter.
Woo!
Was that from
Heidi Woo?
Was that just from people who know Heidi, or was that actually from Heidi?
I think we see a Heidi.
We all know Heidi.
Oh, okay. Cool. Come on up.
To the middle of the stage, please.
The middle, darling.
Please come to the middle of the stage.
To receive your autumnal basket. Amazing. All right, what's your name?
Heidi.
How long have you been in the dev world?
About 5 months.
Awesome! Give it up! Yeah. Welcome, Heidi. All right, what's our next prize, Mike?
The next prize, excellent product placement, is the Stratocaster Lego set from NX, and that goes to Alexander Agriwan. Look left.
Hey,
You got stairs on your side, my friend.
Now, are you a Legoer? Do you do the Legos?
Kids are.
Your kids. All right, what's your name?
Alex,
And how long have you been in the dev world?
25 years.
Nice. Congratulations on your prize, Alex. Thank you.
Our last prize is the Tuxedo Cat Lego set, also from NX, and it comes with the bonus of we will try to protect you from Katerina so that she doesn't come abuse you to try and get that, to take that home herself.
That's a big promise, but
I know. We'll do our best. No guarantees. The winner of the Lego Cat set is Sarika Kale.
this is the first time ever Mike and I have done a prize draw, and every single person was present. Amazing. 10 out of 10. I love it. I mean,
same.
Awesome. And your name and how long you've been in the dev world?
My name is Sarika. I've been here for 7 years.
Awesome. Well, congratulations on the cat.
One last thing. Everybody, great job today. I've heard nothing bad in terms of the code of conduct. But I want to remind everyone that the code of conduct is still in place for tonight. Tonight is a safe space, and it may be harder with the open bar. I understand. But do your best, and please be respectful to others and have a great time. So that concludes all of our activities on stage, and the four of us shall wave goodbye to you. But we are going to bring up Jeff Cross, who's going to introduce the rest of the panel discussion for the conclusion of Monorepo World.
Thank you, Brocky. All right. Okay. Thanks, everyone. I know it took like an hour to do the raffle drawing, so we'll try to make this as worthwhile of your time as possible. I'm going to quickly introduce, I've got a panel of friends of mine that happen to be tool builder geeks. You're not a friend? Friends of mine, plus Sam and Victor. I'm a friend. Okay, thank you. Sam, you can. People who work on interesting build problems. I'll give quick introductions. Victor was born in Vladivostok, Russia, has been a software developer for at least 2 years.
At least 2, yeah.
At least 2 years. Grew up on a potato farm. And this is Lois, who also grew up on a potato farm in South China, now lives in London, and works on RSPack and Module Federation and Zephyr Cloud and interesting things. Victor works on NX, I forgot to say, but then Lois works on these interesting things. This is David from Trunk, who also grew up on a potato farm and used to work at Uber. He did not work at Google. He made sure to tell me that he was embarrassed that I even thought maybe he had. But his partner did. So we've got a lot of former Googler representation here. Then we've got Sam Ciccone, a current Googler, and works on some such interesting things. And did you grow up on a potato farm? He grew up on a potato farm in Ohio, Toledo, Ohio. Has been also for at least 2.5 years doing engineering, software engineering. 1 year, okay. And finally we have Alex Eagle, who grew up on a potato shop. They sold the potatoes. Sam made them, Alex sold them. Also from Toledo, right? Yeah. That actually is true. Everything I said was true. But I'll get to it. I've got some note cards here with some questions. And by the way, feel free to speak out if an answer wasn't good enough for you. We're not doing open Q&A, but it can be interactive. Like I'll start with something that maybe Alex can speak to, and he's definitely going to give a bullshit answer, so you should call him out on it. What's the deal, Seinfeld voice? What's the deal with multi-repos? That's it. No, so we're all monorepo fans, I would say. I mean, like, we've all come to appreciate the good properties of monorepos, but you know, we all work in the real world where I can't think of any of our customers who actually have a single monorepo unless it's a smaller dev team. Alex, what are you seeing? You're building aspect.dev, you're working with a lot of these big enterprise teams. How are they taking some of the ideas like trunk-based development that work easily in a monorepo and applying that to a multi-repo or polyrepo or omni-repo, as you were trying to convince me should be the better term?
Monorepos are great. We are at Monorepo World. I did have some slides I struck from my deck because I didn't have time to describe a couple of issues with this terminology, right? One of them is mono means one, and we all agree that companies are still going to have more than one. And also that it's become a little bit of a religious thing where, you know, we're here at Monorepo World and some people are not. Probably everybody who's not in this room thinks monorepos are a bad idea, or, you know, they've tried it and they don't like it. So I think there's a little bit of a branding issue, and I'm not exactly sure what we can do about that. We can continue to educate people about when we say monorepo, we don't really mean you're going to have only one in your whole org, and maybe that's fine. Maybe there's some other term we could use.
And Alex lectured me for about an hour about this earlier, that I'm doing harm.
He talked to me as well. He
Yeah.
talks to everyone about it today.
Well, that's just today's project, but tomorrow we'll have something else, so don't worry, just ignore me for a few more hours. No, I mean, I'm obviously kidding. I think omni's a good word. We'll see. Of course, companies do have multiple repos, and there's a lot of problems that they can solve by coming to one repo. I think there's been a few talks today about you can give some of the benefits of trunk-based development without having to actually move all the code into one Git repo. We also heard from someone at GitHub who said, please don't put all of your code in one Git repo. So there has to be an answer to this that's not everybody does a single repo for their whole org, or that you can't have multiple repositories and still do trunk-based development, which I think is really the core of what we all want to do.
What is trunk-based development for purposes of this question? I asked it, but I want to know what you're talking about.
I feel like I could defer to someone with a trunk shirt.
I named my company after it.
Oh. I think I forgot to mention companies, by the way.
Oh, well, yes. So I'm the co-founder of Trunk.io. Trunk-based development at its core is a very, very simple concept. I'm assuming probably everybody here knows it. Everyone knows what trunk-based development is? Everybody knows what trunk-based development is. But for those who don't, the concept is simple. You push and pull from a trunk branch. Don't have a bunch of long-lived feature branches. Don't have, it's really a branching strategy at its crux, but it's the core of any good monorepo, that you be practicing trunk-based development where everybody is pushing and pulling from the same main or master or trunk branch. And that thing is the source of truth. It's always checked by unit tests, by code checking tools, et cetera. And you can trust, ideally, that the latest commit on that branch is good, is not broken. and passes standardized checks no matter what you're working on in your company's repo.
Alex, are you happy with that answer?
Yeah, that was good.
I'm happy with it.
Great.
Kind of on the same, I'll actually go to you, David, because you work on tools that are kind of just outside of build system. So for large monorepos, which you've had some experience in,
yes.
What tools beyond the build system are needed? And let's say like 1,000 plus developers in a repo. Like what starts to fall apart that you need more tools for, and how do they need to be different?
So many things fall apart. So I think that build systems, including NX, are expanding to be sort of more than build systems with things like conformance and things like ownership systems that manage code ownership and compile into a code owner's file. Those things are definitely all needed as you scale a monorepo, or scale a repo in general. It becomes harder to know who owns what, who you go to for problems, that across the entire repo everything is actually standardized. What we see predominantly with very large repos is even when they have a monorepo build and test system, they're using NX and Bazel or Buck or whatever, they're not using that in the whole monorepo. So there's sort of a need for a level of tooling that is beyond that actually encompasses your whole monorepo to buy you some standardized CI jobs, testing, ownership, code quality checking, code security checking. That's wider than just the build system.
Cool. Sam, well, actually, I'm going to give you a break for a second. I'll ask Lois a question. You work on module federation. We've seen this become kind of a key thing for a lot of enterprises. How have enterprises changed how they build and deploy apps now that module federation, specifically front-end applications, now that module federation is a new way of being able to deploy? Maybe why and how is it different? You've got 20 minutes.
To clarify, I grew up next to the Phoenix Mountain, not potato farm.
On a potato farm.
Okay, a potato farm next to the Phoenix Mountain, fair. Yes, so has anyone experienced merge freeze? How often? Like, module federation can help you split your front end into components that allow your individual team to ship component level code. So no merge freeze and ship faster. But with Zephyr, it's more like, should I sell Zephyr? Like, oh, my boss is recording, I'm scared. Is it gonna hurt my KPI like Jeff?
Yeah. It'll be nice.
Yeah. With Zephyr, we do versioning your code, your front end on component level. You can roll forward and backwards on your front end. Say you have multiple versions of navigation bar, and you can roll forward and choose hot swap in production and check which one you like and push it. Done. Simple, 20 minutes.
Does anyone reject that answer? Okay, you passed. Well, no, not a single laugh. Alex, can I get a laugh? Pity laugh?
Aha, gobble, gobble.
Okay, thank you. You've satisfied your commitment. I'm going to ask Sam a question. You work at Google. Google, as many people know, last time I checked, it was one massive monorepo that pretty much everything in the company is inside of, with a few exceptions. One of the byproducts of that is some products get neglected, abandoned, or just unmaintained so much, and especially at Google, where they cancel everything all the time. How do you manage keeping an evergreen repository with legacy code around in the same code base where it might be affecting your builds, it might be affecting, like you might need to update things that you have to then update legacy code. What pains do you see with it, and how do you deal with it?
Great question. What? Oh, hello. Yeah, good question. How do we deal?
Take your time.
I would say that in a code base that spans, so I work on Android and Chrome mostly, and that code base is a decade old. Each code base is a decade old. And so it turns out that a lot of that code was written a decade ago and hasn't been touched for a decade. And the people who wrote that code are gone at a different company or working on a very different product. And when you ping them and you say, hey, your test is broken, and they say, what test? And you say, this one. They say, the code that I wrote in 2007? Like, yeah, that. What is this line doing? They say, I don't know, good luck. And they go away.
Sam is the most blocked person on Google Hangouts inside of Google. Is that right?
Yeah, most people have go/no hello. They just say go/no Sam.
Yeah.
It's true. So how do we deal with it? I think ownership is key, but also sort of diffusion of ownership in the sense of you broke it, so you touched it, you broke it, you have to figure out how to fix it. But this can result in sort of paralysis of a code base.
So, as opposed to the person who originally authored it.
Yeah, it doesn't work. I think it works if you're talking inside of a time frame of like a year or 2 year in your code base. Once you go past that sort of 5-year barrier, things becomes important and driving change becomes important, but then how do you actually convince someone that they need to fix the code that they didn't write? And usually it's a pre-submit system. It says, hey, you can't submit unless your tests or builds are passing, and then they have to figure it out. And then sometimes they say, I don't know this code, it's not my fault. Then they escalate up, and then they find a manager who used to historically manage that person who's now on a different team, and then you do the political maneuvering, and they eventually fix it for you. But it's complicated, and I'd say there's no one surefire way, but the best solution has been a pre-submit system that prevents people from breaking the tree. So that's the ultimate arbiter of maintenance or lack of maintenance.
Yeah. Victor and I have felt that pain on the Angular team, merging in Angular changes into Google 3. Lots of projects depend on Angular, and not all of them were maintained, and we had to fix those. But moving on, David, I've got another one for you.
Sure.
Victor, I might bring you in at some point.
I'm happy just to sit here.
Okay.
I feel tired. It's great.
So one of the things you work on is it's called the merge graph, right?
Merge queue. It can function as a merge graph.
It should be a merge. It should be called merge graph.
It's a merge graph if you're using NX or Bazel or
a good tool.
A good tool. That's right.
How are you seeing that evolving? Like, we see it a lot with the companies we work with, that they're always looking at ways to, especially as teams get bigger and changes pile up, to get merged after they've already been tested. What are you seeing as the state of the art now?
Well, a merge graph is the state of the art. The interesting thing is, I think that after GitLab and GitHub came out with their merge queues, which happened in 2020 and 2022, they didn't actually get a ton of adoption by monorepos at scale. They've gotten some adoption, and we come across a lot of users who adopt those in smaller monorepos with 20, 30 developers. As you scale bigger, merge queues don't really, they introduce more of a slowdown into merging your pull requests than if you didn't have a merge queue. So a lot of developers don't really like them. There are strategies to leverage the dependency graph from NX, Bazel, and other things to make it really quick. And so what we're seeing is, instead of having a post-commit job or post-merge job that tries to figure out what you broke on your main branch after you merged it to your main branch, as companies scale, they do want, one of the things that they want is to just ensure that the main branch is always working. So you can kind of have the best of both worlds. We are seeing more mid to large size monorepos adopting merge queues now that there's Trunks merge queue that actually scales to hundreds or 1,000 plus engineer monorepos. But prior to that, it was really just big tech internal merge queue.
Yeah.
And I think that's a lot of the theme of monorepos in general. A lot of big tech companies have made very successful monorepos by investing very heavily in internal dev tools, and only now are we barely getting to the point where there are commercial options to buy most of the suite that big tech companies have built for themselves internally. And for the most part, if you're starting a monorepo today or you're scaling a monorepo today, you're not going to invest the next 5 years with 20 people plus to build internal dev tools to make it actually work. You just need to buy something that makes it work now.
20 plus. Google would laugh at 20 plus.
Or 200 plus, whatever.
Thousands.
Yeah.
But yeah.
I do wonder, so when you reach 1,000 developers, I think a merge queue, a submit queue can make sense, but in our experience, my experience, I guess, the trade-offs for velocity, it just doesn't make sense until you hit a rate of, well, it depends on the shape of your monorepo, but like 20 to 50 commits every couple hours is when it starts making sense to avoid integration failures. But I'm curious, especially from people in the room who've like done this 1,000+ developer space.
Things are getting heated over here.
Whoa, I have things to say about
this. Series of trade-offs, right? It's all series of trade-offs.
Nope, no trade-offs.
So we've dealt with a lot of our users using merge queues at around that space. And in general, it actually doesn't depend so much on the number of developers, but it depends on the interconnectedness of your code. So if you're all working on the same mobile app, we see this in mobile apps really commonly, the need for this, where large companies' mobile apps have 100, 150 developers working on just their iOS app, and then another 150 on just their Android app. And they're not really hitting that velocity, but they are hitting the need for a merge queue constantly. Also, if you have a company culture where you don't duplicate code and everybody's sharing the same libraries and there's more interconnectedness of code, you need a merge queue more. And if you have more of a culture of not having those properties and everybody's sort of rewriting the same functionality in different parts of the code base, which I would prefer that nobody did that, because that's one of the benefits of a monorepo, is to have that interconnectedness of being able to reuse components that other people in the org wrote. But if it's not that interconnected, you don't need a merge queue so much.
So you spend a lot of time on this. Is there, like, do you have blog posts or something for people to look at and be like, okay, how should I?
Coming soon. After this conversation, it's coming soon.
You better.
Can I ask a follow-up?
Oh, geez.
Sorry. So no. There are definitely files and types of testing, like screenshot testing, that create this code rigidity. So if I make a change that updates the widget to blue, and Alex makes a change to update the widget to green, as he always does, I get this conflict. It's like, you broke my pre-submit, but we were both right independently. And so like either there's a serialization point, or we both submit at the same time, and then we get something weird.
Yeah.
Like there are definitely technologies and architectures where you have this concept of hot files. Where we've done is like you write the analysis, you say what lines, what files change constantly, and you go back to the engineers and says, hey, it turns out you have a manifest.xml file that literally every change has to touch. Fix that. So I'm wondering in this monorepo space if we chase technology as the fix, like architectural or non-architectural technology as fixing it, versus just going to the developers and say, hey, you have a hot file that 90% of your engineers touch on every pull request. And the trade-offs there are very different. It's much cheaper to say, split your XML file.
Yeah. No, I mean, I think that's a great point, actually. And I think there's actually a lot of opportunity for maybe the people in this room internally to do some work to figure out what the hot files are, or for one of us to invent some tooling to tell people what the hot files are and try to mitigate the problem at that level.
Victor, do it before Alex does. All right, thank you. I've got one for Victor now.
All right.
This is a little confrontational.
Ooh.
So why is NX getting into polyrepos? Are you giving up on monorepos? Why are you a coward?
Yeah, that's a good question. And I think what Alex said is correct. We actually discussed for many years what to rename monorepo to, right? Because no one has monorepos, a few companies aside. Alex has fewer repos, which actually I kind of like. Right? You have fewer, bigger repos. But the idea was always about graph-based stuff. So if you have graphs of nodes with edges, with dependencies, with like invariants and assumptions about them, you can do something with this information, right? This information could be within the same repo, at which point you have stronger things you could do, easier, right? It could be across repos, so you cannot do all of this stuff, but you can do some of the things kind of eventually, right? For example, if you think about the polyrepo case where there is a, I don't know who should look, let me look at you, right? Because you ask the question, it just feels weird talking to the void, right? This is like my therapist, right?
How does that make you feel?
A little bit scared, but so there are like three parts. Like you have visibility, where you show the interconnectedness of the repos, right? Kind of like giving you the same type of information as in a monorepo case. There is a graph, it's just some edges have a different relationship than others, right? Because they are not bound by the same invariance, right? And then you have control, where you can say certain changes have to propagate through those repos in a particular way, right? And then you have automation. And that's sort of what we really want to do, is to say that some of the properties of the monorepo that I can make a change, and I, for example, can verify that it's safe to make this change, in a system, right? In principle, you could do some of it in a polyrepo case. If you make a change, you can apply a PR or code change, and you run not all the repos because it will be too expensive, but like a sample, right? To just have a kind of probabilistically say that most likely safe to integrate kind of stuff, right? To give you some of the feedback early on. It's not as good as running the same monorepo, but obviously some of the gains are there. Why is that important? Because as Alex said, and as we all know, no one has a single monorepo. Most organizations have a bazillion repos, and what we are telling them currently essentially is like, well, if you want to see the greatness of this way, invest into it, and then maybe a few years, or like a year from now, you'll see a bunch of repos together, and good things will come, and yada yada, right? And I strongly believe that developers don't like things in the future. They would like to see the greatness a week from now, right? If you show them just a little bit of the greatness, right? But like within a few weeks, right? In 2-week POV, you show them some properties that are there, something that they could do. Within the 2 weeks, they're already kind of happy, and they could see that they can merge some of the repos together, etc. Right? It's about this immediacy and about giving you something and asking nothing in return, right? So I actually think it is the true monorepo. Like the whole world is a monorepo, right? In this case, that was another thing that I think Gilad Bracha or someone from Google, I think he was talking about it, that pushing changes to every client in a distributed fashion, pretending that, okay, that doesn't work, okay? But like if you like reduce it to an org and you kind of squint and pretend that it almost works, you get some of the nice things.
That should be NX's motto: squint and it almost works.
But no, the point is, sometimes almost works is kind of good enough. If I tell you that, there is a high chance that your code change is safe, it's not a guarantee, but it's it's pretty certain. So when people integrate those changes later on, right, the most likely they won't have an issue. It's kind of good enough, right, for a lot of organizations. It doesn't have to be 100% guarantee, right, because nothing is shipped to production after this is released. They still need to update to your version. You just weighing the likelihood of this update being painful or not, right?
Sam, counterpoint?
Well, I feel like this conversation, we're skirting around this problem of nothing's actually a monorepo. It's a collection of individual repositories. And the question I will ask is why are we splitting repositories in the first place? And like my experience,
that's the starting point. That's the starting state of most companies.
Yeah, so it's actually a good question.
Well, why not shove them together? And like what we hit is Git doesn't scale, Git hosting falls over.
Oh, you sweet Googler.
Yeah. So.
Well, so why? Like why are we investing in building kind of supporting infrastructure to enable the non-ideal state versus fixing the core problem of Git?
No, it's a good point. So I agree that it's a sort of in general, yes. If you build like across the board better tooling that support blah blah blah, lots of nice things happen, right? And you can say there are organizational reasons, people in London do like blah blah blah. So like all of those things. But even bracketing, imagine there are no organizational reasons, right? They're like, they all want to be together, right? And there are no technical reasons. The tooling is there. The GitHub is mighty or something like that, right? And it just all works very nicely. We're just in a place where they just happen to have 1,000 repos, right? Like it would be nice to say, like, why don't you just merge it together? And maybe that is the path, but you want to give them something cheaper so they can see, oh, things are nice already, and maybe then consolidate, right? I don't think it was a mutually exclusive thing sort of stuff, right? So
isn't that Git submodules then? A single Git repository with pointers?
Oof.
How dare you?
Well, we agreed not to mention Git submodules. So. But in general, I think that what you're saying is true. It's about, in how I think about it, is if you have a messy real-world situation, like the tags law that sucks, you can say, how about we just take this tags law, throw it away, and rewrite it from scratch, right, or something like that. And a lot of the times, people are like, I would like to do it, but it kind of doesn't work, so we have to go a roundabout way. And it will take 100 years, but the first way is just not practically available to us.
Yeah, let me throw one thing in. I just want to make sure there's not a misconception going out here about Git doesn't scale, right? So I think there's several orders of magnitude of sizes of a repo, sizes of an organization, in between the point where it makes sense for these teams to work together, you have 40, 50 engineers, Git is fine. All the way up to you have 400, maybe 4,000 engineers. Git is still fine. Like Git works to a fairly large point. You have to be one of the big tech companies to get to a point where like, and there are things you should be doing, like Git scaler is a good call out. You should be like doing Git GC, you should be removing refs, you should be preventing teams from adding a tag every time they do anything to keep Git fast. But if you do those steps, Git will last you quite a long time. So it's really, this is not like a, you don't do monorepo because Git doesn't support it. Git does support fairly large monorepos.
Yeah, I agree.
All right, we're over time. I want to thank my distinguished guests here and Victor. Get it?
Down.
As well for listening and for a great day. I don't know if the MCs are coming back up or if I should just give the benediction. Okay. Really appreciate it. I know it's a big deal for people to travel and even just to take a day from everything else you should be doing to come here. So we really appreciate the time. For those of you in person, we also have tomorrow, for those of you here who use NX, we have our NX Enterprise Summit tomorrow, which you're welcome to come to, which is like, it's just more informal version of this, nothing recorded, a lot more roundtable discussions, some presentations from the NX team on more advanced topics. It's a good fun time. So please join us. And then of course we have the party tonight at 8 o'clock right here with all the fun stuff that's already been mentioned. So. Sponsors, thank you so much, especially to NX.
Jeff, doesn't that feel a little self-dealing?
Sometimes I forget I work at NX. Thank you to all the sponsors. I don't want to miss any if I try naming them, but they're on the website. Trunk is one of them. I don't know if you ponied up any cash for a sponsorship.
My valuable time.
Okay, yeah. Okay, sponsored in kind. But thank you, everyone. This is really exciting. That it seems to be entertaining. I'm glad we had a little bit broader stuff. We had our Bazel friends today to show that different build systems can be friends sometimes. And anyway, thank you. Thank you so much for coming today.
I have one other thing. Sorry. Yeah, pictures. If you were a speaker, please come up to the stage to get your picture taken. And NX team, stick around because we're also going to have you come up for a picture as well. So speakers on stage, please. Not Jeff. Your boss, Zach. Did he get you the Calendly link for Angular Error?
Yes.
He did? Okay, perfect.
Why? Do you want me now?
Yeah. Change it at all. Come on.
Sure.